That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Hi everyone, I'm Ravikumar Buragapu from Adobe. Thank you so much for joining this session, and first of all, thank you Percona for hosting my session on database resiliency as a part of Percona Community Live on all the 4 prominent streaming channels: YouTube, LinkedIn, Twitter and Twitch. So today's my topic is on database resiliency for mission critical computing. So the key topics of my session are to go over with you on essentials of database high availability and various options of high availability database architecture for making a diligent choice and decision based on your technology and business needs, and how do you accomplish operational resiliency regardless whichever database architecture you have chosen to attain high availability. So the key takeaways for everyone attending this session would have a deeper and a stronger understanding on the key paradigms of database high availability, and as well as the principles of database high availability and various options from architecture perspective to choose and make a diligent architectural choices against your needs, and as with keeping the cost and complexity in mind, as well as I'm talking about the total cost of ownership and as well as the complexity of each solution, which one suits best for what technology and business needs, and as well as very importantly, how do you even attain operational resiliency, the key paradigms of the operational resiliency aspects, how do you handle those? So with that, I like to start off the session with a foundational understanding on CAP theorem. Essentially, CAP theorem states that it's not possible to guarantee that all the 3 of the desired properties, which is consistency, availability and partition tolerance, can be attained at the same time on a distributed system wherein there is a data replication. And the theorem also states that network-based systems can only strongly support 2 out of the 3, the key paradigms of CAP theorem. So essentially, CAP theorem is very crucial and critical for architects and designers to make the decisions on the trade-offs. So coming to the trade-offs on consistency versus availability, right? So high consistency, if that is what the desire for the desired system, it comes with the cost of lower availability, right? If you are looking towards building out a high availability systems, it comes with the cost of lower consistency. So keeping this as a baseline, the consistency, availability and partition tolerance and the trade-offs in mind, how do we even make a better architectural choices in order to build a right scale architecture to attain highest resiliency? So let us look at the principles of database high availability. I just wanted to be very cautious here, not to boil down the entire ocean of all the principles of database high availability, but I would predominantly touch the prime or the 3 key principles to attain high database availability. Number 1, how do you eliminate single point of failures, which including how do you stop propagating or not propagating the failures in a global database infrastructure, which is essentially by adding the redundancy. So when we are building a database design and architecture, it is very crucial and critical to ensure that there is a redundancy being designed as a part of the system architecture itself to ensure that there is no single point of failure exists in any database system. 2, reliable crossover. Though you have redundancy built for all of the sources of the database system, unless we build a reliable crossover, meaning in a redundant system, the crossover point should not become as a bottleneck or it should not become as a single point of failure. For example, the routing between the primary system and the redundant systems, say through a load balancer, a ELB, ILB, or ALB, or a network load balancer, any of those should not become even as a single point of failure. We need to ensure that the crossover should also have redundancy, or they are pretty much reliable to perform, to give highest resiliency. And to avoid failures, and the fault tolerance system must have to be a dependable crossover, and at the same time we need to make sure that they are near to real time to give a seamless and consistent experience with automated switchover mechanism. So this is very crucial and critical when we design a system or when we architect a system, that not only we are avoiding a single point of failures, but the crossovers for the redundancy also needs to be highly reliable, and they should not become as again a single point of failure. So third principle is failure detection. Though it appears to be that I avoided any single point of failures and having a redundancy, and I have a reliable crossover, they not a single point of failure, it appears to be that failures are minimal or negligible or none. Not really, but it is essential to have a diligent and a deeper observability to detect the failures in a very proactive manner, so to make the decisions or design the system to an extent of self-heal, auto-heal, or build the options towards the resiliency against critical failures. So these three are the key principles that needs to be considered when we design or when we architect any database solution, right? So we know the trade-offs between availability and consistency, and we understand what are the key paradigms that needs to be considered, or principles that needs to be taken into consideration when we build a high availability system. And then let us look at what are the various architectural options out there for us to make a better choice, which suits best for what level of scalability, resiliency, availability. At the same time, these solutions would also require to have a conscious decision taking in consideration of total cost of ownership, and as well as operational overhead, also the complexity in managing those systems. So I would like to touch upon the key architectural choices for building out database solutions, and these database options or the architectures are pertaining to the flavor of database solution that you are trying to build out. Is it Percona MySQL, a wonderful database solution option, as it comes out with various of the wrappers, considering everything that I am talking about necessarily, such as high availability principles, to the trade-offs between availability and consistency, and outstanding support, right? Or open source MySQL, or SQL Server, or Oracle, or Cassandra, or you're building out a Mongo, to global databases such as Google Spanner, to Amazon or AWS Aurora. So they are pertaining to the different flavors of the solution. There are specific configurations and setup that require in order to build out these various of these architectures. I would like to start off with master-slave replication, and what does it mean? At what level of what scale of solutions master-slave is best suitable for, and what are the pros and cons to choose master-slave as the best option or a solution to go with for you to make the decision, and as well as when do you need to consider master cluster, where you have high availability, high performance as a consideration, and a group replication, my favorite, which allows you to build out highest resiliency and fault tolerance and high available systems with fully managed cluster group replication mechanism, to building out global scale databases with multi-master Galera replication. So let us start off with master slave, which is a single master replication, in where the data replication is done in such a way that only one server manages the master table and makes the updates and changes required. The copy of the master table is replicated to slave servers, or who are all the consumers who are authorized to view, read and search data from the slave nodes. Any write operations instructed by the consuming systems are transferred to the master, and the changes correspondingly that are demanded. Hence, we can infer that these applications provide slaves with read-only feature and where the writes are done only by the master. Master-slave setup is used a lot for speeding up the reads at remote. But in an event of an outage, reads continue from the slaves, as we have the ability to spin up the slaves across the network as a multi-slave or a layers of slaves. But the writes are not continue to have the seamlessness during the disruption unless we built a diligent automated failover from master node to the slave node. But as in the master slave architecture, several mutation requests to different nodes can't update the same data at the same time. That as the being as a limitation. However, using the technique of sharding, right, the data can be divided into groups of keys, allowing one or more master to control a known or grouped set of keys as an alternate to the master slave strategy. And master slave solution is best suitable for controlled or scheduled write systems, but where the data consistency is a key for the read operations. What I mean here is, let us take an example of a pricing system or a promotions or an offer system. If your desire is to have the data required to be consistent across the nodes, either throughout the network or geographically or multi-site, the reads from the reads standpoint, it required to have highest consistency. Here, consistency is the key. But the trade-off here is availability of the writes. But the system is best suitable for the data of the writes comes as a scheduled or a very controlled or happens through the batches. Let's take about the examples that I talked about. Price does not change on a real-time basis. Price changes as a scheduled and sometimes very use case as ad hoc basis, but majoritarily price change as a scheduled event. So it's possible to manage the availability of the master based on the availability of the master node, but this, and as well as if we talk about offers and promotions, they basically happens through batches, groups or scheduled events. So the availability of writes or the writer node can be as a trade-off to build out these systems. In the sense, if the master is not available during the time, but still that write or the availability outage of the master node can be managed or traded off. But here the very important thing is read consistency. Predominantly the read consistency is required to give a consistent experience of prices, promotions, offers to the users, but also it is, if there is a discrepancy, it is a legal issue as well. So master slave is best suitable for building out such systems where you would require highest read consistency, but you can trade off the availability of the writes if your system is write managed or controlled writes, right? But the system is simple to manage. The total cost of operations for master slave is predominantly very simple, and if you can build out the automation to detect the master failure on a diligent way and seamlessly making the slave as a master with a minimal outage, this minimal disruption, not the outage though, but minimal disruption, it is a great architectural choice. Simple to manage, less architectural complexity and easy to manage. Let's move on to the master application. Master, I would prefer to call this as an active replication, in where the data replication is done such that the data is replicated between two masters who are set up to work as an active-active for the writes. Of course, reads too, right? And in order to scale the reads, the clusters can be extended with the replicas to the master, but essentially, since we have an active-active writer nodes, it is very important to have the data replication between the master must needs to be always in sync, such as using a front line or the techniques and technologies that we have to sync the data between two masters like Golden Gate. Right? This is still feasible to sync the data between two masters on a real-time basis using the transaction IDs and whatnot. But Golden Gate-like solutions, they does resolve the conflicts on a real-time basis between the two masters. And in master architecture, if your desire is to build out not only high consistency, not predominantly not the consistency, but your requirement is high availability and high performance. You want to build out a high available, high performant system, which is a great architectural choice. But here the consistency could be a trade-off because there could be conflicts between the two writers, which would essentially get resolved through the technology that we will build between, such as what I talked about, the Golden Gate. But this could be a trade-off, the consistency. And here some nodes are dedicated to the intensive write operations, while others are dedicated to either for failover or for the reads. System also takes care of, we need to ensure the system will take care of resolving the conflicts between concurrent modifications. If there are concurrent modifications on the both writer nodes, that's where we will lead into data inconsistency issues. One of the key example, Netflix, they have built their infrastructure and solution across US as an active solution because their key objective here is high availability and high performance, not the consistency, right? Consistency can be traded off. But these solutions are moderate to manage, not as simple as master slave, but not as complex as group, or not as super complex as further Galera and multi-master applications. If your desire is to accomplish a highly available, high performance systems, but you can trade off the consistency, such as what I gave a best example as Netflix. It is acceptable that if you do not see a content for one specific user or one specific reason for that moment, that's absolutely acceptable. But the performance and availability of the Netflix system is the key paradigm. As I talked about, the main disadvantage of the master application is its complexity. Conflict resolution, it is very difficult because simultaneous writes on the writer nodes are possible, both the writer nodes are possible, and sometimes if the conflicts are so complex that the existing technology could not resolve automatically, or the system could not resolve, it would even require manual intervention to make the decision to resolve the conflicts between the right conflicts. So change of data inconsistency is one of the I would not say drawback, but that is expected as a part of this design. So but guess what, one of the two masters are always available and the systems are highly performant. So if you're high available, high performance, but possible trade-off on data consistency, this is the outstanding option for anyone to choose master application as the best choice. Here the total cost of ownership is significantly low, of course not to compare with master slave, as these masters are available into multiple regions or multiple network segments. The availability is extremely high, right? Always one master is available. If one master is down, and another master can come back and the replication can be set up and it can caught up and become as an active again. So these solutions would automatically give always high performance. Let's move on to the third one, group replication. This is essentially my favorite. Group replication process involves establishing a pool of servers that are each involved in ensuring the data is copied correctly. If the primary server experiences problems, the member election can select a new primary from the group automatically. There is no human intervention is required. If the master or any node is unhealthy, is inconsistent, could not discover any interruption, unable to communicate, the cluster automatically kicks out that node. Either it could be a master or a slave. And the cluster has the ability to elect the subsequent writer node automatically, seamlessly, predominantly more or less seamlessly. We'll talk about what is that seamlessness when a writer node exited, then how would the cluster keeps the consistency. And basically group replication provides elastic high availability. What I mean elastic is, here the member election happens pretty much dynamically cluster managed. When the cluster is always highly available, as you build out the cluster with 5 nodes or 7 nodes or 9 nodes or 11 nodes as an odd, depends on the desirable availability, you can build out the size of the cluster so that you have a choice from the cluster to always keep available a node as a writer, and subsequently of course. And the cluster kicks out the node which is unhealthy, and also a cluster will take node back when it is healthy, right? It all managed with the cluster. There is no human intervention required. It provides the fault tolerant replication topologies, because that's how the commit happens. It commits a transaction syncing with all nodes at the same time, right? It gets the acknowledgement from all the nodes that the update is being accomplished, and it does the commit at once. So the consistency is always there. The fault tolerance, high available, elastic availability in nature, high performance. Groups can operate in a single primary mode. That is, of course, usually I see majority of the group replication solutions are being set up with. But guess what? Of course, the single primary mode with automatic primary election, where only one server accepts the update at any given time, right? That's what I'm talking about. Only one server accepts the write at any given time, and it commits the transaction by getting acknowledgement from all other nodes. And the cluster will automatically manages who's to ensure that there is a writer always available and all the nodes are always in sync transactionally. And the group replication is a shared nothing replication schema where each server has its own and entire copy of data. That is how it is able to switch the writers if the one writer is down or detected as unhealthy and could not discover it, and there is an interruption, automatically it switches to another node, because every server has its own entire copy of data. It is important to understand that although the database service is available, in the event of an unexpected server exit, those clients that are connected to the previous writer node that has been exited from the cluster would continue to have those connections on it. It is important for us to ensure that we need to make a decision here, right? Is it okay to have those connections on the exited writer node, because the state of the node is still in a write mode, though it is exited out of the cluster, but it is exited in a mode as a write, so the connections will still exist on it. So we need to make a decision if either we can kill the connections the moment any node is exited out of the cluster by building out a simple small automation, so the subsequent retries or the subsequent requests from the same client will re-establish the connection to the newly elected writer node. Or the automation which I am talking about, which we can develop, which does not available by default as a part of the group replication, but this can be incorporated so easily with all my experience I am talking about. It's no big deal. Either to kill the connections on the previous writer node or fail over the connection nodes to the newly elected writer. That is a little more complicated, but I would suggest as long as you have retries, we can kill the connections on the exited writer node. But this is not something that group replication would provide by itself. So we talked about single primary mode, but group replication also support multi-primary mode, which allows all servers to accept the update, and if they are made at the same time in more complex use scenarios. If your requirement is extreme availability, I want multiple writers, I cannot depend on one writer node, it cannot scale by cluster. In that is what your need. You can set up the group replication as a multi-primary node, wherein every node in the cluster is a writer. And all the writers will always be in a consistent mode. As we are talking about, every commit would require an acknowledgement from all other nodes, and the copy of the data is maintained consistently across the servers. But now here, all are masters, all are writers, right? That is another option if you want to have even more high availability for writes, high scalability, and high transactional system. So this is about the group replication. Group replication gives us fault tolerant, high consistency, high availability, high resiliency, with the cost of managing the clusters at little larger the scale and the size based on the scale of scalability that you require. And I talked about the group replication is sensitive to the network interruptions, unlike master slave. Master slave, there is a small network blip or glitch. The connection to the master and slave will still continue to be there. But in the group replication, the nodes that are experienced the network interruption will be exited out from the cluster, so that it's sensitive to the network interruption. So you would see in group replication the nodes will coming in and out of the group or the cluster all the time. Not all the time, but majority of that. If the public provider is having any network interruptions, and if your infrastructure has interruptions and disruptions, automatically the group replication, you would continue to see the nodes moving in and out, but that would not cause any of your data inconsistencies and availability issues, challenges. So you have to maintain the size of the cluster to the level of scalability and availability that you require. So maintenance wise, no big deal. As I talked about, all the time you might need to have is building out a simple automation that manages the connections, either to kill or to transfer. Easy to set up, but the scale of clusters will be little larger, but maintenance wise predominantly simple. And we will talk about how do you manage the schema changes on these sort of systems. What are the complexity involved in managing the operations? How do you achieve operational excellence to scalability from the resiliency, operational resiliency, and as well as how do you basically manage the schema changes in such a solutions too, right? So let's move on. If your scale of need for the database solution is multi-region, multi-channels, multi-sites throughout the globe, this globe as a distributed database infrastructure that you require, we can consider Galera replication. Galera replication, I would call it as a multi-master. It best suits or a solution to attain multi-master, wherein Galera manages its replication through its own protocol, which is called WSREP, which is typically called write set replication, or WSREP API, which essentially defines the interface between the Galera replication and as well as the database, right? So the Galera replication and the database, it basically which WSREP manages the write set replication API, which defines as an interface between the replication and actually the RDBMS. It is a brilliant synchronous multi-master database cluster. Galera cluster provides high availability and scalability for MySQL, and of course you have various flavors of Percona is available on Galera, which gives highest consistency and lowest operational footprint, high availability, and so much of support from Percona. A Galera cluster consists of 3 or more Galera instances in a local network using synchronous replication, right? Galera cluster replication, within the cluster it uses WSREP or write set replication, but between the clusters it uses MySQL async replication to sync data between the clusters. Galera cluster supports multi-master and now has a GUI available for cluster management too. While this provides high availability in a local region or a site, it does not provide any provisions for disaster recovery or a multi-site deployment in general. I'll talk about that, right? So the data in general in Galera architecture is decoupled from nodes, right? Unlike group replication. But how is the consistency is managed if they are decoupled? Is the consistency is managed through GTIDs or global transaction IDs. So the architecture of Galera is GTIDs based architecture. Nodes are specific to the data, right? The entire data set can be replicated across all the nodes if they are all writer nodes. That's what the key paradigm. So if you have multi-master cluster and everything is a writer, the data can be replicated across all nodes in a similar way. But guess what? If you have only single writer on a cluster and rest everything are masters and slaves that require to or depended on having the data replications or updates to be replicated and synced across all other masters. In the sense what I'm talking about, assume that in the diagram master 1 cluster has the writer node, wherein master 2 and master 3 gets the updates through replication, direct replication. And all the nodes in the master 2 and master 3 cluster becomes as a slave nodes. They get propagated through the local master. These local masters are the slaves to master 1. If this is what your architecture, it is extremely complex to attain availability, and there is a possible lag, there is a loss transactions, there is a lot of data inconsistencies, there could be expected latencies, and low write throughput, though high availability on the reads, but with the cost of consistency. Assume if you have set up the Galera replication as all of them as a writer nodes and multi-master, multi-site, multi-region solution, the benefits of Galera replication is high availability. No lag between the slaves or between the clusters, they're all real time. No loss of transactions, no more data inconsistencies. The latencies between the clients are predominantly less because every master has the consistent, fully replicated same data set is available across the clusters. And of course, by default, Galera is read scalable, but having multi-master or multi-writer nodes, the write throughput is also predominantly high, right? So the complexness of Galera replication is, as I'm talking about the two different modes, one is a single writer versus multi-writer. If it is a single writer, it's more operational challenges, lag to replication issues and availability issues, latencies to whatnot. But setting up a writers is predominantly challenging to make the data sets replicated on a seamless manner between all the clusters, and essentially we need to ensure on the GTID based architecture works excellent. As long as it's set up right, Galera is outstanding choice for global or enterprise scale databases, but it comes out with higher cost as the clusters are predominantly several and the size of the clusters is high, and operational cost for managing such a solution is high because the trade-off here is high availability, high consistency, and high elasticity, high performance versus cost. So here cost is high and everything else as an output is predominantly high. So this is best suitable for global database solutions, right? So hope you have the detailed and clear understanding on the various of the database architectures, what best suits for what scale of solutions and what level of solutions to make a technology and business choices. And as I talked about last but least before jumping out of the Galera application, so Galera provides synchronous replication, active-active multi-master topology, read and write to any cluster node, automatic membership controlled, and failed nodes drop from the cluster, something similar to group replication. Automatic node joining, same as a group replication. When a node is ejected out from the cluster, it rejoins back when it is healthy and have the consistency. True parallel row level replication, direct client connections, drop-in replacement for native MySQL. This is all the benefits of group replication. So keeping all the features and benefits of group replication, if your desire is highly available, highly scalable, high performing database solution which require at a global scale, but it comes with the cost, total cost of ownership, and as well as operational challenges which I talked about if it is a single writer, right? Moving on, is it good enough to choose a right architectural choice, but how about operational resiliency? How do you ensure that you have a right mechanism to make the schema changes, and what are the best things that you need to ensure in order to perform the schema changes, and what are the issues and complexities that you will leads to when managing this global solutions and changes on top of it, and what are the best practices for the backup and recovery, and what level of health and readiness checks we should enforce towards attaining operational resiliency, and what does it mean by database observability engineering to build out high resilient, high available, high performant database systems. So it's the next topic, right? So let's talk about the various mechanisms that we can consider in order to perform database schema changes. I like to briefly touch upon three of the mechanics or three choices that we can make based on based on the nature of the solution. One is a total order isolation versus rolling schema upgrade versus non-blocking operations. TOI, abbreviated as total order isolation, these are the schema changes made on all cluster nodes in the same total order sequence, preventing other transactions from committing for the duration of the operation. So you are blocking the schema from any other operations or the schema changes when you are performing one schema change. So you are basically freezing your database when you are executing some change. That's the disadvantage. The main advantage of total order isolation is its simplicity and predictability, which guarantees the data consistency because you are performing a change on a real-time basis across all the database nodes through TOI. Additionally, when you are using total order isolation, you should take the following, you need to make sure that we are okay with the trade-off of freezing the schema for taking any subsequent transactions, right? That's the limitation, but essentially the bigger advantage is it's pretty simple, highly predictable in terms of making the changes through TOI mechanism, and guarantees the data consistency across all the nodes at the given time, right? And essentially we need to ensure testing out any of the schema changes that we want to perform through TOI. What could be the expected impact when you are running this change? How long would you expect to have the schema would be in freeze mode, and what other schema changes and operations would expect it to be performed in parallel which would be blocked. So considering about your system or transactional low hours or zero traffic time, performing change through TOI is highly safe with the benefits of its simplicity, consistency, and guaranteedness. What if TOI is not your choice? The other mechanism is rolling schema upgrade. So rolling schema upgrade RSU, these schema changes run locally by cluster to cluster, affecting only the node on which they are running. So you basically perform the schema change node by node. The change do not replicate to the rest of the cluster. So that's why it would not block any other transactions. All the transactions can free flow when you are performing any schema change through RSU on all other nodes, you're actually doing it local to a node. So you're keep rolling in alternatively on node to node. So, but the disadvantage or the issue, this gives, would not give any consistency, but gives the safest way of performing a schema change, right? And it's not so simple. It's very lengthy process as you roll over your change node to node, cluster to cluster, and so if you have a global database infrastructure, doing RSU is extremely huge effort, and to ensure a lot of consistency issues as well. And the disadvantage is this data consistency issues, if right sequence and right order is not managed, can lead to database outages because of a cluster to cluster inconsistency, because you are performing a change on local to one node on a one cluster, and others cluster is not in sync in terms of state of the schema, and that can lead to schema inconsistency issues. It depends on how you configure and set up your solution, which can lead to local to global outages, massive outages as well. Just a schema change can bring down the entire global infrastructure. So that is one of the things that we need to make sure. And non-blocking operations. So non-blocking operations are useful when an application needs to run number of independent queries in parallel at the same time to speed up operation compared to running them sequentially one after other. Non-blocking operations mode is the best option. So essentially, before using any blocking operation, it is necessary to enable it the setting that is supported MySQL by default as MySQL _opt_ non-block option. This is a configuration which is provided by MySQL, and we can explore in all other database flavors how do you attain the non-blocking operation mode, what is that you need to set in MySQL, but as I mentioned, which is MySQL _opt_ non-block. If you set this configuration as a part of MySQL _options, which would allow you to perform non-block operations. So this would allow you to run parallel queries that require to be run at the same time, which allows you to execute your schema changes across global databases in a faster manner, and which will give you a predictability and consistency across the databases, schemas, and clusters, unlike rolling schema upgrade. Let's move on. Schema change automation. So why do you need to automate a change? A schema changes. So it is crucial to make sure that a change that required to be performed on a schema is performed in a consistent manner across the environment, such as dev to stage to production. That is one very important thing. And it is essential to ensure that no human and manual errors when you are performing schema changes. 3, we require to have a single source for performing any schema changes, that is like a Git. And we need to make sure that there is no security loopholes like manually logging into SSH to perform a schema change. How do you attain all of this? And of course, workforce, right? If we talked about just now rolling schema upgrade, if you need to perform on a Galera global cluster, that would take several days, right? But what if you do not have an automation? That you require to have several hours of manpower, many of the resources will be blocked for performing schema changes. That's very, very important to have an automation. Automate your database deployment scripts. Consistently deploy the same approach and process in every environment that you attain through our database schema changes automation. And guess what? We definitely need to make sure that automation is just a process automation, but it requires to encompass all the validations to ensure that the expected schema state is accomplished before and after a schema change is performed. That means we require to have validations on a schema change to ensure that it is successful. And these checks needs to be part of the automation itself, and based on that, the automation should make the decision either to continue in a progressive manner or roll back the change. So the automation should build diligently to perform the change, validate, make a decision to progress or roll back. And as I mentioned, having all deployment information in one location, that is Gitized, and fewer problems with deployments as no human intervention, and are better performing developers, a developer's heaven, because they don't require to have the dependency on DBA to perform every schema change, as they have automation is available for them to work on any environment as they have access to. So there are several open source frameworks out there which allow us to scale towards attaining everything that I talked about. Diligent database schema change automation such as Flyway and Liquibase are the open source solutions. They allow us in a format that it is known and comfortable to each user, and they are compatible for majority of all the open source and all other database solutions. And the database updates can be done at a breeze, mean a speed, and they generate the database specific SQLs for you. You don't require to do all of these things manually. And change log files are used to track the database changes. You have a change audit as well if you automate all this. There is no manual way of tracking, oh, I don't know when I made the change. Right, so that is the importance of schema changes, which is very, very important to keep up your database resiliency and availability and not cause any outages and issues. And when you perform in schema changes, based on the flavor of solutions you have in play, you might lead into an issues of compatible versus incompatible database schema changes. As we talked about the rolling schema upgrade, where you perform the schema change locally to a cluster and continue to progress, right? So therein you have the possible inconsistency of the state of the schema between cluster to cluster. That can lead to some of the schema changes would fall into those non-compatible schema change. For example, you are modifying the size of a column of a schema or a table, and it is required based on the transactional nature of the database. It required to have the schema to be consistent across the clusters as it is being actively being used. A schema is at big int, other schema same, in other cluster is a small int, or it is varchar 20 and varchar 10. So this leads to an inconsistency. Guess what? This can lead to global outages. The schema inconsistency, when the databases try to self-check themselves their consistency, if they are not, they get into an error state and can cause a global outages. So it is very important to understand nature of the schema changes that we are performing, how compatible are based on the database flavor and the solution that we have in place, such as we talked about Galera to group replication to master and master slave. How would these changes will flow, propagate in my establishment or my solution? How compatible are they versus where would I end up with non-compatibility, right? So let's look at into non-compatible mode, which I talked about, modifying with the change in data type from a smaller to larger, or a larger begin to a small int, a larger to smaller, which essentially can lead to data inconsistencies and possible lossy and non-lossy of data during the schema change. Assume that you are changing a big int column to small int, and the data which is pre-existed on the schema with suitable for a big int will get truncated to small int as a part of the change. So your cluster and your database cluster, one of the cluster is big int, other is small int, other is another small int or a big int. These inconsistencies can lead to database outages and as well as possible data truncation too. And many of the database solutions, when they see this inconsistency, the transaction would fail and, as I mentioned, outages. But there is a safest way to handle such scenario, wherein you handle the lossy and non-lossy through global flag settings such as slave type conversion flag. How do you do the conversion to the slaves on such a non-compatible changes? By setting slave type conversion flag at a global level, so the database now has authority to make the change to go in either as a lossy or non-lossy, because you are giving the authority to the cluster to make the decision to go in as a lossy. In the sense, the database will still allow the transaction to happen but truncates the data, but you don't get into outage, but you will have a possible data loss. In other way, if the schema did, you set the flag and there is no data truncation issue, which goes as a non-lossy. So the cluster can make the decision if you set the this configuration, so which will make your changes seamlessly flow through. But you need to understand, test it thoroughly. Am I executing a non-compatible or a compatible schema change? Do I have a possible lossy or non-lossy data impact due to the change that I am performing? Well, now let us quickly look at the best practices for data backup and restoration. So it is essential to ensure that we have an automated backups to eliminate the risk of human mistakes that is inherent in manual backups. Now, towards expediting the recovery process in an event of data loss, we need to make sure that in a fully automated, intelligent recovery process as well in place, which is tested out on a periodic basis. Coming to the reporting, we need to ensure that there is our solution is built in with the reporting where you will be able to see what's going on with your backups. It's not that I have a backup. I need to make sure that my backups are up to date. They're on par to restore my system at any given point. You need to have those reporting on the backups too. Coming to the compliance and auditing, consolidated records for all the backup processes, which essentially improves our internal and compliance related auditing and reporting. Data encryption, and we need to ensure that data encryption should be included in backups to increase the security and automated operations, right? We need to make sure that reduced amount of IT staff time that is spent on laborious and manual operations that are time consuming and inefficient. This all needs to be automated or eliminated. Synchronized backups. You can save both time and storage space by using backups that are synchronized. And we need to make sure that everybody understand a full backup versus snapshot. Snapshots will elevate the optimized approach of backups and restoration process. Retention requirements. Schedule the archiving and destruction of backups and the data in accordance with your retention requirements. We need to make sure that all the data backup and recovery best practices are followed. And let's move on a couple of more topics which are critical. One, health and readiness checks. Coming to the criticality and importance of health and readiness checks on database solution, from the configurations and validations wise, ensure that our database solutions and operating systems are properly configured. And periodically having an audit and making sure that any fixes, any known issues, any configuration changes that are offered by the specific version and the flavor of the database are up to date. Having the vendor reviews, having the SMEs reviews on the configurations to make sure that the solutions are standing at the front line in terms of the configurations. Resource saturations and validations. Are there enough physical or virtual resources to complete the database tasks, right? Have to have the view observability on the saturation matrix or telemetry. And database performance checks. So this is essential to ensure that do we need to optimize the database engine or query performance. So consistently having a view of long running queries, in which scenario the database engine might require further optimization. So ensuring that we have the observability. Coming to the normalization checks, right? Is it possible that the schema has been normalized or denormalized? Is it necessary to look at the normalization and denormalization needs? So having those checks and health on the normalization at level. Index checks, right? Do I have right indexes based on how the queries are getting executed, how the database schemas are continue to get changed and transformed with all ongoing schema changes and architectural changes. System resources and sidecar check, right? How often the essential administrative utilities are running live, which is including security scan to all the backup and restoration processes and all administrative processes in the database. How often are they running? How much overhead are they creating? How do we need to schedule them to not to intervene and create overhead during the high transactional hours, rather have these administrative utilities running during the low hours. And coming to the backup and recovery, is the system replicated or backed up in accordance with the requirements of business and transactional needs? Right. Coming to the business continuity and DR essential readiness checks, are the processes for disaster recovery documented, tested, and ready? Right. Not that I have some DR, but I will look at it when there is a need. So we need to make sure that all DR readiness entities in the system are always have verified, checked, and ensure they are ready to fire. Runbooks, SOPs, and workforce readiness assessment. Yes, everything is available, but we need to make sure that all our SOPs, runbooks, and other thing is the knowledge, SMEness of the workforce as well is up to the mark to perform any of the operations smoothly and seamlessly. And DR drills needs to be conducted periodically. Last but not the least, database observability, which I would split it into two aspects. One, the infrastructure observability versus data governance, right? On the infrastructure standpoint and the solution standpoint, consistently reviewing database tuning and having the telemetry that would expose the state of database tuning needs, and automated telemetry collection from the infrastructure, availability, saturation, and resource consumption and transactional metrics such as the golden signals on the database transactional availability, consistency, freshness, and availability wise. And database query analysis such as long running queries versus possible query optimizations. Do we have all the telemetry available? And as well as the database monitoring, which I'm talking about, database performance monitoring, are all exposed, and I have the golden signals. And coming to the data governance wise, operational health, data set monitoring, not cutting out there, but column level profiling and row level validations as well. Do I have them in place to cover business rules enforcement, stopping the bad data to get propagated, summary of the statistics on all the data to ensure that I have the data statistics that meets my needs and they are on par, anomaly detection on the data as well, availability metrics, freshness of the data, volume of the data, and to many times we encounter that I think I exceeded the limit of the data type, and now I think I'm running into an issue or I'm running into an outage. I realized that I need to convert my data type from init to begin because I exceeded the limit. Because you do not have those metric exposed, which talks about the volume of data or the trend of your data that is getting in, when are you going to hit the roof. So we have to have the visibility to ensure that we are not so reactive, and schema changes wise, having all the audit trail and how the schema changes are over a period getting transformed, execution of the metadata, pipeline state, and delays. So these are all the key and critical database observability. Telemetry engineering needs to be exposed to ensure that we have the frontline database observability engineering tool, which essentially takes us to highest database resiliency. So this is primarily my topic or talk on database resiliency for mission critical computing. Thank you for being part of my session on database resiliency.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, and welcome to my presentation, Percona Database Distributions and Overview. My name is Lenz. I'm based in Hamburg, Germany, and I'm a member of the database engineering team here at Percona. I joined the company in January 2021, and in my role as the Director of Server Engineering, I lead and support the teams that work on our Percona database distributions, which are the topic of this talk. In this presentation, I would like to give you an overview about what our database distributions are about, why we're doing it, and why you might want to consider using them for your projects. I'll conclude this presentation by giving an update on a few recent changes and highlights of each individual distribution. Before I'll talk about our distributions in particular, I'd like to start by providing some context, giving you an overview about the roles that we play in the various open source database ecosystems, and by explaining a few terms that I'll be using in this presentation. As you can hopefully see from this picture, Percona as a company plays multiple different roles when it comes to how we work on and with open source software, and the corresponding ecosystems and communities. All of our software we create and maintain is released under open source licenses. Most of these components are included in our database distributions, but they are standalone projects and tools as well. Together, they form what we refer to as the Percona solution stack, about which I'll talk a bit more on a later slide. While this visualization focuses on our core database components, MongoDB, MySQL, and PostgreSQL, the same principles apply to any of the components that we include in our distributions. Firstly, Percona is a distributor. In a nutshell, we take existing upstream open source projects and we redistribute them as components of our solution stack, namely our database distributions. When it comes to the core database components like MongoDB or MySQL, we enhance them by applying additional modifications and improvements, adding new features, improving performance, or fixing bugs. In this model, the majority of the development work is done by the respective upstream communities, and Percona is participating in these, for example, by submitting bug reports and patches. The level of engagement varies by project. Some examples in this category include Percona Server for MySQL or Percona XtraDB Cluster, which are based on the upstream Oracle MySQL and Galera cluster projects. We try to follow an upstream-first approach here, in which any bug fixes and improvements that we create are submitted back to the upstream projects for consideration and inclusion, in the hope that they will be accepted. Secondly, we are a creator and producer of open source software by ourselves. We make the source code of these available on GitHub. The majority of the code is written by engineers employed by Percona, but we also engage with our community of contributors to encourage participation in the form of submitting feedback like bug reports or enhancement reports, or working on actual code contributions in the form of GitHub pull requests. Some examples of such projects include Percona Extra Backup, Percona Backup for MongoDB, or Percona Monitoring and Management, also known as PMM. One thing that I would like to emphasize here is that we are not in the business of selling software licenses. We are a strong believer and supporter of the open source software development model, and all of our software is licensed under open source licenses and is available free of charge. You can download and install our database software without any restrictions or limitations. Our software is the primary vehicle for attracting users and making them aware of us as a company and our service offerings. Many of the improvements and enhancements that we include in our distributions are open source implementations of features that are useful in enterprise environments, but are only available in the form of proprietary, paid-for extensions by the upstream projects. These include features like more advanced backup solutions, security enhancements, or tighter integration with existing IT infrastructure. Making all of our database software freely available also ensures that you remain in control of your data and you don't end up in a vendor lock-in situation. Our business model is bundling the software with additional services, which are available in the form of subscriptions. The services we provide include various solutions to help our customers being productive using open source database technologies. One of them is the support offering, which gives you a way to contact our experts via phone, chat, or email in case of trouble or when you have questions about how to set up your production environments. Our managed services offering provides you with remote DBA resources in case that you want to deploy and operate your databases on your own infrastructure or in the cloud, but you cannot or do not want to employ a full staff to manage these. Our experts can assume responsibility for the setup, monitoring, administration, and emergency response of your databases. Thirdly, our consultants can be booked to support you in setting up more complex projects from scratch or when you're facing performance or scalability issues. Okay, let's talk about our distributions. You may already be familiar with the concept of a Linux distribution like Red Hat or Ubuntu Linux, which performs the service of selecting, integrating, and testing all of the distribution's individual software components to ensure they interoperate and work well together. The software is then bundled with additional service and support offerings like providing updates and maintenance. Similar to Linux distributions, the Percona database distributions aim at being enterprise database distributions with a deterministic and conservative release cycle. They are a well-groomed collection of our recommended best practice open source tools and utilities for each of what we call the core database component, which is either MongoDB, MySQL, or PostgreSQL. The content of each distribution varies, but for each distribution we have identified the most commonly used tools that help to implement key enterprise functionality, including high availability, load balancing, backup and restore, disaster recovery, monitoring, and observability. We maintain this collection of software tools that are commonly used together with these database components with the intention to make using the database easier and more productive. These components have been selected in collaboration with our users and experts based on their experience working on production environments of our customers. We also try to be fully compatible with the upstream database versions. Any modifications that we do are changes and additions on top. We don't really want to modify or remove any underlying functionality. Moving from the original upstream database component to the Percona equivalent should always be possible and straightforward. We test and validate the interoperability of all the components of our distribution. When upgrades are made, we retest all components and other products that may be impacted so that we avoid any regressions for our end users. By using our distribution, you are ensured that the components interact with each other properly. For our users, it must be sufficient for them to add our distribution package repository to their Linux operating system of choice, and then use the Linux distribution's built-in tools like apt or yum to install and update our database distribution packages. No other third-party software should be needed. Our database distributions are available for the most common Linux distributions that are used in production environments, like Red Hat Linux and compatible derivatives, Debian or Ubuntu Linux. Together, our database products and the distributions form what we call the pillars of our solution stack. They are the foundation for the software layers we put on top of the solution stack, which we call the consumers. In this architecture, our Kubernetes operators provide the management glue layer between PMM and Percona platform as the end-user-facing management and monitoring application and the database technology underneath. Of course, any component of the stack can be used independently. But our aim is providing a well-tested and integrated solution stack where using multiple components significantly increases the value and usefulness. In closing, I would like to introduce each of our database distributions in a little bit more detail. I'd like to start with our distribution for MySQL, which is based around our oldest database products, Percona Server for MySQL and Percona XtraDB Cluster, which includes the Galera replication framework for enabling synchronous multi-master database replication. Depending on the database component, the distribution includes some additional components to facilitate setting up high availability configurations and methods to distribute and manage workloads. The distribution also contains Percona Extra Backup, which is our open source implementation of a hot backup solution for MySQL, which supports creating backups without blocking ongoing database operations. I'd like to briefly highlight some recent notable improvements that we've added to Percona Server for MySQL as included in our distribution. As mentioned earlier, our focus is on providing open source alternatives to often sought enterprise features that our users find useful. Some recent additions include enhanced encryption functionality. For example, a way to simplify the management of encryption keys in the database using the Key Management Interoperability Protocol, also known as KMIP, or using Amazon's Key Management Service KMS. We also added additional functionality to encrypt and decrypt data in the application using the OpenSSL library, helping developers to use standardized best practices for performing this task. The slow query log improvements added microsecond time resolution and additional statistics to the slow query log output. It's possible to enable or disable the slow query log at runtime. Moreover, we added logging for the replica SQL thread and added fine-grained control over what and how much the database should log into the slow query log. Percona Extra Backup recently gained functionality to store backups in Microsoft's Azure Blob Storage as an alternative to the already existing Amazon S3 support. Our distribution for MongoDB is arguably the smallest one if you look at the number of components we include. But this is due to the fact that MongoDB provides a lot of the desired functionality out of the box already and does not require any additional software to implement many of the usual scenarios. We've added a number of enterprise features to MongoDB in the recent years. The most recent one is the possibility to retrieve and manage encryption keys using the Key Management Interoperability Protocol KMIP, similar to how we enabled this functionality in Percona Server for MySQL. With version 1.7 of Percona Backup for MongoDB, we were finally able to overcome a key limitation of previous versions. Instead of performing logical backups, which can become quite time-intensive on large data sets, PBM now also supports creating physical backups. This significantly expands the range of application of this tool and is a key performance improvement by notably reducing the time to create database backups. The latest addition to our Percona database distributions family is PostgreSQL, which we added to our portfolio in May 2019. Percona distribution for PostgreSQL is a collection of tools to assist you in running PostgreSQL in production environments. It includes the upstream PostgreSQL database engine and complements it by a selection of tools and extensions that enable solving essential practical tasks efficiently. One of the notable components developed and maintained by Percona is pgStatMonitor, a PostgreSQL extension that collects extensive query statistics to help monitoring the performance of your database. pgStatMonitor just recently reached GA status, and we're actively working on further enhancing and improving this component to make it the most popular and useful monitoring extension available for PostgreSQL. There's much more I could talk about for each of our distributions, but I wanted to keep this presentation on a high level to give you a first overview. I hope you found this information useful. Please let us know if there's anything you would like to know more about. We're happy to answer any questions you might have. Our forums at forums.percona.com are also a very useful resource to post questions or get involved in ongoing discussions. Thanks for watching.
Welcome everyone to Percona Live 2022. It is truly an honor to have you, and we welcome you wherever you are. I would love to say thanks to the organizers and thank you to all of you as well. As you guys know, my presentation will be based on data wrangling with MongoDB. After this presentation, I guarantee you guys, you will have the mindset of data wrangling, right? My presentation is 70% demo and 30% talk. Before I dive into the main topic, why don't I introduce myself? Who am I, guys? My name is Jean-Joseph, okay? I am based out of New Jersey, originally from Haiti. I'm a big fan of going out to eat, fishing, listening to audiobooks, movies. As you can see, these are my 4 kids. I have 3 handsome sons and 1 stepdaughter. I'm currently working as a data engineer. I'm a Microsoft MVP, data community builder. For those who don't know me, I am the founder and the main organizers of a data-driven community. Under data-driven community, we have cloud data-driven that is focused on on data management and visualization. And then we have feature data-driven that is focused on the growth of AI. I've been in IT for over 19 years. I started my career as a network administrator. While supporting database team, I moved to database administration and development. And after that, I moved to data engineering. Enough about me. If you guys want to follow me and my community, feel free to scan. So let's go to our main topic now. What I'm gonna cover with you today is, guys, I will go over the goal of data wrangling, how to think about data wrangling, and then the technical tips for data wrangling in MongoDB, and there will be a walkthrough examples. After this presentation, I'm gonna change your mindset regarding data wrangling. So, what is data wrangling, guys? Data wrangling is the process of cleaning and unifying messy and complex data set for easy access and analysis, correct? What that means is that when you take your raw data or your unorganized data, you turn that data set into something useful where business can go and use that information to make to make decisions out of it. Right. So what are the use cases for data wrangling? if we're looking at here, if you're doing marketing, you will need that. Machine learning application need that. Healthcare system, financial services, and banking. Travel and hospitality, voter and elections, statistics need a clean data, right? So that's where you're gonna think of data wrangling. So how important is data wrangling? It is very crucial, guys, to understand that if the requirement or if the required data is incomplete or incorrect, trust me, you cannot make a good decision out of that data. It is simply means that all the insight might be wrong because your data is not, well cleaned, which can sometimes a little bit time consuming, and then it requires a little bit of money as well, because you will need people that have knowledge in this field to clean your data the way you want it. What I like about data wrangling, it's help you reduce the risk by ensuring the information you are about to store for business to use is reliable. Put that in your mind. So if you've done it properly, so that's mean you are the winner. Otherwise, it could be time consuming and business won't be able to meet the expectations, correct? But doing the data wrangling, there are some steps you need to follow. Those steps are the one most likely data analysts or data scientists get lost. And this is what I'm about to cover with you. Okay, guys. If we're looking at here, doing your data wrangling process in practice, what to expect, guys? First, you have to think of data discovery and profiling. Very important, guys. So what I mean by data discovery and profiling. So that's where you have to explore your data for you to better understand what it contains and what need to be done to prepare it for the intended use, right? That help. So once this is done, you have to, there's gonna be data profiling that will help you identify patterns, relationship, and other attributes in the data set, as well as an inconsistencies, guys, correct? Anomalies, missing value, and other issue that can be addressed, right? So what I mean by, so you have to be able to identify the necessary steps to familiarize, centralize, and connect all your data. Once this is done, you have to outline the key technical requirement for the data processing pattern, because most likely when people think of data wrangling, they only think of the cleaning part and transforming. Before you will get access to clean that data, you have to think of ingesting that data, and you have to process it sometimes. And once this is done, you have to store that data. That's when you will need to think of the right data platform approach for your project. In our case, we're going to use MongoDB as the storage, and we will use Python to process, clean, and transform, and save that data, correct? So once the discovery and profiling is completed, that's when you're going to think of extracting that data. I know this is not uh, something related to data engineering, but what I normally make data analysis or scientists think, you need to understand data processing architecture pattern. Sometimes, if you're working for small business, you will be able to do everything. You need to understand when you have to go with kappa versus lambda or lambda versus kappa. If you're dealing with batch processing, you're dealing with live streaming, you have to think of lambda. If you're not dealing with batch processing, it would be best to go with kappa. And then you need to know there will be a trade-off between ETL and ELT. Once you're designing your data processing pattern, you have to think to optimize it for compute and storage. Okay, once this is done, guys, that's when you're gonna think of cleaning the data. When you're cleaning the data, you have to think of assumptions. What I mean by you have to test assumptions about values, okay? About, for example, data type, shapes. Sometimes there are some requests before we're able to give people business what they expect from us. We may need to retransform that data, reshape that data. And then once we reshape it, that's when we will be able to, you know, please business requests, okay? And then sometimes you have to think of identifying error or outliers, you understand? Missing data value. There's a tons of things you have to think of. But unfortunately, most data analysis or data science focus on the cleaning part. They ignore everything else. So doing the cleaning, sometimes after they've done everything, and when business complaining, that's when they realize whatever they done didn't meet business expectation. Why? Because they only focus on the cleaning part. And sometimes there's data silo as well. But because they didn't do a nice job doing the discovery and profiling part, they were not able to discover that. So follow this process will make you save a tons of time. Just for your information. So when we're looking at all of this, you can see these are the data. That's the new currency. So doing the discovery, extracting, cleaning, you think of data, which is the new currency. However, after this is done, that's when you have to think of storing the data. Once you store that data, so that data convert into information. But once you store it, you need to think of it tons of things. That's why you need to have a minimum understanding of data engineering, and then for you to work with that team to ask them a tons of questions. So you may need to even ask the business, and you need to understand your environment, because the data, once you store it, so you have to think of consistency matter, because you will be dealing with distributed system. You have to be able to understand how important is data if how important is it. If consistency matter, you have to be able to advise business. Performance may impact a bit, because once that data committed, it has to be available across all replica before you will be able to see that data. That may impact performance a bit. You have to think of for protecting your data as well, because once you save your data, some data have to be reside to at its location, so it cannot leave. For example, if you are in Europe, some data cannot leave Europe because of how sensitive is that data. And you have to think of data governance as well, who's going to access that data. Not only that, you need to think of performance and scalability, because once business need that information, they will work with you, right? If performance matter, they will tell you they're not able to get that data. It takes forever. They will not know it's a matter of resources. They may think it's a matter of your process. So understanding, how business will access that data will have you work better with other team. And you have to think of reliability as well. Once this is done, that's when you will think of what we call analysis, where business will go and make decisions. You understand? Use the tools like Power BI, machine learning, Microsoft Excel, Tableau, Python, our MongoDB aggregate framework. You understand? So in reality, this is what you need to expect. I'm not asking you to master this, but I'm asking you to understand the process and have a good understanding, right? For you to better assist business. So in a nutshell, this is going to be the workflow. So this is the wrangling. These are the activities that's going to be happen within your process, correct? If you're looking at here, there will be a source. The source can be anything. It can be sensor. You can see because there is there is a IoT device here. I can clearly see there is live and there is batch processing involved. You understand? I can define this as a lambda architecture to process that data. I know this is not related to data engineering, but however, doing data wrangling, you have to think of extracting, processing as well. We cannot think, we cannot think or even talk about data wrangling without introducing the 5 characteristics of quality data. The first one is validity, which tell you the degree to which your data conform to define business rules or constraint. I like that. The second one is accuracy. That so that's when you have to ensure your data is close to the true value. The third one is completeness, which tell you the degree to which all required data is known. The fourth one is consistency, that allow you to ensure your data is consistent within the same data set and across multiple data sets. And then the last one is uniformity, which tell you the degree to which the data is specified using the same unit of measure. Great, guys. So that's when we are close to demo, guys. Okay. So now, before we go to the demo, as we're gonna use MongoDB to as our data storage, why don't we introduce MongoDB, guys? What is MongoDB? MongoDB is a document-oriented NoSQL database used for high-volume data storage. I like that. It's designed for big data. So if you do not have big data, do not think of it. What I like about MongoDB, it provides you flexible schema. So that's when you don't need to worry about if you have a document that have 10 fields and the next documents have 50 fields. You don't need to worry about that. As long as the syntax is valid and your data is parsed, so that's mean the data will be committed. And it gives you flexible deployment as well. What I like about MongoDB, it is rich with aggregate framework. When it comes to data wrangling and analysis, I would highly suggest you to think of MongoDB aggregate framework because it is rich. It is oriented toward programmer. Like, it doesn't matter about your background. If you come from Java, .NET, PHP, Scala, Node.js, C or C++, even Python or Erlang, you will be able to work with it. So now let's go to some demo, guys. Before I go to the demo, let me show you something. If you're looking at here, this is the file we're gonna clean. I'm gonna keep it simple, very simple, because the mindset is is my goal, is to give you the mindset. If you're looking at, we don't have Tylo here. We don't have Tylo here. If you're looking at here, we have comma. We have dashes. We don't have any PBI certification, RIAA certification. So now consider, for example, this is a business request, okay? Our goal is to remove all records where the title is empty, okay? Replace dashes with 0 for UK and US chart positions, okay? And they want you to replace empty string with the unknown for PBI and RIAA certification fields. And they want you to change the release date to a different format. And then they want you to insert that into battles. So for example, this graphic collection, okay, under Percona Live DB database, right? So now after that, they want you to calculate how many platinum, gold, silver for PBI certification. So now let's explore the data, correct? So this is the data, let's explore it. So when we select that data, you can clearly see we have Tylo, release, that's the exact same fields you're able to see here. As you can see, this is the field, okay? So now if you come, you can clearly see that's what you get here. However, if you're looking at here, we don't have Tylo. We can clearly see that. So now we need a way to, for example, exclude those empty records. So what I'm doing here is splitting the light, right? So, and I need index 0. Index 0 will give me the first field, and the first field is happen to be Tylo. So if I execute this, so you can clearly see, I can see that I have empty field here, right? So for your information, I'm using plain Python to do the demo just to give you the mindset, because I know what I have been through whenever a data analysis or sometimes science reach out to data engineering team for support. Do you understand? Most likely they believe in a tons of module that's already done all the work, but the mindset, they don't have it. And some requirement, if the feature does not exist, they have to go out. And people who don't know Python, they have to Google it and, see what can they do, to get the task done. So I'm going to keep it very simple and give you the mindset. So now, if you're looking at here, for me to exclude, for example, the empty records where Tylo happened to be 0, so what I'm doing here, I'm reading the file, okay, line by line, and then I'm using split to do the same thing, and I have a condition. If the length is different to 0, I want you to print that. Guess what happened? We were able to print it. Very nice and neat. So far, so good. Okay. So now the second thing was to, for example, replace dashes with 0 for UK and US chart position fields, correct? So now if we execute this guy, so the job couldn't be done. If you're looking at here, this is the two fields. True enough, this is work, but wherever there is comma, it does not work. If you're looking at, and then if we go to our files, you will see we have comma here. So instead of using OS to import the data, I would highly suggest you to import or to use CSV module. Okay, so this is the CSV module. So what I'm doing is to import it. Okay, and I am doing the same thing to see if that will work. As you can see, for example, I was able to do that just by importing that CSV model. Perfect. So when you're cleaning your data, you should not clean your data in one big giant script. You have to analyze it step by step. If there is bug, you will be able to catch that. Put that in your mind. Okay, so let's do the next one. If you're looking at, we have to clean, for example, replace dashes with 0 for UK, okay, positions, and then we have for UK and US positions. So if you're looking at here, the code is just printed out, but we didn't overwrite the value. For us to overwrite the value, as you can see, this is the same thing. I'm reading the file, okay? This is the header, because I want to remove that header as well and loop to the records. And then I need to apply my transformation against all record where Tylo is not null, correct? That's what I'm doing here. And then what I'm doing here, I wanna, for example, replace this and append this. So when I do this, you will clearly see, for example, I was able to do the work. Perfect. So now I override it. You can clearly see that. Great. So now the next requirement is replace the empty string, okay, with unknown. Guess what will happen? So let me point this just to visualize the data. You can see we have empty fields, okay? So those empty fields have to be unknown. If I go, okay, just bear with me. If I go and execute this, if you're looking at here, even though I cannot say replace here, it will not work. And if you Google it, you will see tons of recommendations, but it will definitively not work. I know you're probably thinking, if I close this is what one guy told me, why don't you close this? When you close it, it changed the underlying data because you're dealing with empty string, okay? So I know like what he told me after that, use single quotation and double quotation in Python are still the same. Okay, he said put this space. Let me put that space again. It's still the same, so let's bring it. Perfect. So the best way to do this, guys, just for your information, is this is what I'm doing, okay? So I am following the same principles. These are the same scripts we just use. The difference is that I'm using an if conditions and I'm stripping it. So that's when I'm removing all the empty space. If the length happen to be 0, I want it to be unknown. And I'm doing the same thing for the other fields. When I execute this, you can clearly see I was able to get the job done. Great. So now, so far, so good. Let's carry on. So now, remember, we have to change the release date to a different format, correct? For you to do that, you have to import dateutil parser to change it. But before we done the transformation, let me import this and then read that data for us to be on the same page. When I read that data, you can see this is the format. So they want it to be here, month and day instead of month name. So now let's go and change this. So what I'm doing here, we import this already, but we will need this module to do that. Okay, so this is the same script for me to read the data, remove the header, okay, and then loop through the records, and then only do the transformation against records that have title. Okay, and I need so what I'm doing here, I'm using this one, as you can see, this one, right? For example, if you're looking at here, that's the conversion. Okay, so now I'm using this one to bring the format. So when I execute this, you can clearly see I was able to do this, right? So now, guess what happened? We will need to revisit the title because when we remove the empty records, we use OS, not CSV module. So let's carry on with this. Let's execute this. So we're still in good shape. Great. So now let's bring the final script. So once you're done with everything else, so that's when you're gonna add up all the Lido transformation you have done. Okay, you can clearly see we were able to clean that data. Great. So now everybody is happy. Okay. So now once this is done, you need to convert this record into JSON format because MongoDB only accept BSEN data. And if you're looking at it, is the same kind of format with JSON. So now for you to do that, what I'm doing, it is the same script above. If you analyze this, it's still the same script, but I'm adding one more and I am defining a new document for each record. If I execute this, you will see, for example, I got it. How great is this? So now those records, so now I got everything that I need. I will need to turn this script into a functions to make the script runnable. So what I'm doing here, I'm defining a functions to insert every new document. I need to know the server name, DB name, the collection name, and I need that document to insert. I'm importing by MongoDB from MongoDB client, and I'm defining the server name, DB name, the collection name, and I'm inserting it. But for me to insert this, that data have to be parsed. Okay, so this is the same functions that I have that give me this output. That's the same script. I just wipe it into a functions. So at the end, instead of point, I call these functions to insert the data. So let's execute this to create that functions. So now, guess what happened? I have to define my variable value. This is the variable value. This is the data file. Server name. This is the DB name. And then this is the collection name, guys. Okay. So, and then this is the functions. And remember the function we call the insert functions. If I execute this, you will, so that's when the data is inserted. All my record has been inserted. So let's read one document from that. Okay. So if we're looking at here, I was able to read one document. That's amazing, guys. Correct? Oh, great. Nice demo. So if we're looking at the first record is please, please me, and then the date is 1963, and then the label is Parlophone UK, and the positions is 1, and then the US chat position is 0. For PBI certification, it is gold, and then for IAA certification is platinum. If we go to our Excel, you will see it is the same file from the CSV, as you can see. 1963, that's the label, this is the position. Every dashes have to be 0. We done that, we have gold, platinum, great. So now, guys, what else we have to do? So let's go and, do kind of a select all from that table. Let's select all of them. And then I'm using, if you're looking at here, I'm trying to point this guy, okay? So if you're looking at here and you guys know documents, you can clearly see this is the object ID, right? We didn't define it by default. That's how it's gonna create. So now let's go and follow business requirements. So the goal to find all records where label happen to be Farokh US UK. Okay. So what I'm doing here, this is the label. This is the client, and then this is the DB name. And then what I'm doing here, this is the criteria. You guys know MongoDB, okay? That's the criteria. And I need that label to be equal to this guy, as you can see. And then this is my projection, okay? So if I select this one, you will clearly see I have 1, 2, 3, 4, 5, 6. If I go here in my CSV file and I select and you click on filter and I label filter on label where it is equal to follow phone UK, you will see that I have 7 records, but there is one record happened to didn't have any title. We remove this, and then if you take a look, you will see it is showing us 7 records. And if you remove this, it will be 6. And then this is exactly the data that you have in here, correct? So now let's do, for example, let's calculate how many platinum, gold, silver we have. This is a bit, intermediate, but I just want to do it because most likely the transforming and the cleaning, the processing is where you're going to spend most of your time, but I still want to make it a little bit fancy. If I execute this, you will clearly see, for example, that I know how many unknown records that I have, how many platinum that I have, gold that I have, silver that I have, 2x and 3x platinum that I have. You can clearly see it. And if business wanted to be into a chart, we can do that. So so we will need to import matplot library, okay, and numpy. As you can see, this is the same thing. This is the same query. The difference is that I have to define the x and y values, okay, to get that value. When I execute this, you will clearly see that this is what I have. And I was able to, get the job done. So if we're looking at here, you can see how ugly was the data and how clean we were able to work with that data to give it a better shape for business to go and, for example, make decisions out of that data. So now things you need to know. This is based on my experience where I have seen people get confused when it comes to data wrangling, cleaning, and mining. Okay, guys, wrangling is something data analysis or scientists will spend a lot of time because you have to convert that data into an intelligible format. Cleaning is like find and correct inaccurate data in a large data set, right? Mining is that when you sort data to find hiding pattern in large data set. So just for information, I want you to, understand each one, what exactly they do. Because wrangling, you will definitively need a pipeline to do the job, but cleaning could be part of wrangling, just for my information. Yep. So things that you need to know, as a best practice, you need to be able to interpret your data. You have to be able to interpret your data. So you need, you have to understand each organization can be dealing with the same set of data, but use it in a different way. If you bring over your experience from your old organization, I would highly suggest you to understand business logic and requirement before you go and apply any past experience. Otherwise, you may end up to get the job done, but it's not complete. It's not exactly what it business expected. And then you have to use appropriate data set, guys. So that's mean it's not about having a lot of data. It's about having the right data sets, guys. Okay. So make sure you are giving business exactly what they want. Nothing less, nothing more but what they want. And then you need to be able to reassess your wrangling data. So what I mean by once you implement that process, do not rely on it. You need to look for inefficiency. You need to look for error. You need to look for inconsistencies. You have to understand if business requirement change, you have to be able to change that process. And then you need to be able to transform your data for better analysis, because here's the thing. If you clean your data the way it's supposed to be, client will be happy, and then there will be less frustration from your end, right? So that said, I would love to say thank you. If you guys have any questions, feel free to ask. If I'm not able to answer it, I'll be happy to blog about it. Okay? And then enjoy the rest of the event. Feel free to connect with me. One more time, thank you and have a good one. Bye bye.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome, I am Keao, a maintainer of Keao Smash. This is emulating block device incidents through I/O scheduler. More accurately, we are talking about the Linux block device elevator design and how we utilize it to emulate the latency or limitation of IOPS. We actually have tried to inject the I/O latency in multiple ways in the past few years. I will also talk about other attempts we have made in the I/O port emulation, and I'm pretty sure this is the best method we have found. So I would like to share with you. As I have said, we are talking about the emulating block device incidents, especially high latency. You may ask, why does it matter? Are the engineers in the so-called chaos engineering area or alarmist? The EBS of AWS has 5.9 durability. Why would I care the left 0.0001? However, the EBS only promises provision performance in 39% of the time. If you are using a physical drive on the bare metal server, it will be much worse as the annual failure rate is around 0.9%. It obviously cannot support the SLA of your application. The programmers have designed a lot of strategies to handle the unexpected situations. Hurt bit, multiple replicas, auto transfer layers, blah, blah, blah. However, even if your code can handle the situation when some of the machines are down or some of the processes are killed by accident, that doesn't mean your codes can tolerate the block device incidents. Consider the situation that a process can do anything unrelated with the storage, like responding to simple network requests. However, it will always turn out for storage-related requests. If you are a developer of some storage systems, are you still 100% confident that the fault-tolerant strategy will still work in this situation? Before entering the main part, I would like to introduce the company behind myself, the PinCap. It maintains two open source softwares, PITR, a distributed SQL database, and Keao Smash, a chaos engineering platform. The TIDB tells us a lot of real-world problems we are facing, which makes the chaos Smash especially good at reproducing the real-world problems. I/O operations is one of them, and for databases or for any other storage system, it's one of the most important, most risky fault they should handle. Let's start with the normal I/O operation calling path and see where we can find something to inject. In short, the process operates on a file through PostgreSQL, through memory mapping, through asynchronous I/O, or any mechanisms provided by the kernel. Then the file system gets the request and decides where to read or write from the disk. There could be multiple read or write for a single I/O operation on client, as the file system could be complicated and it has a lot of things besides the real data, like metadata needed to manage. Then the file system submits the I/O operation represented as PIO, which contains the start sector of the block device and related memory locations. After submitting the request to the queue, the so-called queue, the file system only simply waits for it to complete. But don't lose our target. From the whole process, you may have thought about several ways to inject the I/O latency or error without touching the scheduler. For example, considering the first step, if the process always does its I/O operations from read or write system call, we can use ptrees to pause the process for some time. If we find it's writing something, just like attaching a breakpoint at somewhere, even if you don't know how, you can pretty sure you can do it through GDB manually or any automatically program. ptrees allows another process to get notified when the tree C is executing a system call and pause the tree C automatically. The mechanism is usually using a debugger like GDB or some audit system or user space system call implementation like gvisor. We can also use it to inject latency to any system call or user function calls. However, it cannot solve all I/O situations. If you are submitting the I/O operations through a mapped address, you are writing to a mapped memory, but it cannot be cached by the ptrees. Another consideration is that the AIO, if you are submitting an I/O request through I/O submit syscall, the behavior definitely shouldn't be a synchronous delay. The performance overhead of this method is also unbearable. It will slow down all system code. Another problem is that it cannot simulate the behavior of page cache. Reading from the page cache shouldn't be delayed. Okay, then let's see the second step. There is also an opportunity to inject latency. We can set up a hook file system to inject latency. The file system can be implemented to be slow and allow us to specify the latency. That's exactly what we have done in the past few years. It's a relatively good solution, I have to admit. The roadmap is quite simple, and the user space file system is also a proven technology and has been used in a lot of different places. Last year, I presented a talk, Test Application Storage Bit Stability by Injecting Storage Errors, also in the Percona Live Online. In that talk, I discussed the implementation of such a file system and how we reduce the overhead by dynamically replacing the file system inside a container. You can find the record of this presentation on the YouTube or Percona Live website. So I will only give you a brief introduction to this method. Take reading for example. The read syscall will be serialized as the user space file system request to the Keao and the Keao as the user space program will read the file in another folder to give you the correct response. From the technical point of view, the overall architecture is pretty simple, but the implementation has produced tons of the bugs. Writing a file system, even if it's only a virtual one, is really hard. The code base grows rapidly and soon becomes too complicated to manage. Except the file system, we also use ptrees in the project to replace the open file in the target process. And that is also easy to break. The performance overhead is also significant, as it will copy the data between user space and kernel space multiple times. After describing the two methods we have tried, let's dive further. In general, the deeper layer of the I/O stack, you will get less information about the user space application. You will not know which file is operating, which path is reading or writing. Meanwhile, the abstraction becomes much simpler. Every operation turns into a relatively simple request. It means if we could inject latency in the fourth or fifth step in this pipeline, we will not be able to inject latency to a single folder because we are not a file system. We know nothing about the file system. I don't know the path it's writing. but you could still inject latency to the whole disk. Most of the time it's enough, right? Let's see how it's finally implemented. See step 4, the theme of this talk has already been there quietly, the request queue. Yes, the request queue is just a scheduler. It's a data structure to store the requests, then the request can be merged, delayed, sorted in this so-called request queue. According to your needs, the scheduler doesn't have to be a queue, it's just inserted one by one like a queue. For example, if you want to sort the requests according to the sector so that you can merge the near requests, then you could use the arbitrary instead. To extend our understanding of the scheduler, we should also know the output of the scheduler. Yes, that's the hardware driver. The driver can dump a request from another queue. This queue is not the same with the previous request queue, so we call it hardware queue for distinction. The driver will read the request from the queue, from the hardware queue, convert it to something that the hardware can understand, like an NVMe request, and finally send it to the hardware through something like PCIe memory mapping and map the queue inside the memory so you can write the request in the memory. The output of the scheduler is just pumping its request to this hardware queue. In general, a modern multi-queue scheduler framework is something like this, the red part in the graph. There are many hardware queues. The number depends on the NUMA node or CPU counts. The elevator usually creates one data structure for each one of the hardware queues to make it faster, but lost the ability to schedule between these different data structures. Different data structures and different pumping strategies give us different schedulers. We are using this framework to inject latency. As all requests are stored inside the scheduler, we can delay them for any long time. We call this evil scheduler the IOEM. It means the IO emulator. The source comes from the NetEM, which is a network attribution emulator. It can be used to emulate the network latency, packet drop, or anything else. IOEM is here to emulate the I/O latency and IOPS. The behavior of this scheduler is quite simple. It stores the requests and assigns an expected schedule time for all of these requests. When the hardware queue wants to get a request from the IOEM scheduler, the IOEM can pick up the earliest possible request to see whether it has met the time to give it to the hardware queue. To both add latency to the I/O operation and limit the total traffic, we use the arbitrary as an internal data structure to help us to know which request has the earliest time to dispatch. IOEM also has a global traffic limiter, which maintains a counter to record the time of I/O operations of all queues. Remembering that there could be multiple hardware queues, so we have multiple arbitrary set lists. The whole process, as described in the former slide, has two sides. When a request arrives, we will calculate the expected send time for it and store the request in arbitrary sorted by the send time. When the time arrives, it can be stored in the list once the traffic limiter allows the request to go out. It can be dispatched to the hardware queue to send the request as early as possible. We set up a timer to periodically ask IOEM to check whether it can dispatch the request. After registering this scheduler, we can use FIO to test the IOPS. You can see the I/O limitation is really cool. The result of FIO is so near with what we have set. In this example, we only allow 1005 requests in 100 microseconds. And the result is expected, 14 to 15 kilo IOPS. Not that accurate, but it's still cool. I still do wow every time I use it to test our databases. The most fascinating thing is that this injection can be modified at any time. You can change the latency, limitation at any time. You can even change the scheduler to another one to make sure your application has returned to a normal state. It matches the spirit of chaos engineering. This injection enables us to inject latency in production environments. There are also other tools that can work on a block device layer, for example, the device mapper. We already have a device mapper to add a delay before writing it to the backend device. However, it cannot be modified at any time after the application has started. Above all is the implementation of the IOEM and the kernel modular. However, there is one more thing. If you know Chaos Mesh, it's a chaos engineering platform running on the Kubernetes. How could we combine the so-called low-level things with the super high-level Kubernetes application? It's also a long journey before we can get the real FD of the block device used by the pod. On the Kubernetes level, firstly, we have a pod, then we can get the volume from the pod. Now we can handle two situations. If the volume is the host path, then we can find it. If it's a PVC, then we have to get the related PV and get the corresponding block device or partition or directory. In conclusion, we can get a directory or a block device or a partition. Then we continue the processing on the nodes. On the nodes, if we are injecting a directory, we can get a block device or partition. If we already have a partition, we shall turn it into a block device. Finally, we can automatically modify its elevator and inject latency. The evil part of this implementation is that we transparently inject latency to the whole block device, and we cannot separate different partitions or folders. After all of this encapsulation, the user can simply apply an IO injection through a simple YAML file. That's nearly all of this sharing. Finally, I would like to share the current status of this project. The related kernel module has been implemented in this repo. It's compatible with CentOS 7 3.15 until the 5.15 LTS mainline kernel. We have done a lot of work on the compatibility, and there are still a lot of our users are using CentOS 7, which sounds not great. The Chaos Mesh integration is still in reviewing. Sincerely hope it can be merged in June or July so it can be published in the 2.3 version of Chaos Mesh to be released at the end of July. We are also trying to submit a kernel patch to the upstream. It's really necessary after 5.16 as some needed header files are not public anymore. We will need to eliminate something related with the cloud of Chaos Mesh and complicated filters and provide it a simpler way to configure it. And then we can send it to the kernel-related maintainers. Really hope we can meet IOEM in the mainline Linux in the future. Thank you. That's all for this sharing. If you have any questions, feel free to ask. I believe I was there prepared to answer your questions. If you have any further considerations, you can also contact us through the Slack channel, GitHub issues, or discussions. We are really having a lot of fun breaking other computers or servers. If you are also interested in chaos engineering, so maybe we can play together. Thank you. That's all.
Hi, everybody. Welcome to another Haas Talks Foss. I'm here with Liquan Pei from PingCap. How are you today, Liquan?
I'm pretty good, and I'm pretty excited to take this conversation with you.
Great, great. And so tell us a little bit about PingCap and what you do there for those who might not know about PingCap or TiDB.
Yes, PingCap is a company founded in 2015, and it starts with a project called TiDB. And TiDB is, I would say, a NewSQL or HTAP database. For people who don't know about HTAP, it's a short for hybrid transactional and analytical database, which means that you can process your ORTP workload and ORAP workload in a single system. And since then, since it's funded and it starts with building the open source project, and it has attracted, I think, over 2,000 stars, and it has already over 1,000 contributors of the project. And it has been used by many companies. I think we now have over 1,500 companies has adopted TiDB in production. In short, I think TiDB is a new distributed architecture. It was inspired by Google Spanner, and it has a layered architecture. Yeah, we can go more detail about that. And okay. I joined PingCap in 2020, but I've been know this company a long time ago. I know the founders since the year of 2017, at that time I was at Pinterest, and we have a project, and we call it like real-time indexing. And actually that's a good fit for TiDB. We did a quick kind of like a demo at that time. I think that is how I know about TiDB at that time. So that is kind of like some of history with TiDB. Now I'm here work as database engineer. But I do know in startups, especially we are still early stage in the United States. I also wear multiple hats. And okay. I did help with recruiting a lot. I interviewed maybe a couple hundred candidates last year and this year. And then I also worked very closely with a few customers, especially some key customers in North America.
Yeah, and many of the former people who I've worked with in the past have gone on to work at PingCap, many from the MySQL space, because PingCap's protocols are MySQL's protocols. They've yes. Made sure to mirror those, so there's a compatibility with existing MySQL workloads.
Yes, that's a good point. I think when we build that, I think we keep in mind that we want to be MySQL compatible. I think that is kind of the original goal, because we know that MySQL is kind of the most adopted open source database, and it has a lot of usage. And I think when the founders start build TiDB, they want to make the migration easy from MySQL. Yeah.
Yeah, and we've seen that, in this new SQL space, you've got, TiDB, you've got Yugabyte, you've got Cockroach. Yugabyte and Cockroach have chosen the Postgres protocol versus the MySQL protocol. So depending on where you lie on whether you prefer Postgres or MySQL, there is a solution for you. But maybe tell us a little bit about what NewSQL is, because people are using MySQL today. They understand it. Why would they need to move to the next level, to this NewSQL version that has more features? What do they get from doing that?
Yeah, I think that's a great question. My understanding of NewSQL is really combine the advantages of the relational database, which has a transaction capability and the SQL interface, right? And the scalability of NoSQL, right? Because NoSQL excels at scaling. It's pretty easy to scale. You can add nodes, and it can handle more, can store more data and handle more traffic, right? That is kind of what NoSQL excelled at. Whereas for traditional relational database, you have the transactions, right? This simplifies a lot to developers, because they can safely retry when something fails. Whereas if you don't support transaction, then you have to do a lot of additional work in order to make things correct.
Yes.
And that's one point. And the other thing is that a SQL is much easier, right? It's very expressive. You can do a lot of computations using SQL. You can do scans, you can do group bys, you can do joins, and then do analytics, right? You can do a lot of things. Even you can build machine learning libraries using SQL. So I've been working at a previous company that they called Greenplum database, and they actually build machine learning library on top of SQL. So you can do a lot of things with SQL. So this definitely can speed up the developer velocity. So I think that benefits. However, traditionally scaling a SQL database is pretty hard, and people choose to use sharding. And once you go there, and the application needs to be aware of the database sharded, and you lose the transactionality across shards. So I think with the new SQL, the sharding is transparent to the user, and the user still think you are working with a single node database. But the database underlying can be scalable. You can add new nodes, and then you can move the data around and automatically. And by adding new nodes, you can scale the database, serving more traffic and store more data. So I think overall, from the benefits to the developer is that, first of all, they're still working with SQL, and they are still mostly thinking it's a single node database. Then they have a higher developer velocity. And from the maintenance point of view, and you don't need to manage sharding, and I think that is kind of the benefits.
Now, one of the interesting things about TiDB is it is currently a completely open source, product. So anyone can go out, try it, use it, and get the benefits of this new SQL for themselves. But you can also contribute to it. You mentioned that you have thousands of contributors worldwide.
Mm-hmm.
So, it's a bit of a different model than a lot of companies are following. A lot of companies right now tend to, prefer some sort of proprietary-ish or not quite open source license, if you will. So, that's one of the exciting things about that, and that can help, definitely drive adoption. But, I talked with Morgan on our podcast, Morgan Talker, not too long ago, and he was talking about some of the hackathons that, the engineers at PingCap have put on for their community. And I was curious, have you been participating in those hackathons as well?
Unfortunately, I didn't, but I would love to.
Okay.
I think it's a pretty. I think it's a pretty fun fact. Actually, I watched a lot of videos, and a lot of articles talking about the hackathon. For example, using GPUs to accelerate or AP processing, and building a graph database on top of TiDB, right? Or building a file system on top of TiDB. There's a lot of interesting ideas, and also there are some features that I think customer really want, like the TTL in tables, right? This is a lot of customer want, and a lot of interesting stuff. So, yeah, I would love to do that, but I think the challenge with me, the time zone issue, really in the US. Yeah. I think there's a lot of events actually in the APAC region, so that's kind of what I miss those things. I hope that we can have a hackathon in the local time zone so that I can really participate. But there are a lot of interesting things out of it. For example, for the GPU kind of acceleration, NVIDIA also expressed some interest in knowing more about it and see whether we can collaborate in some sense. Yeah.
So your job is working heavily. You mentioned you're doing a lot of different hats because you're a startup, but officially it's working on the database kernel itself. Is that correct?
Yes.
So what sort of work are you doing recently? What sort of interesting things are you looking at?
Yes, I think one thing I was now looking at is kind of some new features in the database. For example, whether or when should we have dual partition in TiDB, yeah, and how to make TiDB more cloud native. This is something I was involved in the discussion. So, yeah.
And you're talking about cloud native in terms of being able to run on Kubernetes, automatically spin up new nodes, reshard, repartition as you need to?
Yeah, this is part of it. Also, I think another thing we need to look at is that how do we build a database that leverages the cloud primitives? For example, I can give you an example. For example, right now, the TiDB is using Raft to do data replication, right? And when a node is done, when I add a new node to the system, you actually need to copy the data from the existing nodes to the new node so that you can serve the traffic, right?
Yeah.
That is current like architecture. But then in the cloud, you have S3s and you have other like the cloud services available. And then you can leverage that to simplify those replication. So for example, you don't have to replicate all the data. You can probably replicate your logs, right? That's enough. And all the rest can be done through the S3, right? You can use S3 and then to download. And another thing you can leverage as the cloud is that typically the TiDB is doing compactions because they are building a RocksDB. And periodically they need to do compactions to kind of make the data more better formed, I would say, right? To deduplication, to make things like more structured. So, and that is done traditionally in the same TiDB nodes as in the nodes serving the traffic. And then when you do compaction, it can have impact on the online traffic, right? However, on the cloud, you can do things differently. You can actually do remote compaction. You can, okay, so you can say that, okay, I have a few dedicated machines, and then we can ship those files in those machines and do the compaction and ship them back. So at the end of the day, though, the machine serving the traffic will consume much less CPU when doing those compactions. You actually offload the compaction into dedicated resource, and as a result, it causes like a much more stable performance to the online traffic. So those are some kind of things, the benefits of the cloud native architecture, right?
Okay, so I mean, yeah, I mean, it sounds like, you know, a lot of the stuff you're working on is kind of twofold, right? Obviously, the performance and scale is always important, but also those operations, making it easier for things to happen behind the scenes. I know that, you know, trying to spin up new nodes is always a challenge, and yes, if you can hook into some of the things that are already available in the cloud, whether they're, you know, block storage, copies, or do snapshots, or take your backups from S3 wherever, that those are always good things. And obviously anything that you can do to speed up some of the back end maintenance is also going to be helpful. But when we talk about like use cases, and you mentioned TiDB has 1,500 customers and probably 10 times the number of users. I'm curious, is there a use case that you see that this is really popular with? Is there one or two different industries or different workloads that TiDB really excels at?
Yes, sure. I think we have like customers in the fintech space, and the customers, I think I want to maybe give two use cases. I think one are in the fintech domain and the other maybe in the SaaS domain. So I think for the fintech, that there's nowadays more and more like I would say that either online banking or there's P2P or customer-facing payments, right? For example, Venmo, Square Cash App, and there are other I believe companies in different parts of the world. For example, there's a company called New Bank in Brazil. They are they are offering credit cards, and there's another company in South America called B89. They are offering also similar to New Bank. They are offering the credit card to Spanish-speaking like customers. So I think for those companies, they want to offer good experience to the users, right? Because they are dealing with a larger user base, yeah. And I think they are have the challenge of scaling their business. For example, one of the customers we have is in Japan, and they are an online payment company, and you can basically send money to each other, and they have met the challenge that they cannot scale during peak hours, and especially during promotions. And then they are suffering a lot about that because the scale database they were using cannot scale the rights, and then they basically cannot do the promotion. The database is down. So that they decided to use TiDB because TiDB's architecture is a master, and you can scale both read and writes. And then once they migrate to TiDB, they no longer suffer any outages when they do promotions, and TiDB can easily handle 3 times of their current scale. This is one of the examples we have, which is the fintech, the online payments, and you are offering a service to the consumers, and they can do a lot of transactions at the same time. Yeah, because of it's a consumer-facing app. That's one
So
example.
fintech is an interesting space because it's one of those spaces that when you look around the industry today, everyone is concerned about, ensuring that not only do they have performance, but security. And in fintech, it's one of those things that security is even further along. So maybe tell us a little bit about, some of the things that you're working on from a security standpoint to make sure that, the code that's going out there and the feature set can handle a bit more of a secure environment like that.
Yeah, sure. We have like the TLS between all the components and the client and the cluster. Okay, and also we have encryption at rest, which called also TDE for our storage layer. And then we have also authorization and authentication system in the TiDB layer. And beyond that, I think we also offer audit log for the users that they know what's happening in the database. So here are some features we provided in the database itself. On the cloud services, you know that we probably I should mention that we also offer hosted TiDB. We call it TiDB Cloud. And for that, we have actively kind of like doing compliance stuff. So for example, we have passed SOC 2 Type 2 and also the ISO 27001 recently, and to show our continued investment in the security. Yeah.
Okay. Yeah, I mean, it's always interesting to see because the bar for not only performance but security keeps on becoming, bigger, higher and higher to clear as these systems become more critical, especially in some of these ancillary spaces.
Yeah.
But from an engineering perspective, I am curious. Like, what are some of the interesting, maybe fun things you've uncovered looking at the code base, for TiDB? Are there certain things that surprised you when you started to dig in? Were there things that you thought were very interesting, or that you think is pretty unique?
Okay, pretty unique. Okay. Yeah, I think the pretty unique thing is usually when you work with a distributed system, some pretty simple thing can be really complicated. So that's one thing. I won't give you an example called, I'll say the bin log or change data capture, right? And I think if people has worked with MySQL, and they should be familiar with the bin log, right? And the bin log can be used to do data replication, set up like a the primary, secondary like architectures, right? Yeah. So those are interesting. And I think for a distributed database like TiDB, and then if you do bin log change data capture, there's a lot of like interesting problems you may never think of when working with compared with working with a single node database. For example, because TiDB supports distributed transactions, and all the transactions can happen on different nodes, right? And if you're doing a change data capture or a bin log, you can gather this data from different machines, right? Mm-hmm. But if you really want this data to be useful, you do need to output the data in a transaction order so that you can build like a primary, secondary architecture, build your DR system, right? However, then there's a challenge is that because everything is distributed, you get a lot of things like in the order of modifications, but not in the order of commits, right? You can start a transaction, and this transaction can be very long and can then committed very late, right?
And span multiple nodes.
And then even you don't know when you receive everything, right? Because everything is distributed. You don't know, okay, whether I have received all the updates for this transaction, right? Then this really becomes like pretty interesting. So I think for the distributed kind of transaction, we actually utilize research actually from big data. I think there's a paper called NAIAD, published by 2013 by Microsoft, that they're actually building a data flow system and using the concept of the result timestamp. And the idea of result timestamp is that you know that before this, once you receive this, it's like a watermark in the stream processing system, telling you that once you receive this event, everything before this timestamp has been received by the downstream. Then you know that all the events are, you see all the events, then you can send them to the downstream. Other than that, you cannot send to the downstream. And this is pretty fascinating. And without this idea, you cannot really reconstruct your transaction order, right? So I think this is something I really like.
Yeah, that's interesting. I mean, in when you think of a distributed system and a distributed, SQL system, for those of us who have been in the database space, you're used to being able to monitor nodes, even if there's multiples in a cluster. But because of the distributed nature of the transactions, it can lead to other issues, not just with the, trying to piece together, the transaction logs, but also the observability and the monitoring and being able to figure out, which potential node might be having issues, or trying to piece together that has to be a challenge from a back end perspective as well.
Yes, I think I totally agree with you. So I think the challenge with distributed system is like you have to deal with failures, right? So you have to deal with failures, and you need to make sure that your system behaves correctly with those failures. So and then also because it is kind of like handling a lot of things at the same time, right? So those are understanding what happens is pretty challenging, especially where support like SQL queries, and also we support complex SQL queries, and figuring out what consumes the most resources. It's kind of challenging.
Yeah, and I mean, I can imagine that it's hard enough sometimes to find the problem area.
And also that there are there's a lot of kind of like background works like compaction, like the garbage collection, like the synchronization between the column store and row store, right? There's a lot of back end, and then the replication, then the transaction logic, right? It's kind of like a lot of things going on at the same time. And beyond that, there's constant failures. You do need to move data around, and you do need to understand the environment in all this kind of dynamic, in this very dynamic environment, and ensure everything is correct, even with all this dynamic correct. Imagine the case that you still want to support ACID, right, for all the transactions, given that the data is constantly moving, there's constantly failures, there's constantly retries. So there's the region splits, region merge, right? So that is kind of what really I do really like.
Yeah, I mean, it's fascinating because as you start to go in as a database person, as someone who's running this, to be able to understand where a problem is, where the issue is always that interesting step that from an engineering perspective you try and fix those without escalating them up or letting people know about them, but eventually someone's looking for.
I think that's the beauty of the database. You had a lot of complexities inside, right? And for the user see, okay, I think we are just running SQL, and I think for a lot of I've been working with people from other working mostly in the upper level in previous companies. So they are really mostly dealing with the running SQL queries, not writing SQL queries. They would think that SQL system is pretty magic, but I mean, for a database person, it's really they had a lot of complexity there. So
Ah, very cool. Well, Li Quan, I want to thank you for stopping by and giving us a little bit of an overview of TiDB and some of the things you're working on. Always good to catch up. Appreciate you stopping by.
Sure. Thank you.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, my name is Anton. I'm working with dashboards in Percona, and today I want to tell you about how optimizing the storage of large volumes of metrics for a long time in VictoriaMetrics. First of all, nowadays the main tools for monitoring the operation of any application are metrics and logs. An important role is played by the time of their storage. Often, in order to understand certain processes and predict their development in the future, we need to analyze metrics over a fairly long period of time. In the case when the project is just starting, where volume is relatively small, but over time it becomes larger and larger, and there is a need for optimization. In this article, I will touch upon the mechanism for processing, storing, and optimizing metrics during their long-time storage. Let's talk about VictoriaMetrics. As I mentioned before, I want to tell you about how we store metrics in VictoriaMetrics. The mentioned solution and the base for storing time series VictoriaMetrics was released relatively recently in 2018. But has already gained popularity. Initially, VictoriaMetrics was designed as a time series database, but over time it has grown into a full-fledged alternative to Prometheus with its own ecosystem. VictoriaMetrics is currently a fast, cost-effective, and scalable monitoring solution. You can deploy the application either from binary file, a Docker image, or a snap package, or build it yourself from source code. Single node and cluster versions are available. The main reason for switching from Prometheus to VictoriaMetrics for us were significant savings in system requirements and the ability to work in push mode. Also, important factors in favor of VictoriaMetrics were ease of installation and subsequent support, the possibility of more flexible performance settings, and the availability of features that are not available in other applications. For example, Prometheus lockdown sampling. Despite many external tests, we wanted to get our own data. Test bench and we created a test instance for understand how many resources we need. Test bench configuration had 2 CPU, 7.7 GB RAM, and 25 GB hard disk drive. The test lasted about 12 hours and have 344 billion metrics. Let's check what we get from resources. From hard disk compare side, we can see that Prometheus use 10 and 39 gigabytes, and VictoriaMetrics is use 9 and 67 gigabytes. Here there are no big difference by size, but if we store metrics for a very long time, this is maybe very useful. What about CPU? About CPU, another picture. Prometheus use 74.28%, and VictoriaMetrics use only 32 and 86%. There are no comments here. I think VictoriaMetrics must have by CPU, because CPU is to cost very much in the cloud providers. As I mentioned above, let's talk about pull or push model. About push model. As for pull, it works as follows. Exporters work on the target host and collects metrics where in the classical scheme of work, Prometheus pull where exporters and collects metrics as specified intervals. This scheme of operation has a significant disadvantage as we need to maintain several ports open. What I mean here? Let's take as a sample permissions. Our permissions server send request to exporters. Sometimes we have a firewall and we should have opening ports to get our request. And in our sample, with ports is 4230, 42201, 42202, and etc. And when exporters get request, it send a response. Response sent by another port. In this sample, by classical HTTPS port is 443 port. This is classical. And when we have a firewall, our incoming request may be blocked. This is not good. And let's talk about push model. Push model working like this. When use him, use VM agent. VM agent work on the client sides. It go to our exporters and scrape metrics, and after it push this metrics to the server side. There are no open ports. Also, if we lose network connection, it's storing metric in the cache and resend it when connect will be reconnected, and in such case we have no loss any metrics, and we have no gap on the graph now Grafana. I think push model is more better than pull model. And is also, as I mentioned above, VictoriaMetrics can work in two modes, single node and cluster. Let's talk about it. Single node version is used for relatively small amounts of data, less than 1 million metric per second, and does not provide scalability and fault tolerance since all application components are connecting into monolith. VictoriaMetrics consists of the following components: VM storage, the storage itself, VM insert endpoint for receiving metrics based on the permissions remote write type, and VM select, a component that allows you to make queries using the permissions querying API. In the official documentation, the developers recommend using the single node version and use cluster version only if you are real need and you understand the consequence of such decision. Let's talk about what is it TSDB. TSDB, this is a time series database, is used as a database for storing metrics. TSDB has many differences compared to relation database. Well, such as write operation prevail over read operation, there are no relationship between data. Since the metric has one value of certain points in time, there is no need to nested structures. Typically, an amount of data is large. The unit of data is such a database is a time point. Now, the data structure of such a point consists of timestamp, time in Unix format. You can see it. It's the left side of our screen of here with it name time. The next field is a name field from which the name of the metric is taken. This field can be missing, but this is in anti-pattern because in any case we need to know the name of the metric we are tracking. And some additional fields with labels, label fields that are needed for any actions with metrics, aggregation, but some attributes, filtering, etc. And a field with metric value. And we have 4 kind of fields, 5, first of it time, second name, next some labels, and the value of our metric. When the data is recorded, time series are formed. A time series is a sequence of strictly monotonically increasing data points over time that can be accessed using a metric. Let's talk about how we can change some settings in the VictoriaMetrics to storing to keep many metrics for a long time. Let's talk about flags. VictoriaMetrics have many flags, and here we talk only about 5 of them as a sample. If the number of metrics and their storage time increase, the amount of required resources for the application in availability increases too. VictoriaMetrics has mechanism for adjusting consumed resources. The first with the memory.allowed% and memory.allowed bytes keys allow to limit the amount of memory for external buffers and query caching data. Next flag is a search.max Unicode time series key prevents excessive resources consumption when execution large queries, and in some cases can prevent the application from caching with an out of memory error when execution large queries. This parameter is set by 6 billion by default and reflects the number of Unicode series returned in response to the request to /API/v1 query and /API/v1/query range endpoints. Also, very useful flag is search.max samples per query key, which limits the number of returned metrics in one query. The search max query duration key is responsible for the time to wait for a response to a request. It means when we send a very huge request and we can waiting for answer is very long time. And we can limit this time by this flag. Is when it the time is go out, we get error, and we can change our request why it working for so many times. In general, there are fairly large number of cases that affects performance. In the post, I mentioned only rules what we use in our practice. And another very interesting feature is downsampling. I think this is a killer feature of this application, VictoriaMetrics. As an important feature of VictoriaMetrics is downsampling, the ability to delay data as it becomes obsolete. Its functionality is available only in the enterprise version, but it is also built into Percona monitoring and management. As I mentioned above, in the paragraph describing the features of TSDB work, time series must have a large amount of data and be unchanged in order to obtain maximum sampling efficiently. Well, downsampling period key is responsible for the work. Example, the frequency of collecting metrics in our case is once every 5 seconds. But in this case, the volume of the database will grow very quickly, and we have a large amount of metrics. So we define a policy for storing metrics. After 1 hour, we store metrics with an interval of 10 seconds. Every other day, with an interval of 30 seconds. After a week, with an interval of 1 minute. After a month, with 5 minutes. After a year, 1 hour. So it will look like this. Downsampling period 1 hour 10 seconds, 1 day 40 seconds, 1 week 1 minute, 30 day 5 minutes, and 1 year 1 hour. And this we reduce our volume to a very small size. Let's talk about another feature. It called deduplication. Deduplication is a technology that allows you to analyze duplicate data and replace it with an appropriate reference. The use of deduplication can significantly reduce the amount of data. It is used with Prometheus or VM agent are working in high availability mode and write to one VictoriaMetrics instance. In this case, we definitely need deduplication since the database stores overlapping data, which significantly increases its volume and in case of large volume. The data request time. Now, where mean scape interval case is responsible for the operation of the duplication. For example, deduct mean scape interval is 60 seconds, means that within the same time series, all data will be collapsed and only the first points within 60 seconds will be saved. Science version 1.77 VictoriaMetrics with the last row sample per each deduct mean scape interval discrete interval. It is recommended to set this parameter to scape interval the same time for metrics. According to best practice, scape interval should be same for all metrics, but this is a topic for a separate post. Let's check by sample. Before the duplication, we have some data points: 5 seconds, 10 seconds, 15 seconds, 25 seconds, 35 seconds, 45 seconds, and 55 seconds. And then we have 4 kinds of interval. First of which 0, from 0 to 15, second from 15 to 30, third from 30 to 45, and fourth is 45 and 60. In this interval, we have some data points. The first is 5 seconds and 10 seconds. Second is 15 seconds and 25 seconds. Third is 35 seconds, and fourth is 45 seconds and 55 seconds. And VictoriaMetrics is kept only one the first data point. And after the duplication, we can see of only 4 data points: 5, 15, 35, and 45. And the data point 25 seconds is lost. Why? Because we have a scape resolution is 10 seconds, and we have the duplication is 15 seconds. And we should have scape resolution in the duplication is the same or equivalent to prevent this case. Another interesting feature is rotation of metrics. Rotation of metrics is where removed when they become obsolete. Where retention period K is responsible for rotation of the VictoriaMetrics. By default, this period is 30 days. Therefore, you should immediately set the required storage period when launching VictoriaMetrics. Let's dive a little deeper into the features of data storage. Example: we set the metric rotation time for 1 year, for 4 months, 2 weeks, 3 days, and 5 hours. When we use this flag, retention period is 1.3 year, 2 week, 3 day, 5 hour. Why we use this? Here is a fractional number, because here, to avoid the confusion with M letter, which can mean both the months and minute, and developer is recommended to use this to prevent this confusion. Based on personal experience, a sufficient data retention period for metrics will be 1.5 year. And also, worth emphasizing that you plan to store data indefinitely, you still need to set this key for very, very big data, about maybe 900 years, because if you choose 1, because you choose 0, this is you get error. And let's check how we run VictoriaMetrics with which flags. First of it, retention period, we mentioned above, 1.5 year. Next, storage data path, where we storage our data with metrics. Next, in which address, in which port we run our instance. Next, how max query length we can send to VictoriaMetrics to prevent, also to prevent some load to our service. And some other flags, as we mentioned above. And conclusion. what we do in this case. We configure downsampling, we optimize query execution to prevent some confusion with our server, and sufficient data retention period for metrics will be 1.5 years. That is all. Thank you for attention. You can contact me by this email. Thank you.
Hi, everybody. Welcome to another Haas Talks FOSS. I'm the Haas, Matt Yonkovit, head of open source strategy here at Percona, and I am joined once again by Bruce Momjian from Enterprise DB. Bruce has been on this podcast before, and we had been ships passing in the night last week at the Postgres conference. You know, we saw each other but didn't get to catch up, so we figured why not get on a call like this and chat and catch up on what's going on. And you know, so it's always exciting. You know, we've got other conferences. We're starting to be in person again. I don't know about you, but I'm glad to actually talk to people in person. Right, you know.
And, there was a lot of energy in San Jose because everyone was together, and a lot of stuff you couldn't talk about online. It was just too hard to really get the emotion across. It's much easier in a group, together in person.
Yeah, and there were so many people to talk to, right? So you got to talk to a little bit of everybody. You're like, I haven't seen you in a while.
Very true.
Yeah. So, so Bruce, you know, I figured maybe we would just catch up on a few topics, see what's trending, see what you're seeing in the industry. You know, you are as plugged in can be, you know, in terms of the Postgres community. And so I'm curious, what sort of trends, things are you starting to see evolve as you're looking towards the next year? You know, you've been talking with folks, you've been following the mailing lists. Are you seeing a couple patterns or something that we should be aware of in the community?
Well, probably the big issue this week and last week actually was how to deal with the Russia issue. So I've spent a lot of time on that because obviously as a person in leadership, it kind of becomes my responsibility to keep an eye on that. You know, we talked earlier about risks to the community, right? What does that look like? You know, and it kind of spans quite a wide spectrum. For example, if we have committers in these countries, what if they can't communicate with us securely? What if they don't feel they can actually tell us if something's wrong, right? Yeah. And so we kind of did that due diligence to find out who has commit keys in what countries. And are all these people feeling like they can communicate with us? Because if they can't communicate with us, then effectively something bad could happen to them, something bad could happen to their keys, and we would not be aware of that, right? The second issue that's kind of hot, the same topic, is how to deal with people who want to disengage with Russia and Belarus. So we had somebody this week who did not want their blog entry syndicated to those countries. And, you know, how do we handle that? Do we require so we have a Planet Postgres which syndicates all the blogs together, and they publicly posted that although my blog summary will appear in Planet Postgres, anyone in Russia or Belarus who clicks on the link to see the full blog will actually not see it. And how does that? It's certainly the right of that person to do whatever they want. They're creating the blog content, but to the extent that that we're syndicating that, is that acceptable? What does it do to the user experience if everyone was to do this? What if Russians were to post a blog that was only visible to people in Russia? Would we accept that? Right? Like you see how it could kind of spiral out of control.
Yeah, and I know this is a topic that is a hot topic. In fact, Amanda Brock from Open UK is going to be talking at our conference specifically about some of these topics from an overall open source community perspective, which should be interesting. It's a slippery slope, but it's not the first time we've had a bit of controversy around this. If you remember, GitHub blocked some countries when they had embargoes against them, right? So if you were in certain countries, you couldn't get to your GitHub project. And that was a big hubbub a couple years ago because it was like, oh, wait a minute, what happened with this? Postgres being in a bit of a different space, but it does follow that same kind of geopolitical pressure, if you will, because countries come and go on, these different, embargoes. So you have not only governmental regulations on what's allowed, but then you have moral and ethical questions that come up. And it's a very difficult topic because, you do see some open source projects start to develop morality clauses and focus on, do we need more ethical, like compliance things? But that's a dangerous slope as well.
Yeah,
because,
it is.
If you think about, from a license perspective, you can use this software unless your name is Bruce,
Right.
or, that how do you enforce it? How do you ensure that happens? So it does become a little dangerous. And you might have seen there was several articles, over the last, month or so since the war in Ukraine started, where some people actually put in poison pills in their open source.
Yeah, that was really serious, and obviously it affects the reputation of that project. It also, some ways, spills out to open source in general, right?
It does. Because it seeds doubt, right, in a company.
Yeah, and this is not. I did write a blog entry on my website called "The Abuse of Open Source" with a question mark, because this is not a completely new thing. When you think of, you go back to Alfred Nobel and the dynamite and him creating the Nobel Prize to sort of offset the damage. Think of the Manhattan Project engineers trying to prevent the use of the atomic bomb against Japan. But also, even more recently, there was some open source concern about the use of open source by the U.S. Immigration and Custom Enforcement, ICE. And that was sort of, it came and went. Really didn't really stick very much. But yeah, it's sort of like, how do you put the genie back in the bottle? If it's knowledge, and software in some sense is knowledge, right? Can you restrict that knowledge? And if you do, what are the ramifications of that? And that's really where we've kind of come through. I mean, obviously the open source the term of what would be considered open source by the OSI does not have any discriminatory use to it. But then how do you deal with a blog entry that you're syndicating that has discriminatory use? So we're just kind of keeping an eye on it. It's not something we're ready to take an action on. Obviously, if it became widespread, and in fact, the blog entry explained in detail how other people could do the same thing if they want to, showed Nginx examples of how to do it and do geolocation stuff. So the person in some ways is advocating that others follow this pattern. I haven't seen anybody follow it. If it becomes followed and it really hampers the usability of Planet Postgres itself, that could be a concern, and maybe we have to add, because the bottom line, and you aware of this as well, is that open source, by definition of the OSI, has no discriminatory real use to it. So how does that OSI license for the software, how much does that spill into the infrastructure that we support and the Planet Postgres infrastructure that we support, and how does that deal with content creators who may have discriminatory, right? And so that's if you want to know the hot topic for the past 2 weeks, that's it. He just did it basically 2 days ago or a day and a half ago. So it is the hot thing. I've been working with the Russians for, since the invasion, making sure they're okay, trying to, obviously Postgres has relied a lot on Russian technology, Russian software, engineers, and all that, a lot of that non-relational stuff came from the Russians. So that I'm going to be speaking at Percona Live. So, how do you honor and show appreciation to the work that's been done in the past by a very dedicated Russian team, at the same time not supporting an invasion, and how do you also help them who probably are as upset or more upset than we are? I put a personal blog out yesterday, basically saying, the title is "The Russia I Grew Up in Doesn't Exist Anymore," and this is a gentleman who left Russia for Georgia, and he basically said, I'm talking about the hope for this country to be happy and free. It's gone. It's not there anymore. And it probably will not happen now in the next 20 or 30 years. And, we're sitting here trying to understand what the new normal is. But the Russians who really understand the tragedy of this are also trying to figure out what the new normal is, in a way that impacts them even more than us. And the gentleman also, talked about how tragic it is in Ukraine, and certainly more tragic than it is for the Russians. But it's trying to sort of explain that what that looks like going forward for Russia is really very unclear and very dark.
Yeah, no, and I mean, from a Ukrainian perspective, we all have colleagues. Lots of Percona employees are from the Ukraine and Russia.
Yep.
Our founder, one Ukrainian, one Russian.
Yep.
And I think that from a overall perspective, no one that I have talked to that I have connections with in the community space, thinks that anything that's going on is right or just
Exactly.
or morally
Exactly.
justified. It is a horrible situation, and it's amazing the dedication of those folks in Ukraine, and not only do they love their country, but a lot of them are still working, and it's and under the stress, and it's you have a lot of admiration for people who are willing to stand up for what they think is right.
Yep.
Now, without minimizing that very difficult situation, and that is a tragic area. Let's shift over a little bit to some of the more technical topics, some of the Postgres side of things.
Mm-hmm.
And I had given a talk last week, and it was interesting. My talk was on how developers are going to impact the future of Postgres, and the development cycles. And I wanted your take on this, because this is a trend that I am seeing more and more. I'm going to say something that many people disagree with me, but I have a reason, so I might have to explain. A lot of developers, end users, don't like databases, right? They don't think databases are cool. They'd rather spend their time doing other things. A lot of times they think they're too complex. And the needs for people to move fast and not have to think are increasing. And that's not necessarily a good thing. I am not I don't condone that, but I am seeing more and more people looking at no code or low code solutions. For years we've had to deal with ORMs connecting to databases.
Yeah, exactly.
For years we've had frameworks and things, but we're starting to see an escalation in terms of the needs and the desires, and almost a de-evolution of the skill set that most database professionals have. And so that worries me a bit in terms of inflection points from a open source database perspective, because it means less feedback, but it also means people doing things that the databases were never intended to do. which could result in new features, or it could result in, entirely new projects or crazy things that try and take what we've already done and evolve it into something completely different. And I don't know if that's a trend you've been tracking or seen, but I'm curious on your take on that.
Yeah, it's funny. I thought of something that I had never really thought of before, because you were talking about, right, how is what's the new normal here? What are people kind of wanting from a database, right? And I kind of go back to my time as a developer back in the 90s, where we used to write applications. And a lot of times I'm afraid the developers approach the data store of their application as though they're the only person running it. So they're basically in their head, as they're out thinking of their application, they're thinking, okay, I got a flat file here, or I got, an ISAM thing here, whatever. And when I'm writing my application, I'm like, okay, I read a record, I put a record back, I read a record, the standard ORM kind of approach. But they're not, they don't really want to embrace the fact that thousands of people potentially are doing it to the same data store at the same time, that there may be billions of records in there that are getting analyzed, that are getting joined, that are getting processed in other ways. And they're frustrated. They're frustrated that, why is this so complicated? Why can't I just get my data? If this was a single user application, I wouldn't need any of this, right? And they may be right. A lot of cases, you don't need a relational system if you've got a small amount of data, and it's not, they're a single user, so, and of course, SQLite's a fantastic solution for that, although that itself is SQL, so maybe that's negative, I don't know. But it feels like there's so much focus on tool sets and tool chains and the new development paradigm of the month. It seems that they just don't have time. They don't have focus. They're very focused upward out in what the UI looks like and sort of how that's going to display to people and what's the user experience going to be, and that's great. But they don't want to look at that bottom piece. I think one of the things that makes me unusual is I've always been a tinker. I always go downward. I'm always like, when I started with computers, I read CPU books to understand how does the hardware work? How does the IO work? I remember looking at UARTs and, how does ISA bus, right? And because of that, as an application developer, I started to look at how does the database doing what it's doing, right? Because I'm wanting to understand downward. If I'm understanding the hardware, I need to understand how the data, and I got involved with Postgres because of that interest at the lower level, right? But the question is, how do you do that for people who aren't inclined in that way? And that's tough. I mean, I think a lot of the stuff, a lot of the non-relational stuff that Postgres has really is very fascinating. And it does. I think one of the reasons it's resonated with so many developers is because it gave them a reason to like relational systems. Because all of a sudden, you could, it wasn't this very restrictive thing, and you could do these cool things that would be really hard to do in your application. And I almost think as a relational database, we have to continually market that. And I think the best way to explain it for me is that having understand the server, understanding how MVCC works and how locking works and how aggregates work and all of that query optimizer stuff works, right? All of that kind of fits together to make the developer's experience super simple, right? Because that's the beauty for me of it. Because if you don't use a relational database, you need something complicated done, you have to do it in your application. So I'm always, regularly telling people that the database is the thing that makes your application simple. And as soon as you leave the relational system, whether you're going for a NoSQL solution or something else, your application, as you're saying, is going to be a lot harder. And you're going to do stuff that you really shouldn't be doing, like a nested loop in your app when you should be doing a hash join or a merge join. You may not even know what those things are. And you certainly don't want to be writing them. And you certainly don't want to be writing them in a way that you auto detect what type of result set should use which type of join in your app.
Now that reminded me of a story.
Yeah.
So I was actually helping a company, and the company doesn't exist anymore. Really bad model. Their model was to create a social media like app or website for your music playlists. So it was a little unusual, but I remember going there, and these were really smart MIT, Stanford folks, and they actually just selected all of the data out of table A, all the data out of table B, and then they joined it in Java. And then they did their joins in Java. They filtered out the data that they wanted, and then they threw it back. And then they went and they got another set of data, and they did the same thing. And they couldn't understand why the performance was so atrociously bad. And it's like, why do you think you're smarter than the people who wrote the joins within the database? Why are you taking everything and reinventing the wheel? But they thought, because they were super smart, that they could outthink, the database and do it in a better, more efficient way. I mean,
yeah.
At least I have to give them some credit for actually thinking about how joins work, because I think in a lot of cases people don't even think that. But it is a strange thing, because you're right. A lot of people, they'll not understand the database, how it works, and that causes issues. And I think that there is a difference, though, between those who don't care and those who just don't have the time, right? And so I think it's a nuance. But I think some people do care, and they kind of they'll just trust that the database handles it and just figure it out later. And those people, they can develop bad code, bad designs. They can cause all kinds of issues. But then there's the ones that just don't care. And I think those are a bit more dangerous. But I think that where I'm a bit concerned, and this is one of those interesting things, the rise of people taking parts of Postgres and building other databases and trying to establish new kind of norms. I wonder what your take is on that. And what let me give you an example, right? You've got some folks will take the Postgres client libraries, Cockroach, Yugabyte, other folks. I mean, great databases, great technology, have no problems with them as companies, but it's a trend to kind of replace the back end of Postgres. And then I see other ones that are taking and sticking with the back end of Postgres and adding compatibility layers on top to change all of the client protocols to make it something that it isn't. So it's weird, because it's Postgres-like, but it isn't Postgres, right? And right. So, I'm like, ooh, how does this fit into the new ecosystem? And is this one of those, you're going to be talking about challenges and risks. Is this a risk where, you start to see a bit more of a fracture, or is it something that we say, this is just yet another kind of distribution? I just had someone on a podcast who, likened Postgres to Linux, right? And so this is just another distribution of Linux. Mm-hmm. And so it's an interesting take, and it's a bit of a slippery slope. And, it's something that I've seen more and more of. And so, and I'm not saying any of these technologies are bad. I'm not saying they're doing anything wrong. I'm just curious where this takes the ecosystem in the next 20 years.
Right. Yeah. I do have a slide actually about that in the deck for competitive challenges. So the good news is this is not completely, this is not entirely new. I mean, we've had sort of forks of Postgres way back to when I started. So I think Netezza might have been the first one who basically tailored it for FPGAs. So they had an FPGA storage kind of solution in the early 2000s, late 90s. I think it's pretty far back. Then we had some ports that ported Postgres to Windows before we had a port. One was out of Japan, one was out of Boston. Then we started to get a lot of data warehouse forks. Certainly Greenplum being the best one. And then and now we're getting more of the distributed forks. I almost feel like whatever sort of hot topic there is, some startup kind of comes along and says, hey, let's do a fork of Postgres and do X, right? We've always had, as a community, mixed feelings on these things. I've always been of the opinion that the forking has two possibilities, right? The first possibility is that the new fork becomes so popular that it basically eclipses the original project. Now, you might think that's kind of bizarre, but if you look at, I believe it's was it EGCS, the GCC compiler that effectively was a fork of GCC, and it became so popular that the GCC people had to eventually take it and make it the new GCC. Okay, and the reason for that was because the GCC project had become so conservative in adding compiler optimizations that EGCS came along and it did stuff everyone wanted, and everyone was like, well, this is all we want, and if GCC isn't going to do it, we're going to use that. So GCC had to move over and just say, that's what we're going to use from now on, and all the current code for GCC is now really EGCS in a way, right? The second possibility is that the project, the fork becomes this extra thing that sort of takes a workload that the original thing doesn't do, and tailors it for that. Whether it's, for Greenplum, it would be data warehouse. For Yugabyte, it would be distributed, and it doesn't do what the original does as well, but it does the distributed thing well, right? And I frankly am fine with that. I really feel that effectively, as that new workload becomes popular, either we bring some of that code or those ideas into Postgres, or that project continues to grow, but they also need the community to grow at the same time, and they basically help to fund and bring Postgres forward. So, if we look at Greenplum, there's been certainly a lot of engineers from Greenplum who have helped us. There's a Percona Postgres, right? I think there's EDB Postgres. There's a Fujitsu Postgres, and as far as I know, all of those projects are helping. RDS, certainly Postgres is bringing in a lot of engineering help. So I kind of see it as better. It's really a question of whether you see the world as expansive or limited, right? If you think of the world as having limited resources, limited opportunities, and you have to basically close off the challenges to your world, then you're going to see these forks as negative. If you think of an expansive universe where they're opening up the use case for Postgres, they're opening up the visibility of the project, and you have to have the confidence that the project's strong enough to remain viable and visible in that environment, then you're gonna embrace that. Even if, for example, Greenplum for the first 10 years or whatever really just forked Postgres and didn't really come back a lot. There wasn't a whole lot of feedback. And then a couple of years ago, they're like, oh, we really need to get up in current Postgres. There's a huge lag now. We're missing a lot of features. Let's get some engineers involved. Let's bring the code up to current Postgres. I don't know where they are on that now, but the point is that fork, and certainly the EDB fork with the company I work for, has helped fund the community. And if we prevented those, then we wouldn't have those, we wouldn't have those resources.
Yeah. And I mean, I think it's the philosophy of you make the pie bigger, everyone is more successful, right? So more contributions, more people who are contributing to the ecosystem, more eyeballs more usage,
Right.
is we don't need to fight over the same territory right now.
But you have to be a healthy project. You have to be nimble. You have to be one that embraces new people coming in. It doesn't happen by accident. And if you're rigid like the GCC was, then this is going to be a problem. You really have to be you have to be pretty strong. And in fact, I have another slide talking about whether cloud could eclipse open source. That's another similar concern where the cloud becomes a fork, the cloud deployments, the cloud database services become a fork. Could they become so big that people don't even know the project exists, right?
Oh, yeah.
And what would that look like? So it's a similar kind of case that where you have this service that's out there that's kind of fortunately they're using your name, right? So you're kind of okay there. But could it become so big that nobody even downloads your software anymore? Nobody knows who you are. People don't think there's a way of getting involved except through the cloud provider, right?
Yeah, and that is a risk, right? That is a risk.
Yeah.
So, Bruce, I like to I started this since our last podcast. I like to end with kind of a rapid fire set of questions, just some random things.
Sure.
Just interested in your people can get to know you a little bit, and also give you the opportunity to share some insight. So, what is your favorite upcoming feature in Postgres 15?
Probably, if I take a guess right now, the movement of this is really geeky, the movement of the stats collector to shared memory. That was a big thing for us. So it's something that's been a long-term issue that I think is gonna improve quite a bit.
What was your favorite release of Postgres? Like, do you have a favorite? Like, this one was just
probably the one that added the Windows port was the coolest. Yeah.
Okay.
That would be 8.4, 8.3, something like that. Yeah. 8.0, maybe it was 8.0, I can't remember.
Okay, fair enough. Last book that you read?
The last book that I read was a book on Amish history.
Oh, okay.
Yeah, very interesting. I'm on my fourth Amish book. I'm looking over it there at the bookcase.
Oh,
something I've always
excellent.
been interested in, and because of the pandemic, I'm home a lot more. So, all right, let's get to the books.
All right. So that's an interesting one. So also curious, if we are to meet you at a conference and we're to go to dinner, what's your favorite food?
Well, I just came back with a conference. I had 2.5 ribeyes in 5 days. So I guess it's ribeye.
Oh yeah, so steak eater there. That's okay.
It's not necessarily my favorite, but it's the one I don't get at home a lot. So I have a tendency to favor that. So I have a tendency to favor stuff I don't get at home, like jambalaya. I love, steak. I pretty much love everything. So yeah,
fair enough. Okay, and we're gonna end with this one. If you can get through to developers worldwide or technologists worldwide with just one thing that you wish that they would do, what would that one thing be? Making you think here. Making you sweat. No right or wrong answer.
It is tragic to find that there's an easy solution to something that you spend a lot of time working on. And a lot of times that answer's in the database.
Okay. Make use of the tools that are available to you, understand the technology that you're using, and explore your databases more. Always good advice. Bruce, thank you for hanging out with me today on the Haas Talks Foss. I appreciate you stopping by. We're going to look forward to catching up in person at Percona Live in a few weeks here. That should be exciting. Any final words for the audience here?
No, I'm certainly looking forward to Percona Live. So I think this might be the first time I've done the US one. I've done the European ones quite.
Okay.
So
which is unusual because you're from the US. So
yeah, well, what happens is the the events are always on a travel. I'm already out there, so it's like I'm already in Europe.
Yeah.
So, every time it's been in the U.S., it's been a conflict, but it's always worked out. It's in Europe, so I'm so excited. I'm excited to go to Austin and be in person again together, right?
Yes, indeed.
To hang out and have a good time. Yeah, it is really something I've missed.
Yeah. And for those who are watching, go ahead and like this video, subscribe to it, give us comments, give us questions, tell us what audience or guests you would like us to pursue in the future. If you'd like to hear from Bruce again, you want me to bring him on and grill him on some topic, feel free to suggest that as well. I'm happy to do that. You know me, I like to talk to people. But Bruce, hopefully that's okay with you. I didn't ask him before I
Absolutely.
said, go ahead and have me grill him. But until next time, we appreciate you hanging out with us. We'll see you later.
Bye-bye. Great.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
Hello, wonderful to be with you today at the Percona online event. This is a follow-up to the Percona Live, which we had in Austin last month, which was a lot of fun. Really great to see everyone together. And as they said, they had a lot of talks that they weren't able to fit in, so they decided to do an online event as well. So it's a pleasure to be speaking to you today about that. My name is Bruce Momjian. I'm one of the Postgres core team members and an employee at EDB. Been with Postgres for 26 years and EDB for 16. So I am going to be giving you this very unusual talk today about indexing, and not only about traditional indexing you see in relational systems, but also some of the non-relational indexing that we support as part of Postgres. This talk, the slides are actually available right here. There are 57 other talks at that location, as well as videos of many of these talks. So feel free to go over there and watch some more if you're so inclined. This talk is part of a 3-talk series that is on my website under the extended tab under presentations. The first one, Making Postgres the Center of Your Data Center, talks about how Postgres is effectively designed to be extendable. The second talk, Non-Relational Postgres, explains 8 of the major non-relational data types that Postgres supports, like JSON and full text search and range types and so forth. So if you're inclined to watch those, you might find them interesting, or at least look at the slides to get an understanding, because if you're not familiar with those types, it might be a little hard to follow, because I'm going to, the first half of this talk is pretty traditional, talking about relational indexing and some of the features that Postgres has that enhance relational indexing. Well, the second half is going to be talking about some of the specialized indexing methods that we use, particularly for non-relational data types, so that it might be helpful for you to be aware of what those are. What we're going to talk about, as I said today, we'll start to talk about traditional indexing. That's the standard B tree that hash everyone's familiar with. Then we'll talk about some of the unusual indexing capabilities that Postgres has for traditional workloads, like expression indexes and partial indexes. They may sound strange to you, but hopefully by the time you're done, they'll make sense. Then we'll talk about bitmap index scans, which is a special way of basically processing indexes and combining them. And then we go into the sort of special area, section 5. We'll talk about non-B tree index types, specifically those index types which are designed to handle non-relational workloads. We'll talk about some of the data types that are used for that support, and then finally give a summary of where indexing makes sense and some sort of quick rules that you can look at to make sure that you're making the best use of Postgres indexing capabilities. So let's talk about traditional indexing to get started. First, B tree. Every relational system seems to support B tree. It's a fantastic indexing method. When I was a consultant in the 90s, believe it or not, most of our indexing was ISAM, and B tree was this new thing. Not new, but sort of new to the industry, because it didn't have the traditional sort of block-oriented approach that ISAM had, and it was much more flexible, much more granular for concurrency and so forth. B tree is ideal for looking up unique values and, of course, maintaining unique indexes. There's really no other indexing that we have that does that better. But as you can sort of allude, there are some cases where if you're not doing that kind of work, then there are maybe other indexing methods that I'll talk about later that may be better. B tree is fantastic for high concurrency because it is row oriented, and it's very easy to identify which row goes with which data row, which index row goes with which data row. Its internal structure is very simple. It's basically a key and then a pointer to a row. Postgres does not have index organized tables, every index is independent of the actual row storage. So it would be index, row pointer in one index, and you might have the same row pointer in a different index that is used, does a different key, for example. It is used in a variety of cases. Certainly, if you do an order by, we would use a index in that case, typically with limit. If you're using limit, it makes the order by even more useful because we can pull the first or last couple rows off the index really quickly. In fact, I was just talking to a customer this week about how Postgres does sort of combines order by and limit and optimizes that. If you're familiar, if you're more interested more in that, there is a talk on my website called Explaining the Postgres Optimizer. And that shows you how the optimizer effectively uses index scans in a variety of cases, including the limit case. Merge joins, again, also in that slide deck. If you need ordered results from the two tables that you're joining, an index can be used. And of course, nested loop with an index scan, again, also in the presentation, are of course very useful. So aside from looking up unique values, which is obviously the number one bullet here, or looking up values that match a specific key, there are these secondary uses, order by, merge join, nested loop with index scan, which are as important in a lot of ways than just direct lookups on the row. So just be aware that that is a kind of interesting use. B-tree is not just for looking up something in a where clause. It can be used for joins. It can be used for limit and order by. But it isn't. B-tree is great, but it isn't perfect, right? First off, a traditional B-tree, and Postgres does handle this later, I'll show you, is the ability to index expressions or functions. Traditionally, a B-tree does not do that. Postgres does. Row control is a little tricky. Small indexes, lightweight indexes, B-tree are typically not very small or lightweight. They're fairly heavy. So we have some options there, as you'll see in later slides. If you're trying to index nonlinear data, B-tree is terrible. Just imagine a two-dimensional space. I'll show you some examples. Closest matches, very hard to do with B-tree. Many duplicates, very hard to do with B-tree, although we have improved Postgres a little bit in recent releases with duplicates. And multi-valued fields, things like JSON and full text search really don't do B-tree well. And I'm going to show you later how non-B-tree indexes are actually better choices for those type of cases. So let's talk about one of the limitations that Postgres handles for B-tree indexes, and that is expressions. Traditional relational systems allow you to index columns, but you may want to be using a column as part of an expression or as part of a function call. And as you can see in this example here, if I'm using a lookup on a lower function call, a lower case, the name column, if I create an index on name, that does not help me because effectively the query is not really looking up the name, it's looking up lower of name. And the third query here is actually the way Postgres handles it. It actually allows you to index a function call. And if you use that function call in your query, the index will be used. So let's look at an example of that. What I have here at the top is I create a list of 1,000 customers, all with customer 1 to 1,000, just numbers. And then I create an index on name. And you can see right here in this query, it properly does index this customer and actually uses an index right there, index only scan, because I'm looking up the name directly. Now, without a special index, if I actually go and do a where clause on a function call of name, you can see that the system has no idea how to process that using an index, and it resorts to a sequential scan. However, if we create an index, which is a function call, specifically instead of creating an index on name, I'm going to create an index of lower of name. Then fortunately, when I do the next query, you can see that lower of name does cause my special new index that I defined right here to be used. And that's an example of expression indexes. You can use a lot more things. You can do computations. You can do concatenation in these indexes. There's a whole bunch of things you can do in that expression. Doesn't have to be just a function call, but it's quite powerful. Again, as I said, you can do user-defined functions. You can concatenate. You can do math. The only requirement is the function has to be immutable. Most functions are, so you probably don't have to worry about that. But if you ever get an error saying the function can't be used, it's because you've used a function that's not always returning the same results at all times. And of course, that would cause a problem. Okay, the second example of Postgres using specialized indexing is something called partial indexes. This may not seem super useful to you, but I think it is. What a partial index allows you to do is to index only some of a table. So why would you create an index on all the rows if you know that most of your queries are not going to be looking up all the rows? Maybe there's a very hot part of your table that you're going to be using a lot, and there's a part of your table you're probably not using very much at all. I think the classic case for me, I used to work on an accounting system, and we had a lot of accounts receivable records, as you can imagine. And we had a little Boolean flag, which indicated whether the record was zero, whether the invoice was zero balance or not. Well, as you can imagine, we were looking up non-zero balance invoices all day and very rarely looking up zero balance indexes. So one of the unusual cases would be to actually index just the non-zero index, the non-zero invoices. And that would allow you to have a much smaller index and allow lookups to be much faster. So the advantage here is that the index is smaller, it fits in memory, it's not as deep, so it's more shallow, so you can get to the rows quicker. And also, every time you use an index or create an index, you are going to have insert and update overhead, and of course cleanup overhead and a delete. So if you're not going to be using the row, adding the index and requiring the index record to be added and then updated or removed is overhead. And if you don't need it, it's actually not a good idea not to use it. Now, we can still see all the rows, right? So the rows are still there. Even if we only index part of it, all the rows are still there. It just means we may not use an index for those rows. We may have to do a sequential scan, which may be fine if you're not doing this quite very often. Let's take a look at this. There's a little convoluted example here, but what I basically did was I just altered the customer table and I added a state field, and I basically identified a batch of customers, excuse me, which are in Arizona. So those would be the Arizona customers. And I can now create an index, and the specific part here about partial is I've got a where clause in the index. So you may not have seen this before in other databases, but in Postgres, you can add a where clause to an index. And by creating a where clause, you effectively create a partial index. What I effectively did was just to grab an index and create just an Arizona index. It's a little duplicative because I've actually indexed the state field, and the state field is always going to be AZ. So it's kind of a silly example, but it works. Maybe I don't need any other field, and I just want to pull up my Arizona customers really fast. So, hey, and I'm going to do that a lot. So maybe that works. Here's an example. If I look for Pennsylvania, which is PA, you'll notice that it does a sequential scan because there's no index on PA, right? But if I do Arizona, as we do in the second query, you can see that it does a bitmap index scan on Arizona, which is kind of nice. A little more sophisticated example would be to use a different column in the as the indexed column. So in this case, I've said state equals Arizona, but I've actually used a name field here. So of course, if I just look in general for all the rows, cust 975, it doesn't use an index. And the reason is because it doesn't have the where clause for Arizona. It wouldn't find all the rows because, as you remember, the index only has Arizona rows. But if I actually look just for Arizona, you can see that index is being used, this index right here. And if I ask for just Arizona and the name, or just Arizona, you can see that index is used in both cases. So again, it's kind of interesting. Maybe that's not super useful, but just be aware that is a capability. If you're ever in the need of indexing some of your rows and you just don't want the overhead. I have a blog entry about that. The overhead of indexing is not zero. It's kind of this insidious issue because when you create an index, every time you do an insert update, you're going to be potentially changing that index, but you don't see it because those are small operations and it just becomes a little slower to do an insert, a little slower to do an update. But overall, it can add up. And if you're doing a lot of those each index adds a little bit more overhead. And it's kind of hard to even measure exactly how much because the cost is spread about across so many queries. Another thing I want to cover, this is not an index, I should clarify. Some relational systems have bitmap indexes. Bitmap indexes are very useful for static data like a data warehouse. Postgres does not support bitmap indexes. I think there's a good reason for that. We basically use whatever index we have available, whether it's a B-tree hash or something else. And we can create an in-memory bitmap, which allows us to join indexes as though they were bitmap indexes, but we basically create the bitmap on the fly, which works really well. So when bitmap indexes are used, when an index lookup potentially might generate multiple hits on the same heap page, so we're not reading the same page over and over again. And it's also used if you're joining multiple indexes together. As you can imagine, if you have a where clause that has two restrictions and one restriction on one index and one restriction on another index, how do you use both of them? Well, you basically get the results from both indexes, the matches. You create a bitmap and you join those bitmaps together, and only the cases where they match basically with an and, or you OR them together for an OR, and then you can then look at the rows after from there. So it's kind of an on-the-fly way of merging indexes together. It has row or block level granularity. Again, it is a dynamic kind of a thing. It's really nice. It does ands and ors. It's automatically enabled by the optimizer. So if you ever see a bitmap index in the explain plan, that's what it's doing. It's basically creating something on the fly. Here's a little example. If I have index 1 and index 2, and I have an and clause between them, I effectively can create an and of the bitmaps and then get all of the rows that match both indexes and then look up the results really quickly. And that's just an example of how it works. So that's really what I wanted to cover in terms of B-tree indexes, traditional use for uniqueness, for looking up specific rows. I talked about how they're used in order by and a whole bunch of other cases. And I talked about expression indexes and partial indexes and the bitmap way of joining indexes together. But for the rest of the talk, I want to talk about non-B-tree indexes. And these are effectively, some of them are like hash indexes are also supported in a lot of databases, but there's a bunch of them that really are almost custom to Postgres. They're not custom to computer science, but not a lot of relational systems support these non-traditional non-B-tree indexes. And frankly, these indexes are incredibly powerful. Postgres would not be what it is today. Without these indexes, it would not be able to handle non-relational workloads as well without these specialized indexes. These indexes are the unsung heroes of the way that Postgres handles non-relational data. I should also mention that our Russian colleagues are primarily responsible for most of these index methods and several of our non-relational data types as well. So for some reason, that has been something that they've focused on in previous years, and it's obviously Postgres continues to benefit from their work. The first one actually was done by a gentleman in Chile as part of obviously the larger community. But this is called a BRIN index. It stands for Block Range Index, and it is primarily designed for data warehouse. So these indexes are very small. I'll show you an example in a minute. It effectively stores a minimum maximum value across a range of blocks. It allows skipping large sections that would not necessarily contain those values. It's ideal for naturally ordered tables, things that are like chronological, for example, would be very easy to use this index for. They're not expensive to update. They have very little column cost, but they are slower than B trees. And we have enhanced this index somewhat in Postgres 15 and 14, allowing, for example, to have multiple min-max ranges for a specific index. You can now, instead of having one min-max, you can have multiple of them, giving obviously better granularity for exactly how these block range indexes work. Generalized inverted index. This is really the workhorse, I think, for our JSON data type. It is fantastic for indexes that have duplicates. So things like text documents, JSON, multidimensional arrays. It's basically an inverted index where you store the key once and then you store all the matches. There's some incredibly interesting compression that goes on. This index has been improved over the years, so it keeps getting faster and more compact. It's optimized for multi-row matches. So as B-tree, I would say, is sort of optimized for single row matches. This is optimized for multi-row matches. The key is stored only once. It's basically, there is some expense here, as you can imagine, to update the index. So we have a special batching mechanism, which allows you to make some updates to the index, and they sort of stand in a holding area. And then as that holding area gets full, that eventually flows into the main index. But all of the lookups of the index look at the holding area first before they go to the main index. So there's not a question of correctness here. It's just a question of a delay of actually updating the index versus keeping them in that holding area. And I said it has really interesting compression capabilities and multi-column filtering. GIST, which you may have heard of before, it's a generalized search tree. Again, we're starting to see this came from Berkeley as sort of a generalized way of looking up data. This, I would say, is the catch-all for our non-relational types. So GIN is great for duplicates. GIST is great for things like geometric types, which are effectively two-dimensional. Range types, which have a start and a stop. In a way, those are two-dimensional as well. HStore, int array, trigrams, these are all PostGIS. These are all this is a very useful data type for that sort of two-dimensional, multi-dimensional kind of data. It also supports a distance operator, which is actually kind of interesting, where you can get the distance from various, the closest neighbor to various things. I have an example of that in my other talk. SPGIST, this one's a little hard to kind of get your head around. I have some examples later on I'll show you. But SPGIST is very similar to GIST, except it allows the key to be split apart. The term is decomposed. So you can effectively take a string, and if a lot of the strings have the same prefix, you can not have to store the prefix over and over again. It kind of splits apart a long string into smaller pieces, and then they can be partitioned in different sizes. And I'll show you some examples. Once you see the example, I think it'll make more sense. Hash indexes, this has been around for a long time. I was embarrassed before Postgres 10 because they weren't crash safe and they weren't replicated, but that is long ago. Frankly, in Postgres time, 4 or 5 years ago, we made them crash safe. They are really only good for equality and non-equality lookups. You can't really do range lookups with hash because of obviously you have to look up specific values. So if you thought I was just kind of making these names up, Postgres, as I mentioned in my Postgres at the Center of Your Data Center talk, has a capability called extendability. So, and this extendability actually covers indexes as well. So in that talk, I talk about how you can create your own data types, how you can create your own aggregates, your own operators, your own typecasting. Well, you can also create your own index methods in Postgres. And in fact, I actually did a query of the PG_AM table, which stands for access method table. And you can see that I've actually listed, the 6 indexes I just talked about, and why, how they're used. So this is a great slide. I think if what I've told you is like way over your head, this slide is great. B-tree is great for unique indexes. Brin is great if you're indexing many columns. Gin is great for duplicates. SPGist is great for duplicate prefixes, and gist for everything else. So if there's anything, if that's the only thing you need to remember from the first half of the slides, that's great. I mentioned that these are critical for non-relational data types. So what I'd like to do is take the indexing methods we just talked about and match them to some of the data types that we support, non-relational particularly, and show you how they work together. So it might not be a surprise that every data type does not support every indexing method is not supported by every data type. So there are, let me give you an example. So you can't use a B tree on some of our data types. For example, you can't create a B tree index on a polygon, right? And what I did here was I basically said, I actually queried the pgAM table and I joined it to another table called pgOp family. And I basically reported which data types support the B tree indexing method. All right. Similarly for Brin does not support every data type. It supports only the data types that are listed in the the PG_op family table, and this query shows that. You might be surprised that Gin doesn't support many data types. Remember, I said Gin is really designed for duplicates. So we basically only support the data types that we expect to see a lot of duplicates in. Now we do have a contrib module which has support for Gin and some other data types if you're really wanting to use maybe Gin and some of the other data types. We have some way of doing that, but traditionally it's designed for things that have a lot of duplicates, particularly JSON, as I said, TS vector, which is full text search, and arrays. Just remember, I said that's a more generalized thing. So polygons, you see polyops there, network data types, circles, boxes, but also full text search, TS query, TS vector, and JSON-B, which is kind of interesting, right? So you've got a choice sometimes. Do I want to use gist? Do I want to use Gin? I normally, again, as I showed in my earlier slide, you probably want to favor Gin if you can, and then only use gist if you have a reason to. SPGist, again, looking for that prefix at the beginning, a little harder to understand, but obviously the text data type would be a classic case for that. So let's look at some examples. Here is what the B tree index looks like. This is sort of the classic textbook of a B tree. You've got an internal page which has ranges for your leaf pages. You've got leaf pages which then point directly to the heap, which is where the actual data rows are stored. Here's an example of Brin. I mentioned it was really small, and I'm going to prove that now. So I effectively went out and I created a table with an integer of, looks like 100 million rows. Okay. And then I created 2 indexes. I created a B tree index and I created a Brin index. I realize this is an extreme case. However, here is how big the table is. Here is how big the B tree index is, which is, I guess, 2/3 as big as the table almost, right? And that's how big the Brin index is. So you can imagine that you could effectively create these tiny Brin indexes on almost every column because they have very low overhead for updates and inserts. They're very small, and they aren't as good as B tree, but they can allow you to filter your data very efficiently, and they can be combined together as I stated earlier with the bitmap scans. Here's an example of GIN. In the GIN example, we basically have, we're creating a table and we're putting two strings in. We're putting the fox is sick and how sick is this? So this is a full text search example, okay? And if I look at the index, with the row, it basically has the fox is sick and how is the sick this, because it's basically tokenized, or made them into lexems, so that they're basically discrete words in the actual table, because of the way, the way that the TS vector works. Okay. So this is actually, again, what the table looks like. But if I look at the index in GIN, what happens is the foxes only appears once, and these three only appear once, but is appears twice. So we have is, and we list the two places the is appears, and we have sick, and we list the two places the sick appears. So effectively, what you can imagine, if you had hundreds or thousands or millions of these matches, you'd have the word, and you'd have all the places that word appears, right? Another word, all the places. And you can imagine that because GIN can combine these together, if I look for this word and that word, it can basically merge the two GIN indexes together and find out which rows potentially have both words in them. GIN also works for JSON. So here I'm creating a JSON B column. I have a name of Bill, active true, name Jack, active true. Here's the actual row in the table, name Bill, active true. But if I look at the GIN index, you'll notice that Bill and Jack only appear once, but active, name, and true actually appear twice. So what exactly we saw with the GIN before, we have the word active, and we have all the rows that have active, name, all the rows that have name, true, all the rows that have true. We also have a capability called JSON-B path ops. If you're looking for nested, basically combinations, JSON path ops is a better choice. It basically takes the keys and hashes them together so that effectively you get a more compact representation of the key. And of course, this is a single hierarchy, but you could have a hierarchy that goes way far down. It would just be one hash value. So if you're doing a lot of lookups for exact matches, JSON-B path ops may be a better choice. The Postgres manual explains how you can sort of determine which is a good choice for you. GIST, as I said before, is the fallback. Supports a whole bunch of different data types, multi-dimensional arrays, IPs, and so forth. I'm going to just illustrate why GIST is useful. So, for example, if I'm looking for equality equals 2, right? That's really easy to do with B-tree, because you're like, okay, it's got to be, I just order everything from negative infinity to positive infinity, and 2 is going to be right in that center there, right? Or even if I go greater than 2, I can say, okay, I want that 2, and I want everything that's over that up to infinity, which is really easy to do. However, what do you do for a two-dimensional point or a polygon or a circle, right? Do you do something like this? Say, okay, x equals 2, and I want everything more than that. Well, that works, but you haven't really restricted anything along the y-axis. Because your B-tree index only is linear. That's the problem. That's why B-tree indexes are really inefficient for multidimensional values like range types and polygons. However, GIST for polygons implements something called R-tree. It's basically a indexing method that represents concentrically smaller boxes. So if you're looking, for example, for a point in this region, you find the biggest box that contains that region, and you can just have to look at that box. So if I'm looking for something in here, maybe I'm looking for a point right here, I don't have to look in all the other boxes. I can just say, okay, I know it's in this big box, and I know it's in this big box, and I know it's in this big box. Okay, let's just look in this big box for matches. I don't need to look out here. I don't need to look out here. And that's one of the sort of abilities for just to handle this nonlinear data like that. Again, it supports two-dimensional things, circle, box, polygon, point. PostGIS obviously also uses this method in a powerful way. Range indexing also just is very good for that. Range indexing is kind of taking two columns and combining them together as a start and stop column. As you can imagine, they're still linear, but they're kind of two-dimensionally linear because the start is one spot, the stop is another spot. And what it effectively does is it creates these concentric ranges of, they're getting smaller and smaller, just like the R tree boxes get smaller and smaller. The ranges get smaller. So if you're looking for something in a specific, maybe you're looking for a car rental at a certain time, you can use the GIST index to find the smallest range box that could potentially contain that range, and that's how that works. SPGIST, I talked about this earlier. This is the ability to take a string or some field and break it up into pieces. So, for example, if I'm looking at URLs, I would only store HTTP once, and then everything underneath that would all be HTTP prefixed. If I want Yahoo, HTTP Yahoo, then everything underneath that in the index would all have the same prefix. So it's a kind of a creative way of sort of slicing up a key automatically. You don't do it yourself. The index does it for you and create this sort of bounding that allows you to kind of get to the row a lot quicker. We also have something called quad point ops and KD point. These are a little more quite a bit more exotic. They're basically different methods of doing the R tree kind of a setup, and sort of they're GIST, but they're ways of sort of separating and shrinking down the problem space. There are some. The bottom line is that the normal R tree has some pathological cases, if I'll say that. And these are basically designed to work around those pathological cases. And pathological in terms of certain update patterns can cause the boxes to grow unusually or not be efficiently laid out. And these are different methods of handling that. We do have support for many of these indexing methods for the extensions that we ship with Postgres, or modules, if you want to call them that. So as I said before, we have btree-gin and btree-gist, which allow you to implement btree on a gin or gist base. Cube, HStore, InArray, I told you before, was a way of using indexing integer arrays. pgTrigram, I talked about that in my other talk about non-relational, but trigrams obviously benefit a lot from this as well. So I know we've talked about a lot here. I want to just kind of wrap up with a summary of exactly what we kind of get out of this, because I know it's a lot of information that you may never have heard of these before, and your head might be like, I don't really get it. So let's just look at indexing in general and just sort of summarize. I already summarized earlier which indexing methods are good for which cases. But even the ability to create indexes, how do you know when to do that? Well, we do have some statistics in Postgres. For example, there is a pgstat user tables, which has a sequential scan field. If you see a lot of sequential scans happening and you believe that an index would help, you can actually look and try adding an index and see if some of your queries go faster. You can run explain, particularly also via pgstat statements or pgBadger, to look for queries that are running a lot, and maybe look at the explain plans and see maybe if there can be enhanced by an index. But sequential scans are not always bad, right? There's a lot of queries that run just fine with sequential scans, and indexes either wouldn't be used or the overhead of the index might be a lot, particularly if you run the query once a day, right? It might be too much overhead during the whole day to maintain the index versus just living with a sequential scan once or a couple times a day. Also, if you can look at how much indexes are used. We have a pgstat user indexes. If there's few index scans, it means that index may not be used, and you might want to remove that index because, again, having an index that isn't used is still costing you disk space, and it's also costing you the insert update overhead that you're paying at the front while queries are running. The delete cleanup you're not paying, you're paying, that's a vacuum operation that happens in the background, but the insert update overhead is actually happening while you're doing the inserts and updates. So that index is costing, and if it's not being used, it should be removed. When you're evaluating different index types, because I've thrown so many different types of indexing at you, this is the criteria that I use, right? How long does it take to build the index from scratch? Is that important to me? It might not be, it might be, I don't know. Particularly if you're doing a temp table, the index creation time may be pretty important. Some indexes are much quicker to build than others. What is the storage size? As I showed you before, a Brin index is tiny, a B-tree index is huge, right? So keep in mind what you're actually storing and how much disk space, because that index to be used is going to have to be loaded into RAM, obviously, and you're going to have that overhead. It's going to be stored in the shared buffer cache and so forth. The insert update overhead I've kind of talked about. That is going to be expensive. The Brin index is the easiest one, very low overhead. But as you move into B-tree and Gin, those index updates can be expensive, very hard to measure sometimes. Sometimes you have to do a bunch of inserts without the index and then add the index and then do a bunch of inserts later and see what the difference is. See how much overhead you're actually causing with those indexes, because it might be substantial, particularly if you're batch loading a lot of data in a lot of time. Access speed, some of the indexes return results quicker than others, right? Remember I told you Brin is very crude and allows you to filter rows, but at a megabyte level. And you can change the size of the Brin, you can make it smaller or bigger, but in general, it's doing whole ranges. But obviously a B-tree is very fast. So you have to kind of pick which one, what's most important to you. And then obviously operator lookup flexibility, which is a little hard to understand, but as I said before, hash can be used for equality and non-equality can't be used for range lookups, right? And certain things are much quicker with range types than B-tree, for example. So again, you have to sort of look. I talked about like JSON has particular ops used for looking up the whole key path and the value together versus looking up the pieces of the JSON. So again, you have to kind of look and see what really fits for your workload. So what I've tried to do is kind of give you a big view of what is Postgres capable of, not only in the B-tree and the expression index and the partial indexes, but when you start to get into the non-relational types, how rich the indexing is for those non-relational types, and how important that is to the success of using those non-relational types. If you tried to force all the non-relational types into a B-tree, Postgres would never be able to scale these non-relational types. It's really these specialized indexing methods are the underpinning of Postgres's ability to handle these non-relational types at scale. But it does require a little bit of learning. So hopefully this talk has helped you to learn those things and given you some other things to kind of research. So thank you, and it's been wonderful to talk to you today.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, with that, let me go to a keynote, or I will run out of time kind of talking about the put. And what we will talk about, or a question asked first, is what is the biggest factor which impacts the open source right now? Anybody? Come on, get active. You had your morning coffee. Anyone? Anyone? Okay, I see everybody is still operating in that Zoom mode, right? When we do not talk to speaker at all. No, come on, guys. I'm watching all of you, right? So please signal me with your eyes, with your hand motions, right? If you want to say like, ooh, Peter, that is a piece of bullshit, right? Yes, you can do that, right? To say, yes, that is awesome, Peter. Give me some energy, right? That also helps. Well, anyway, the answer you are supposed to give is the cloud, right? That is, I think, is the biggest factor which impacts the open source over the last few years. And I think in a database space, in particular, it's interesting how the cloud database revenue was growing, and now in 2022 is on track to surpass on-prem databases. Now, how does cloud impact an open source? I think one interesting effect is what cloud allows people to kind of hijack the limitations of a GPL license, which was often protecting the people in the past, right? Like MySQL was famously known for dual license. Hey, you know what? You want to build commercial software on MySQL and distribute it, you're welcome to do that, but you need to pay MySQL, right? With cloud, that is not really the case. And I think that is one of the reasons we see right now amount of GPL licensed software is shrinking, and we have more permissively licensed software happening in a few years. Now, how does cloud really impact the open source software? I think from one standpoint, it really helps us to simplify deployments and through that maximize adoption of the open source software. But then that also changes who is going to make money on that open source. Like MySQL is probably a great example here, right? Even though Oracle does most of the MySQL engineers, Oracle friends at AWS are making most money on MySQL, right? So that kind of changed. The thing I think to remember about the open source is this. What the open source really is not the business model. It was not designed to be, right? And the open source, you can think about that as a development model, distribution model, and it can support variety of business model, and those business models are changing now. If you know the open source, there are two big approaches or two different types of open source you can see. There is a foundation-driven open source, right? Or we may talk about that as community-driven open source, as well as single-vendor open source. And what we see is what those groups are really look at the cloud impact very differently. For foundation-based open source, there is a lot of focus on, hey, the cloud really helps to accelerate adoption. And those community tends to really embrace this effect very well. For example, you talk to PostgreSQL people, they absolutely love what the PostgreSQL is now available on all the cloud vendors. Because that is one of the reasons what PostgreSQL is now the fastest growing database, because it became so easy with that embrace of the cloud vendors. Of course, that changes who makes money on Postgres, right? But if community, that does not really weakens community, that is just a part of evolution. If you look at a single vendor, though, this tends to be like a very venture-funded or public companies, right, which are really out there to maximize revenue they extract from that product, and they are generally quite fearful of a cloud competition, as we see. And that has caused, through the years, their fully or partly abandonment of the open source licenses, right? You can see like a pretty much who is who abandoning open source license. And to me, this is kind of even funny, right? The big bad Oracle, which was supposed to kill MySQL, right, according to some rumors that when acquired, they actually did not go this road, right? They do have open core model, and there is MySQL Community and MySQL Enterprise, but Oracle has not kind of worsened, if you like, the license for MySQL, unlike many newer and other players. If you look at the primary goal of those license changes, is this really creating monopoly in a database as a service market? For many folks I talk to, they see that is the only thing which really matters, right? Self-service running on-prem, not really as lucrative, not as much kind of rewarded by investors and market cap. So database as a service, that is a complete focus. But why database as a service for the users and customers? Well, the thing in this case is a database as a service that is the easiest way to deploy database technology. Because deploying database is actually quite complicated, and especially managing that. You don't have to just have a database, you have to figure out backups, scaling, self-healing, upgrades. All of that is more messy than they happen if, let's say, your stateless application, right? And database as a service type of deployment is really helpful because it allows developers to focus on things what matter, productivity, building applications as fast as possible. So what do I see as a monopoly with that database as a service? First, yes, we have vendors changing the licenses so they can only be the one who provide database as a service, but the rest of us being able to use that software in other environments. Well, I see that as no different than proprietary software, right? So let's not talk about that as almost open source. It's not. It's not open source. It's proprietary software, which is the license which kind of allows you to do certain things. At the same time, I think what not all is lost in this database as a service and the cloud evolution, right? I don't think what we've seen some sort of, demise of open source software and this kind of cloud restrictive licenses taken over the world. I remember being involved in a technology in early 2000s, right? And at that time, I was developing like in a PHP using VI and, like a kind of Stone Age tools. I remember Windows folks would tell me, oh my gosh, you are using such a hairy, inconvenient platform where we have all this, graphical user interface with all their, fancy stuff, right? And I think that is very similar to the state of cloud right now, when a proprietary solution are much easier and more polished than the open source one. I also remember the situation with the Solaris and Linux at that time, right? Probably somewhere in the late 90s, I remember talking to Solaris folks and say, well, Linux, 32-bit operating systems, you can't really have more than 4 gigabytes of RAM. And if somebody remembers, there was also a limit on 2 gigabytes per file size. That was like a joke, right, as people running real operating system thoughts. But now, 20 years later, where is Solaris and where is Linux, right? I think what that shows is that the open source tend to be slow or slower, but it's inevitable. And I think that is exactly what is going to happen with the cloud as well. Yes, we have AWS and other cloud vendors which came up with a very polished, productive, but proprietary stack. But there is other work going on, such as by work of a cloud-native foundation, which is building another platform which is powerful and gets extremely more polished and extremely more powerful. And actually, if you think about the scope, how many companies, like tools or services, whatever you call it, are being built around cloud-native foundation, it probably surpasses the amount of services available from all major clouds combined. Now, am I against the cloud? Well, actually, I am not. I think this wonderful presentation, or this slide from an early AWS presentation, you can even see some, old logo, which was comparing their cloud to the electricity, right? Well, you don't want to make your own electricity, right? Well, totally agree with you. It is very, makes a lot of sense to run this stuff in the cloud and use the cloud as commodity infrastructure provider, as electricity is, right? What does not make sense is just running their proprietary cloud services, because that would be similar to just, like buying a fridge or TV, which only works when you buy electricity from a particular provider, right? We don't do that. We want to have that flexibility. And that is a combination of the cloud vendors plus technologies from cloud-native foundations such as Kubernetes provide us. So as I was talking about the database as a service and how that is important and the open source, do we have a solution which provides database as a service experience in an open source, right, which is completely open source? Well, not really, but I think there is a lot of happening in the industry which I will call their baby steps. The first important component, what we have here, is a Kubernetes, which has become ubiquitous operating system for your data center. And I know not everybody likes Kubernetes because it's different, especially if you're coming from Linux, right? But I would tell you that Kubernetes is probably like a beer. You are expected to have that little bit of a bitter taste the first time you try it. But when, as you repeat, right, you probably turn to love it, right, as many of you I know do. So what is up with Kubernetes? Why is it important? And specifically at the Kubernetes operators technology, when it comes to a database. Because it really helps us to automate both day one and day two operations, right? Really deploying the databases is an easy part. Making sure at scale you have a self-healing environment which can scale easily, right, without a lot of manual work, upgrade correctly, handle all kind of edge cases. That is a hard part. And operator technology in Kubernetes allows us to do it. It is still not quite database as a service yet because it's a different UX, and that can be more hairy compared to deploying database as a service in the cloud providers, which you can do in 2 clicks and an API call. But at the same time, the Kubernetes is a wonderful building block for modern database as a service. Here is a pool results from data on Kubernetes community, which shows what, if you look at the stateful applications on Kubernetes, databases are actually the #1 tenant which people are already running on Kubernetes. Also, if you look at number of public cloud solutions, many of them which have been put in production in the last couple of years are actually running on Kubernetes underneath, right? So with that, we can see what there are really many tens or hundreds of thousands of databases or database clusters are running on Kubernetes right now. right? And though it may require some thinking and engineers to make it work, that is quite possible. At Percona, our approach to fully open source database as a service is using Percona monitoring and management as a GUI and also API endpoint to provide you database as a service experience in a fully open source mode, where you can install PMM, you can connect that to the Kubernetes, maybe on-prem, maybe in the cloud, manage Kubernetes service if you like that, and get database as a service experience. Our database as a service on PMM is not GA yet, it's a work in progress, but you're very welcome to try it out and experiment and maybe even contribute, make it work better for you. That is their power of open source, as I see that. Now, I wanted to end this presentation by saying a few words about Percona, and for those maybe who, while use our software, may not know where we come from as a company and what we really focus on. Here is the slide from the book we printed for our celebrating 15 years anniversary, which shows how far we have come up. And I think what is very important about Percona is what all the software which we ship is open source. I think that is a pretty unique in the industry. And what is interesting for me is I was probably for 15 years was saying, well, that's never going to work. That's never going to scale, right? And you can think about the Percona as a company which is running this radical open source experiment now going on for 15 years. And how has it been going for us? Well, this is one of the slides from our sort of marketing presentation deck, right? And what I wanted to show here is what we have quite a few customers, right? And we are growing pretty well as a company, right? While also we are able to do it in while maintaining a sustainable business. Percona never raised any venture capital, right, or some debt. And what that means is what that requires us to maintain sustainable business practices, right? And what that means is what we provide you, we can provide in a sustainable way. We don't need to come, well, you know what, now we spend most of the money we raised, now we have to turn it around, right, and start charging the actual prices, as sometimes happens in the industry. And I think that business approach, while it takes a longer time to grow, that is very good for community and for our customers. So if you think to finish it up, I wanted to maybe leave that 3 takeaways about Percona in this case. We as Percona is very focused on success of our customers and open source database community at large. That is really we see as the very important core purpose of Percona. We really love open source and we like doing open source for real, right? There is not quite a good, established terminology for that, right? But we can see right now, in many cases, open source is used kind of as a, marketing term. And when you look underneath, there is a lot of asterisks. And in the end, unless you are maintaining commercial relationship with a vendor, you can't really use the software at that scale. At Percona, we want to make sure what you can use our software successfully, right? Wherever you are choosing to be our customer or not. But we want to make sure also we are providing so much value and so much love to you as a customer, it becomes irresistible to be one. And again, as I mentioned, sustainable business model is a very important for us. You know, many people has been trusting us for more than a decade, and I want to make sure you can trust us for decades to come, and that is where sustainability is very important. That's all I have to say. With that, thank you.
So we are now on our Percona Community Live, which is our online portion of Percona Live. For those who couldn't make it in person, for those who wanted to speak and couldn't make it or got sick, because a lot of people got COVID, including myself. So, you know, we're doing obviously this special day, and so I thought it would be a special time to bring in Peter and have a brief conversation with him. Something a little off the cuff, unscripted. So this is Peter Unplugged. Which is always
unplugged.
Yes.
Oh, okay, yeah.
Okay, so Peter, you know, so we know that right now things are changing pretty fast in the open source ecosystem and in the world itself. You know, one of the things that I noticed was a plethora of smaller companies, startups, open source companies are now starting to hit the funding crunch. You know, because right now we're in this weird space. So I'm curious, how do you see the current economic, you know, impact that's going on, its impact on the open source space? So what do you think is going to happen there?
Oh, you wanted me to talk economics?
I'm gonna talk about a lot of stuff.
That is surely
it's top of mind. It's top of mind for me.
Yeah, no, absolutely. Well, I think if you look at from what you talk about the crunch, right? We are in the early stages, because if you think about where we are, is about just 6 months ago, it was one of the best times to raise the capital, right? You had a lot of open source companies raising capital easily and at a very high valuations, right? And obviously, if when you do that, even if they spend money like a drunk sailor, then it's very unlikely they'll spend all of that over over 6 months, right? So if you look at that, I think a lot of companies who raise the capital, they still have some cash, but they need to be started to think wherever they are able to raise another round, on what conditions, where we need to reduce the burn rate, and so on and so forth, right? So that is truly interesting. What exactly is going to happen here? One thing which worries me, as it comes to the open source in the commercial space, right, is when things get tough, open source license is often the first thing to be thrown out of the window.
You mean like from a company perspective, you're open source, and then you're like, oh, I need to make money, so let's just change the license?
Well, that's right. That's right. Like if you think about the company which had been relatively slower organic growth of open source, and you can say, oh, shit, now we don't have any money, we are going to die, so let us just change the license to non-open source license, right? Let's force all our users base to pay us, right? So we can hopefully survive, right? And then that, of course, makes less stuff available to open source community, right? So that is kind of one fear what I have, right? And there's obviously a lot of scale in this case, right? It doesn't have to be like everything becomes proprietary, but that may shift things to what exactly is available under open source license to what is available proprietary, cloud only, right? So you name it.
So interesting. You know, there has been a ton of companies that have kind of overlapping ecosystems, right? So when you talk about, you know, whether it's database technology, storage layers, you know, security companies that do a similar thing, but they release a slightly different product, a lot of times in the open source space.
That's right.
Where, it's like, oh, I prefer to have everything looking, on the screens brown, whereas the other one prefers white. But other than that, they kind of do the same thing. As these companies run into problems, what happens to their user base? Like, like if they go under, or if they decide like, oh, you know what, we can't continue because, there's so many. Do you think that, like these other companies will absorb them, or is it going to be, especially with the cloud offerings that most are running to, they might not be compatible with other things? Is that going to cause some issues with migration?
Well, yeah, I think in this case, what you're saying, I think a couple of things is likely to happen. One is consolidation, right? I do expect, as often happens in the markets, in tough times, what we financially weaker companies are going to be bought by financially stronger companies, and then the product, it may depend, right? It may be the product will be integrated, it may be product will be continued, it may be the product will be just pushed, users may push to be migrated off to the stronger company product, and the product be killed, right? So this is multiple choices, or companies may just die, right? That happened in the open source ecosystem. You may remember company RethinkDB, right? Which were building kind of spiritual alternative to MongoDB, right? Or Basha, the company beyond one's high-flying React technology, right? And the company stopped working, right? And what is interesting though in this case, and that I think what is better in an open source space compared to proprietary software or software as a service only model, is what the code remained, right? There is still some like maybe much smaller and less active communities, but working on RethinkDB and React code, right? So if you were running those technologies, it's not yet like you are completely out on the limb, right? I think this is also going to be time when people will start appreciate kind of mature, boring technologies more, right? Because if you think about technologies like Postgres, MySQL, right, and a few others, is they are really have so many companies involved in an ecosystem. So if one of the companies, even if that's in a major vendor, that gets into a problem, right, the technology itself would not die off, right? If that is some very cool hotshot where the ecosystem is small, then the death of a single vendor may be critical, right, to a successful project, right? And I would remind this was an interesting project in like MySQL space. Some may remember a project called Drizzle. It was supported by a single company, Rackspace, right? Interesting project, doing a lot of cool stuff, but you know what? That's once that company decided not to fund that project anymore, it pretty much died because, well, there was no that kind of a critical mass which can, survive death of a single vendor, right? Or single vendor stop and invest in a project.
Now, you bring up Drizzle, which is a very interesting case study because there were a lot of derivative works and processes that came out of Drizzle. And one of the interesting things when economic times shift and when you see, times in the market where maybe, old habits, come back where you run back to the more stable technologies, a lot of technology might fail as a company, but live on in the open source space and really go on to be the foundation for the next big thing. I mean, when you look at a lot of the work that happened with Drizzle and the team, you ended up with stuff in OpenStack and Jenkins and, Kubernetes, a lot of the foundational, design of those early Drizzle systems and, the process for building and deploying. I mean, it has set the foundation for a lot of code that most people don't even realize.
Oh, yes, yeah, absolutely, right. I think this is one of the things of what the open source is kind of being a gift to the world in a sense, right? Because what you do in an open source community is much more open, available to everyone, right? And that's really pushes technology innovation forward, which is much more so than if it's done in a proprietary space, right? Where you may have technology dies, nobody has an access to that, right? And maybe a few people learn something from it, right? Who are directly on that stuff, but it does not have as big impact to the society and to the world, right, as open source technologies can do.
Yeah, yeah, and I mean it's something to realize that sometimes software or companies get bad press, but the technology behind it could live on for a really long time and influence many others. So it's
absolutely.
It's something important to know that even if you're learning a technology that might seem like it might be going away, that might be relived into several other products. Now, as we turn into the database space specifically,
Hey, wait, before that, let's talk a little bit more about the economics, right, as you started out. You did that, not me.
Sure.
Right, I wanted to look at the other side, right, and their benefits, right, if you look at the full open source ecosystem of a possible downturns.
Sure, absolutely.
Right. And I think this is kind of a very interesting time for the open source technologies, like through open source, because that pushes a lot of companies to look for alternatives, right? If you may remember after 2001 crash, right, companies could not be in business using Oracle as a database, right, Sun for servers and so on. So it was just dumb too expensive. It was very robust, very convenient, very easy to use, but you just didn't have money to be able to do what you do with those technologies. So often you have to become scrappy and use Linux, PHP, Apache, MySQL, which was a lot of pain and suffering at times. Right, it was very interesting for me looking at some of the time before 2001, like how a lot of people who has access to those, very expensive but very, efficient technologies would almost laugh at you, like, oh my gosh, you are using those kind of a Stone Age tools, right? You are, writing code in VI, right, compared to our fancy, tools, right, if automatic completion. But guess what, right? As things, as the fortune changes, a lot of those technologies just became much more expensive, and community instead invested in open source, took that open source to the next level, right, and built much more efficient and very robust ecosystem, right? And I am hoping what we'll use this opportunity to do the same, but in the cloud stage, right? Because right now, if you think about the single host operating system war is long in the past, right? And Linux won, but on the server side, right? But if you look at the cloud, majority of folks are using proprietary solution by major cloud vendors, right, in this case. And the cloud native, the Kubernetes ecosystem, we have a lot of catching up to do still.
But wait, so, since you wanted to stay on the economic side, I'll stay on the economic side. When you look at, like what you said about like the, open source thriving in the last recession and really growing, it was a little bit of a different setup. And right now, instead of being kind of like the fledgling, alternative, it is more of an established practice. But we're seeing more and more, as you mentioned, movement to the cloud as that alternative. Now, the promise of the cloud is it's scalable, and like you scale up and down and you only pay for what you need. I mean, that's always been the promise. So while open source has been recession proof, is the open source in the cloud that's being run in the cloud recession proof as well? Is the cloud recession proof, or is it going to see the same economic troubles that you mentioned the big hardware vendors and other proprietary vendors saw during the last recession?
Well, I think in this case, open source is only part of a solution, or only part of a question, right? If you look at what has been happening in late 90s, early 2000s, right, is also moving to much more commoditized hardware stack, right? You went from the Sun servers, right, or something like HP Tandem Nonstop or whatever, right, which you could only buy for a single vendor for a huge amount of prices, to getting the pretty much commodity boxes. Dell, IBM, HP at that time. That was all also kind of always pretty much the same shit, right? Which was, because of that competition, much cheaper, right? So the cost efficiently comes through having a choice and avoiding vendor lock-in, right? Now, if you think about the cloud, you can think about that from two different levels, right? And one, that is the cloud as a commodity. If you think about storage and compute, those foundational building blocks are pretty much commodity. They're the same whatever cloud you want, right? And there is a lot of cost competition on that, right? Think about like S3, for example. Well, there is a lot of S3 compatible alternatives, right, which offer you drastically different costs compared to, let's say, Amazon S3, right, for example. There are, on the other hand, this very highly differentiated proprietary solutions, right, which cloud vendors, of course, wanted to use. And if you get on those, like, you are stuck and you're going to be paying the top dollar, right? So that is, I think, where the difference is. The thing in this case, though, is those proprietary solutions in many cases are more robust or easier to use. Think about, something like a BigQuery or Amazon Aurora, right? Or, Snowflake, right? Or whatever. These are much easier to use compared to the open source solutions. At the same time, if you just install some open source Linux with open source browser, it is actually almost the same easy-wise as using proprietary operating system, right? But you can even kind of get a laptop with a pre-installed Linux those days, right? So in that case, we have the same usability. When it comes to the cloud, the open source cloud right now is 10 times harder to use than if you sell your soul kind of and go all the way proprietary with major cloud vendors.
So what you're saying is there needs to be a reckoning around the ease of use and the user experience in the open source cloud.
Absolutely.
And what do you think will drive that? Do you think that the current economic conditions will make that a requirement, or do you think that people will just accept a little less polished?
Well, I think that is already happening, right? You can see certain shifts going on in the ecosystem where we see ranging from some, raw foundational tools, like, let's say, Kubernetes, right? It's kind of a very core component of the infrastructure, but that is a very gnarly, right? That is not something you use, right? Well, actually, that is same as it happened with Linux, right? Initially, Linux was this very hard to use, but a very powerful command line driven stuff. Proper graphical user interface, which is requirement, right, for your, classical user, came years, if not decade later. Now, similar things happen in the cloud and cloud native, right? We already have Kubernetes, right, and a lot of other companies is kind of cloud native ecosystem, which are pretty robust and powerful. And we have some GUI coming up, right? For example, a Rancher project, right? Hey, you get a GUI where you can deploy the services on the Kubernetes, no matter what that Kubernetes is, right, in an open source space, right? And I expect that is where we'll see a lot of the innovation happen over time, right? And the downturn will just accelerate that.
Yeah, okay, it's fair enough. Fair enough. Now, part of this ecosystem though is the growing database space that is, currently exists and is being built, and it's yet to be determined how the economics impact this. But it seems like there are more and more database technologies out there than there ever have been before. A lot of them claim compatibility, where they will take the Postgres library or the MySQL, library or interface, and then they'll implement them as a way to ease adoption of their product. But that means that there's a lot of choices. Are there too many choices in the database space right now? Is it something that we've reached a point where there's a bit of paralysis and you're never going to find one that wins over the other, and so eventually you have to worry about some sort of consolidation later on, and you should just stick with the primary versions?
Well, I think this is an interesting question, right? First, I would say what this competition of ideas, right, and a lot of choices in the market is fantastic, right? Because that is what drives innovation, right? Over time, you do expect both technological and business consolidation over time, right? Like, and you can see like one of the interesting examples would be you see their SQL vendors kind of implement some NoSQL functions, like a doc store, JSON type, and so on and so forth. They're all of those kind of SQL is evil, NoSQL vendors. They implement some sort of a SQL or SQL-like languages in their products, right? So we have that kind of idea to have a consolidation, right? Or we have also the ideas as more and more coming up as HTAP, hybrid transactional analytical databases, which can do it all, right? And I think over time there also will be winners and losers in this case, right? And I think, well, it's just a math question. What all those kind of hundreds of vendors which exist out there, they are not going to get as big portion of the market as they hope to, right? Because, well, they all have to sell up to 100%, right? Yeah. So I think what is interesting here, though, is you can look kind of beyond the hype and at some real problems, right, which are being solved, which offer some 10x advantage, right? To give you an interesting example, right, in this case, for a lot of applications, for example, if you remove the politics, reduce the licenses, MySQL and Postgres is basically the same stuff, right? You can build the application with one database and with another, right?
By the way, all the audience, or most of the audience, just called you a heretic for saying that. Whether they're on either side, they're both going to argue you're wrong, that their database is better, but that's okay.
Yeah, that's okay. Well, anyway, right? I mean, in many cases, that is kind of becomes kind of religious questions, right? In this case, they're not kind of so much of a factual. Anyway, at least I see it this way, right? But there are certain cases where you can look at them actually not being able to do certain things well, right? For example, if you look at sharding, neither Postgres, no MySQL, right, as a core technologist, has that kind of a good scale-out experience, right? You have to actually do it manually, right? And that is why you see the solutions like Vitess, right, or for MySQL, or Cypress for Postgres, right, or CockroachDB, TiDB, Yugabyte, right, which are trying to solve that scalability problem. And that is a real problem, right, I would say. Or another one is neither MySQL and no Postgres, right, in its core is really designed for analytical workloads, right? Raw storage engine, not a great thing. And that is, again, like why there is a number of solutions exist for both technologies to solve that problem. right? Because those databases at core are not very good at solving them. Which of those solutions will actually win in this case and will be de facto sharding solution for kind of like a scale out PostgreSQL, scale out MySQL? I think it's too early to bet.
Well, and what's interesting for a lot of that scale out is the majority of applications don't need that level of scale out. So I think that some people like to over provision and think ahead. But the reality is a lot of the core database functionality that exists within any of the popular databases that are out there tends to solve a lot of the classic workloads. And so the question is, what workloads do require it and fit best? Because not everything should fit into each of the database shard systems that are out there, because it just doesn't lend itself to it.
Oh yeah, absolutely, right. And I think, Matt, what is interesting in this case, and a big impact here, is this SaaS world, right? Which I think changing dynamics in this case in significant cases. Because if you think about like an old world, right, where you see the enterprises self-hosting applications, right? Then if you look at this space, every enterprise will have hundreds of thousands of applications to host. Hey, you have your own, let's say, little bookkeeping system, right? Relatively small. You have your own, I don't know, say some content management system. You have your time scheduling system, right? You have whatever, right? Now, in many cases, that will be provisioned in the cloud, right? Instead, and in the cloud, that is where you have a single vendor who has to do multi-tenancy. And even relatively small applications providing some relatively small functionality, but to potentially large number of users, they have to be thinking about sharding at some point in time.
Yeah. No, absolutely. And I mean, I think that's something that's really important to, realize. Now, Peter, I want to, ask you a couple of quick questions because we're running out of time here. But the thing that I'm interested in, for those who are watching, and maybe they're thinking about learning a new database, learning a new technology, what should they be learning today? What is the thing that you would recommend to, people who are starting to pick up the infrastructure side, the database side, that they have to figure this out, whether they're a developer or someone else? If you're going to tell them, maybe a couple technologies that they should focus on, what would they be?
Oh, well, I think the first and foremost, I think it's much better to pick what you are deeply passionate about, right? In this case, right? I find what people who focus on those things, they typically became much better expert, much right, than people who just say, oh, you know what, I read this is the most, interesting technology, let me try to learn that even I have no interest. So that is for me within number one. Let's say I would say I also would focus on a technology which is changing and growing rapidly. I think from my success as an expert with MySQL was because I came in that community when MySQL was rather early, and it was kind of time for heroes, right? Right now, getting in MySQL ecosystem would not be the same thing at all, right? So I would be looking, if you think about the databases, right? Think about this cloud native and Kubernetes databases, the database which use some modern technologies like, hey, it's a separation of storage and compute, multimodal databases, right? Maybe think about a distributed system. So this kind of stuff, which is hot and growing those days.
Wow, Peter, that was a total non-answer, but I'll accept it because I was looking for you to tell people like, yeah, you should use this, but you didn't. You totally said, use what you're comfortable with. That's okay. That's an answer, but I think people like the easy answer. What? Okay. So I'm gonna
life is tough, Matt.
Yes, life is tough, but I'm gonna peg you to answer the question in a different way.
Okay.
What are the technologies, the 2 or 3 technologies that you personally are excited about?
What I personally excited about.
And you can't say whatever I'm interested in. That is not an answer that is
Well,
acceptable.
you're asking the wrong person, like I'm CEO now, right? So I may as well be interested in
You get into the technical side, you know it.
Oh yeah. Well, look, I mean, I'll tell you, right? I am excited in the Kubernetes and related technologies, right? Because as I mentioned earlier, I think that is a really great set of technologies, right? Which is going to revolutionize how we use infrastructure technologies, similar to what Linux has done 20 years ago. Is that better answer, Matt?
It is. It's better. It's better. It's better. It's still a pretty big ecosystem. It's kind of like saying that, I like the planet Earth, but that's okay. I'll allow it.
Okay.
But thank you for hanging out with us today. We hope that you enjoyed our conversation. We are, this is part of our regular community live. We're trying to fill in some content in between gaps here. And so I thought a good conversation with Peter would help with that. So we hope you enjoyed this. And if you want to hear Peter and I ramble on again, let us know. We would love to answer your questions and, get your perspective on things.
Okay, cool. Thanks, folks. Thanks, Matt.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. I'm Farokh Shahabi, the co-founder and CEO of Formally. I'm so happy to be on this event and talk to you about the no-code industry, what it means to the database industry, and what will happen in the future of work. So let's go a little back. Let's talk about the no-code industry and what is happening and what it really means for businesses. Let's take an example. If my mom decides to create an online shop for her pastries today, she can. She can have a beautiful online store with all of her products and their images up and running. She can even connect it to her bank account in less than 1 hour. She doesn't even need a computer. She can do it all on her phone. If you had watched this 20 years ago, you would have laughed. Today, anyone with no knowledge of software development or IT for that matter can create beautiful websites, big e-commerce marketplaces, or even mobile applications with just a few clicks. Thanks to no-code platforms like WordPress, Shopify, Webflow, Bubble, and a lot more. As Albert Einstein said, you don't really understand something unless you can explain it to your grandmother. And that's what is happening in the software industry as well. You can summarize the evolution of the software industry in one word: easier. All the successful products that you use every day are just the easier versions of the products that you used yesterday. Collaborating online on a Google document is so much easier than sending and receiving Word documents back and forth with your team. Installing Zoom is so much easier than having to set up a complex Cisco VoIP system for all of your team members. Searching a desired YouTube clip, it's so much easier to having to sit and watch TV at a specific time only. And of course, scrolling down on TikTok, it's so much easier than watching YouTube videos. Every day it's happening, and every product that we think is simple enough are become much, much easier and with better user experience. An easier product will always replace a more complex product as the primary solution for the majority of its users. Everything, and I mean everything we create so far, everything we invent, is a transformation of something else that we either created or found in the world before. Creation or invention is not create something from zero, is it to create something that is much, much better than existing solutions. Much faster, much easier, better user experience. Otherwise, it's just an improvement. Even if you look at the software development itself, almost all of the advancements of the past 30 years can be described like this. We made development much, much easier, and now we can build more powerful products and scale much, much faster in less amount of time. The no-code industry has grown 10 times in the past 5 years alone. Also, the rise of COVID-19 and remote working accelerated this growth tremendously. And I want to talk about data now. Data is without a doubt the core of every software. It's the man behind every software. So what about the database industry? How did databases evolve in the world of no-code developers, citizen developers, and business users? Unfortunately, the thing that should have happened never did. The majority of businesses choose these two options. One, they use spreadsheets as their database, which is a huge step backward. Two, they use software builder platforms to automatically create a database for them, which means, for example, the database design of a CRM for a big factory is as same as a CRM for a restaurant. These options are far from ideal, but they were easy enough for almost all businesses to consider them and use them as the primary option. Let's talk about the spreadsheets a little bit. Spreadsheets are not databases. We all know that. But almost every business collaborates and organizes at least a portion of its data in various spreadsheets. Is that really wrong? Yeah. And here's why. Spreadsheets don't have real access management or security control. Same as all file-based design systems, spreadsheets are huge security risks. If someone had access to a spreadsheet once, nothing can stop them from duplicating it and keeping it forever, which is a huge no-no in the cybersecurity era. Spreadsheets don't even have dynamic and limited level access management options that databases can provide nowadays. And they lack even the basic security protocols. And all of that is okay, because they were not designed to be databases in the first place, but as worksheets. We were meant to work on our data in spreadsheets, but never store data in them. The second thing that I want to talk about is the danger of copying and paste. The ability that we have now to freely copy and paste what we want in a spreadsheet is really great, super easy. But that also means that we will lose the origin of data, which is very important in our game. And we also most probably end up with multiple copies and duplication, which is neither efficient nor safe. When you lose the origin of and goal of each data point, it becomes so much harder to connect them and understand them. So it quickly can become a big pile of meaningless entries. And this is what is happening all over the world. And when you have no database design, you cannot scale. Spreadsheets may work for small use cases, but never for serious scalable work. The cost of maintenance of a tool created with spreadsheets can become too much as you scale. Arguably, creating relations in a spreadsheet is so much harder than designing a full database in the first place, and also far, far riskier. It's like filling your bath with a cup. It might get done, but the water will be too cold by the time you can use it. So what is the solution? The solution is like this. You should make databases without them even noticing them. The businesses should create their own customized database without even realizing what they are doing. Here's how. The first thing is the fact. Creating a database is too hard and too boring for most people. On the other hand, people love creating and customizing what they can see and feel, the tools they need. If it's easy enough to create and customize it, in any game that you can imagine your children are playing, they love customizing, they love building things, but they don't realize that they are in some way developing a piece of software. That's what we should show people, not boring data tables, not coding, but the end results, what they can be and how they can be used. And that's the magic of the formal data OS. So by helping businesses and business users design and create their own customized tools that they actually can see and feel. We actually are designing and building a full database automatically for them. Creating a database this way can be super easy. You don't even think about it. Same as when you play with Legos. You just need to put the building blocks together and voila, you will have exactly what you want. A database is just a structure. It's useless if it cannot be used easily. So the key is not to only create a database, because that doesn't work, because people cannot see it, cannot feel it, but to create customized tools on top of it as well. We can break the journey of data into 3 main steps in many businesses: data collection, data organization, and utilization of data. One of the biggest problems that companies nowadays have and are facing is that every business is unique, and they need their own unique tools to operate and to be more efficient. Also, they need to collaborate now more than ever, especially when we are talking about the rise of remote work, when people are not in the same building or in the same countries or even continents. Collaboration is the key. And when you are talking about collaboration, the first thing that you collaborate on is data. The world today needs more software than developers could ever possibly build. So software development by developers is not an answer. The answer is that everyone should become a developer. But development should be easy. When you create a formula, which is happening in the formula platform, a database, a business logic, and a full UI connected to it are created for you automatically, which looks like this under the hood. Let me share my screen. Yeah. This can explain the majority of the softwares that every developers are creating. This is actually a very, very famous architecture. Every software that you are using and you will use in future are somehow using this architecture. This architecture can be different in some ways. The controller can be separated in 2 or 3 steps. The view and the model can be together, but overall, it's the same principle over and over. You have an input, a data input, you are processing it, and you are showing an output. And that explains every piece of software. And that explains how databases and how data works with software. So when you create a formula, a database is created automatically for you. Brain is created on top of it, so you can work with that database and create applications. And so you don't want to bore people with all of this stuff. A view is created as well, so people can work on it. They can collaborate. They can show it to their audience. They can show it to their customers. They can use it themselves. So a data model, a controller, and a view is created automatically. And when you imply that all of these relations, all of these complex things are done automatically with just 1 click, it makes software development much, much easier. But that's not the end result. If you want to create a website, for example, you are not starting from scratch. It's still too hard. So the main thing is that don't start from zero. When you want to create a database, you should not start from zero. It's not about, okay, let's think about what I should design and everything. When you have something like this, you should have a very customizable environment so you can design as you go on. And the best thing to start is by work of others. You are not alone in the world. Everyone else is designing databases as well for different use cases. Their use cases are different from yours, but somehow similar, like 80%, 90%, 99% similar. Great. So you can start from work of others. You can start from templates, from samples, to not start from ground zero and just think about it, to see use cases, study them, and create something better. Let me show you an example. Here are templates that Formalu provide. We have, I think, 200, 300 templates now, from the easy templates that everyone can see with different UIs and with different systems, to complex applications that everyone needs for their work, all in one place. And when someone, let me move that. And when someone is navigating these templates and seeing them, and they can just duplicate it and use it as their own with a button, they can see how it works on different responses, on different devices, and they can see how it feels on different solutions. And what I can have, what should be happening, I can see my final solution in the mod. So I can customize it. I can make it my own. So I can create something more powerful than I could ever done before. And that's the beauty. The beauty is not to box people in some templates or some procedures or some approaches. It's just to give them Legos so they can create anything they want themselves. They can create mobile applications. They can create web applications. They can create forms. They can create widgets, anything they need for their business. They can create customer portals. They can create their own login sign-up situation, Kanban views, map views, anything they can, just by clicking a few buttons. So customization is a large key here. Customization means that you are giving people the ability to create their own things without your own box. So people are creating their own boxes. But with that, you make it super easy. You give them a brain, an automatic brain, with logic, with the calculations, with every feature they need. You give them ability to integrate your database to the tools they are using. Now is not the time that businesses use only one tool. They are using multiple. They are using a few dozen tools at the same time. And integration of the data is the key here. So you should be able to create a database that automatically create to any data source that you want, send data to them, receive data from them, and navigate it, analyze it, all in the same place. And it should not be that hard that you require a developer or data scientist. That's the beauty of the no-code platforms, such as Formal. So you can give people the ability, the tools to create their own tools. In a few years, it's most likely that people are not using Office applications anymore, because nowadays they can create their own Office applications. Just as like that, they are creating their own websites today, their own marketplaces today, their own shops today. Everything will be customizable if you create not a box, but the tools to create a box. Thank you very much. I'm Farokh Shahabi again, the co-founder and CEO of Formalu, and I love to hear more about you and your business. Have a great day.
Hello, everyone. Welcome to another Haas Talks Voss. I'm the Haas, head of open source strategy here at Percona, Yonkovit, and today I am here with Ovice Tariq. Hello, Ovice. Welcome back to the Haas Talks Voss.
I'm doing great. Today? Thank you, Matt, for having me here. The last time I was here, we had a wonderful conversation about databases and how we managing data at Uber, and glad to be back here and really miss you at the conference. Was looking forward to meeting you in person.
Yes, I know, right? So for those who don't know, I got COVID like the very week before the conference, so I couldn't travel. So it was horrible because you spend all of this time and energy and you want to meet all of your friends and all the people you know in the community, and then it's like I'm stuck watching on Twitter. It's very sad and depressing. So now I need to go out and do more conferences to make up for it. That's my goal
definitely.
Now.
You definitely have to do that. But look, I can tell you that the conference was success. For me personally, it was great to be back in the community in person, meeting people, and the schedule, the speakers, everything was great. I got to learn a lot of new things. So it was great to be there.
Yeah, well, I'm glad to hear it. Because the only one that you could blame for that would be me on the schedule. So I'm happy that the schedule was okay. It was good. Yeah, good speakers, good lineup. That's good. I like that. I like the feedback.
So you were there in the spirit then.
Now, Ovice, I was. I did you see that I photoshopped myself into photos? Yes, there's some videos floating around that I just ended up in mischievous places. So I'm just going to say they're quite great if you go look on Twitter for those. Always fun. But Ovice, you mentioned the last time we talked, you were at Uber, and now you're not. You have your own company now, and your company is called Tigris Data. What is Tigris all about? Tell us about what your aim is with Tigris.
Would love to do that. So Tigris, is still connected with my history with databases, and based on my experience over the last 15 years, working at Uber, working at Percona and other companies. So it's about building user-friendly database that makes it fundamentally easier to consume and use databases for real-time applications. And the idea is to move away from an unbundled approach that the industry is going towards more of a bundled approach, where the developer doesn't have to think about taking up multiple database systems, putting them, stitching them together, and managing things like data pipelines and data movement across different systems. So simplifying all of that and really providing what I think is the right serverless experience for databases.
So it's really, you mentioned different databases. So under the hoods, is it handling where data goes to which sort of database, which type of database, and it's routing things? Is that the gist of it?
If we think about data access patterns in general and what applications typically end up using, there are a couple of things that come up to be common. One is the OLTP system, and there you could be using a SQL database or a document database, and then you need real-time search because you want the users of your application to be able to do keyword searches, fuzzy searches, and be able to personalize their experience that way. And then because microservice architecture is so common these days, and that's the way to build scalable applications, event-driven development has become very important, which essentially means that streaming is very important. That's the way that different services communicate. So these are the three distinct data access patterns that I think are very important for every application. And what we are trying to do is cover these three data access patterns, but not by saying that, there's a single storage engine that's able to serve all of that, because that would simply not be possible. But instead have a single platform that supports these type of data access patterns while abstracting away the different storage engines that are used to make it happen.
So it's like one engine to rule them all, and then behind the scenes you can pick like the proper things without the end user having to understand the underlying technologies.
So one platform to rule them all in the context of real-time applications. So the user is interfacing with simple, easy to use APIs, and those APIs are backed by a smart query engine which knows which storage engine under the hood to route the traffic to, and then the platform ensuring that those data structures, those distinct storage engines are consistent and in sync.
Now, you mentioned easy, right? Like, so I'm curious, right? Like, so APIs, that's good for developers, but for DBAs, it's like APIs, isn't that what SQL is? It's just that's the API to the database. So why are you focused on easy in the developer experience? Like, what brought you to focus there?
Yes. Easy. Databases traditionally have been difficult or hard from a usability perspective for developers, especially when I'm writing an application.
Really?
Well, it depends on who you talk to, right? I mean, if you're talking to DBAs and if I wear my DBA hat, then no, databases already provide all that you need, right? You just don't know how to use it.
Yeah.
But if I put on my application developer hat, then it's oftentimes a little hard to reason about data modeling. Oftentimes it's a little hard to map between how I'm building my application, which tends to be more object focused, and then mapping it back to SQL, I think it tends to be a little harder. That's why we see things like ORM being used, right? Which is essentially providing a way for the developer to be consistent with how they are writing the application code and accessing the database in the same way. So that's what I mean by ease of use and simple APIs, that our focus is for the developer to not have to think outside the code, right? So as you're writing your application code, you use the application code to define your data model, and then you use your favorite programming language and the favorite programming language construct to access the database. You don't have to think about a separate language and a different way of you don't have to think about a separate language, or you don't have to think about a different approach to storing and accessing the data. So that's essentially the approach that we are taking, which means that if, for example, you're using Go, you would define your data model using the Go constructs, right? And then you will have APIs that are similar to any other function call that you would have, which you would use to store and access the data in the database.
And then behind the scenes, you're doing all of the scaling, the operational stuff, just handling it all on your
yes. Scaling it, keeping it efficient, making sure it's reliable, handling all of that. Yep. Backups, all of the operational stuff, right? Yeah, all of the operational stuff. So the idea is to keep the infrastructure abstracted as much as possible, while providing the right level of observability. So not having it as a black box, but still making sure that all the operational concerns are taken care of.
Yeah, and I mean, we joke a little bit about developers, like not thinking that databases are horrible and hard to use, but they do. They think that databases are horrible and hard to use. Like, I mean, I kid, but I always tell people, developers hate databases. Most of them hate them. Like it's a necessary evil, and they want to avoid it if they can. They do it because they have to store data, but they don't want to. That's why I think that we're seeing kind of a renaissance on technologies that help developers feel more comfortable interacting with their database layer, right? So, having the ability to have the security, the, availability, everything baked in, that's great. But then also giving them an interface where it's just natural to whatever programming language or, APIs are used to. It just makes sense.
Yes, and that is essentially the route that we are taking as well. You put it really beautifully that, as much as we as database engineers don't like the fact that application developers don't always love the database, that's simply true, right? And that's why I think it's important to take a cue from the application framework side. There's been a lot of interesting stuff that has happened on the application framework side, like lambdas and making it more higher level, so that developers are thinking more about business logic and not having to configure and run web servers. I think we need to take a similar approach on the database side or data side in general, and start from the developer experience. That what is the day-to-day tooling that developers using? They are using some programming language, right? And how do I make this seamless for them and not have them learn something new?
Now you're doing this as an open source project, as well as eventually commercial. So what are you looking for? Code contributions? You're looking for help in that space? What are you looking for from a community perspective that our listeners, our audience, how do they get involved, right? And what sort of help could you use?
Yes. So we are building it as an open source project. I myself am a big open source proponent, and my career has been dependent on MySQL for the most part, and other open source technologies. And we are building this. We are building Tigris as an open source solution, and there are multiple reasons for doing that. One of the reasons is, from a transparency perspective, especially when you're building a data and database product, it's important to make sure that it's clear that it's clear to the users in terms of how we're building the database, and because that's what's going to store the data, right? So transparency is really important there. Then the other aspect of open source is what you touched about, the community aspect, right? And I think that community is really important when you're thinking about building a developer-friendly product. How do you build a developer-friendly product, right? By basing the roadmap of the product on feedback of the developers, by doing things that the developers or the users of the product really think that this is making their life easy. And I think that's where community comes into the play, and I'm really focused on making sure that our product roadmap is essentially driven through community, right? So that's one core part of it. The other part of it is contributions, which is again the power of open source, which is all of these smart people around the world getting contributions from them would make the product a lot more robust, right? And that would also make
power of the crowd.
And that's essentially the important reasons why we are going with open source, to have the community support so that we are making the right product, while also have the community support to actually build out the product in the right way.
Awesome. Yeah, no, I mean, and that's great, right? I mean, I think that, having the ability to tap into the community and to work with the community, it drives a lot better code. It also drives good feedback. It helps you with your product roadmap. I mean, it is kind of the de facto standard. Now, what's interesting is in the open source space, and I'm not familiar with your plans in the future, but we're seeing a lot more people adopt open source as a means to tap into the community, but then their end product ends up being the as a service model. So, a cloud-based solution that, hey, this is where we make our money. Sure, you can go grab the code, do whatever, but we have the behind the scenes cloud as the deployment method, if you will. And we're seeing that more and more with a lot of big companies, whether it's in the MySQL space or, the Postgres space, and Mongo space, whatever, where it's almost like cloud first. with open source being more of that kind of marketing type of thing to get the interest and galvanize. So I'm curious, what are your thoughts on that? I mean, is that a trend that you've seen as well?
I definitely
and what do you
see
think
the
about
trend. I definitely see that more and more happening. Definitely see that a trend. And the way I think about it is, I think that is essentially using the community to for your own gains, but not actually giving back to the community, right? So it's especially if you have built out a open source product, and there are different variations of how these companies are building out the business. For example, the deployment code is not open source, right? So yes, the code is there, but how do you actually run it in production? That is not open source, right? So is the product really open source? Then the second part we see is other types of licenses, which essentially mean that the product becomes open source when it has actually grown old, right? Like, okay, this will become open source after 3 years, 2-3 years. Well, after 2-3 years, there are going to be so much security holes, so many bug fixes. Who is going to actually use your open source product? So I definitely agree that I see this more and more as a marketing ploy, and not really contributing to giving back to the community and making the community more empowered. Which is why the approach that we are taking is that everything is going to be open source. We are doing the development in open source, and that also includes the deployment mechanism. That the deployment pieces, for example, we'll be using Kubernetes to make it to be able to run the system, and everything around that is going to be open source. And we would eventually end up having a hosted version of the product. But the hosted version would be no different than what is open. So it would just be, think of it as an installation of the product that is available open source. This is not to say that the hosted version is not needed. Hosted version is still needed because not everyone would be able to host it. But I think that when you're utilizing the community to grow your product and take it forward, in order to give back to the community, you need to make sure that you actually make the open source part usable. You provide it in a way where people can actually use it and run it if they want to.
So, it's an interesting thought. So I was, KubeCon was also this week, and being at home, stuck with COVID, I was, like I said, I watched basically Percona Live through Twitter, which meant I picked up on all the KubeCon things as well. And there was an interesting thread that I started to see throughout some of the conversations at KubeCon, which was, there are the most popular topics are the user topics, not the contribution or the deep kind of open source topics. And that really got me thinking, and we've done some surveys here at Percona about this as well. I think the generation of developers and users isn't necessarily as tied to open source as a must as much as it is a checkbox. And they really more care about the button, right? Oh, look, I'm just going to click the button and you say it's open source. So I'm just going to trust that it is, but I don't really understand underneath the hood or really care. And I'm not going to contribute. I'm just going to use. And I think that that's a really weird trend, and I don't know what to make of it yet. But getting to kind of the the different model here, and contributing back to the community. I wonder if we've kind of tricked people into open source is a term, and it's just another one of those scalable, it's web scale, right? Is it turning into something like that now, where we all love an open source who've been in the community for a while, but for a lot of folks, do they understand and do they care anymore? That's a tough question.
That's a tough question. I think that on our part we need to do more education so people understand what truly open source mean. But I think that the other part to it is essentially the cloud, the impact of the cloud, right? Because more and more people are now used to clicking the button in the cloud, just having the solution available to them, right? And not having to run it themselves. And that is a completely fine expectation, because most of the products don't tend to be infrastructure specific products, right? And giving the user the ability to not have to worry about infrastructure is important. That's how you enable people, enable a lot of these developers to move forward with their businesses and their products. So that is definitely one reason why it is this way. I do think that people care a lot about open source. And especially over the last few years, we are seeing more and more trend open source with being something really important. And when, as part of building our product, and we have talked to a lot of users of databases, right? And one thing that has always come up is the open source part, that they would very much prefer to have something that's open source. And in some cases, if it's not open source, they wouldn't even consider it, right? Because like one of the things that you were mentioning, that open source, there's definitely the transparency aspect and community aspect of open source, but the other aspect of open source is quality. Having a product open source ensures that the product has longevity, the product has more quality, and that is something that that people see when they use an open source product.
Well, with this push button kind of environment that we're in now, where it's it's all about how do we just make developers forget about the infrastructure, right? What are the pain points that developers are facing in the data space now? Like, what are you seeing like as the critical issues that keep on popping up? I've got a few that I've seen over and over again, but I'm curious, what are you seeing in the space in terms of, hey, now that we've solved or we've got solutions for high availability or for, uptime or, like scaling, a bit, what sort of pain points do developers care about?
Yeah,
and
so
what resonates with them now?
from a usability perspective and developer experience perspective, I think the biggest pain point for developers is actually related to the unbundled architecture approach, or unbundled product delivery approach that the industry has taken, where instead of the developer having a end-to-end solution, we provide the developer with Lego blocks, a lot of options, and then we expect them to pick the right option and connect the right Lego blocks and connect them in the right way, while learning each of these Lego boxes individually, while operating, managing, observing these individually. And that is the biggest pain point that I see, that from an architectural perspective, the Lego based approach or unbundled approach, if I'm building a platform myself, like the way I'm like Tigris, that makes sense, because that's the way to build a scalable architecture. But when I'm building it from a user perspective, the user should not have to worry about many Lego blocks and how do I stitch them together and how do I stitch them in the right way. And I think that is the biggest impediment that I see, based on my research, developers are seeing these days, that they would very much want to have a end-to-end solution that works for them out of the box.
Yeah. And a lot of times the database side of things is a secondary thing, right? So there are solutions for, a lot of deployment methodologies and, methods for the application side, the tools in the application. But from the database perspective, it lags behind a couple of years. So it's a magnitude more difficult to handle a lot of those issues.
For sure. And that is exactly where I think that we are trying to innovate, that how can we push the database industry forward and, start thinking about it more from a user perspective and not necessarily from our perspective as database developers.
So, pushing the database, space forward, there's quite a big ecosystem out there. There's a lot of database companies. Where do you think is the next big thing in the database space? Like, where do you see like the space evolving here? Right now, we started to see some new SQL type applications and databases start to pop up. We're starting to see the emphasis on the developer. What's the next big thing?
We will see more and more emphasis on developers. For sure. And we will see the industry go back in circle. Remember back in the Oracle days where Oracle was able to handle, there's different type of use cases. We will see more, and that's what I refer to as a bundled approach. So we'll see the cycle go back there, where we'll see more and more of these, unified solutions or that work out of the box. So I think that the industry is going over there. And then the other thing that is important is I think that there's going to be a blurring of line between purely a database versus a backend that can also run some business logic, which you have been in the database industry would remind you of stored procedures and stored functions, right? So I think that we will see more blurring lines between application frameworks and database, and we'll be moving more towards a backend approach where, as applications are moving more towards a Lambda style architecture, we would see more and more business logic getting pushed down to the database, and we'd be seeing a push more towards a unified solution. That's more on the delivery aspect of thing. And I think that there's other aspect of it as well, due to increased focus on data privacy and regulations. The other important aspect we will see is databases being distributed instead of the centralized approach that we saw emerge over the last decade. We'll see more of a decentralized approach and pushing of the data close to the user, doing the processing close to the user, instead of bringing everything in a central place.
Yeah, no, it's an interesting point that you make, that there's this technology's cyclical wheel that goes on, and I think most people don't realize that like a lot of technology that we use today was really invented like 3 iterations ago or 4 iterations ago, and we just rediscovered it and repackaged it. And a lot of the ideas that we come up with for new things, they've existed before. It's just we're rediscovering. It's an interesting space, and you can learn a lot from how people have done it in the past. And I constantly see the pendulum swing one way, and then people go like, oh my God, we're so distributed, we're crazy, we've got all these things, now let's go back and consolidate. And then we get too consolidated, and it's like, why are we spending all this money on these monolithic big things? Let's go back and go and distribute again. And so you get this back and forth. And I think you're going to continue to see that happen because in the tech space, it's just a wheel. You got to wait long enough, and eventually it'll come back around into popularity.
Do you see the circles and in the tech space in general, even if you look at the programming languages, moving from dynamically typed languages to statically typed languages. So there's definitely this is definitely something that we see. But I think that whenever a new iteration happens, when we go back in the cycle, we do come back in a better way because technology has generally moved forward.
Yeah.
So when we come back, we come up with a more efficient solution, a solution that will take us forward further.
Yeah. Yeah, I mean, I definitely see that. It's something that is an interesting thing to see. But yeah, so Ovice, I'd like to play. You didn't get this opportunity to play this game with me last time that you were here, which I'd like to now. I've started this thing of just asking a lot of rapid fire questions, just so people can get to know my guests. It's actually a pretty interesting, fun way to just hear about you and learn a little bit about Ovice. And, so these are 100% random questions off of the top of my head, and I do not know what I'm going to ask. Okay, so I'm just forewarning you. Are you ready?
Well, yes.
Are you ready?
But let's say yes.
Okay. Growing up as a child, what was your favorite food?
My favorite food was barbecue. Yeah.
Barbecue. Okay. And now what is your favorite food? If we're going to take you out to dinner, what kind of restaurant or place are we going to take you?
Barbecue. I haven't changed much.
Oh, yeah. So you haven't changed much at all. Okay. That's okay. What's your favorite vacation destination?
Favorite vacation destination? That's an interesting one. There are a lot of places in California, so we keep visiting it. But I haven't been to Mediterranean, but that seems to be the place that I would want to go to, and probably would be my favorite destination.
Okay, all right, fair enough. What was the last book
that I read? Amp It Up is the book that I read last. It's by the Snowflake CEO.
Okay.
I definitely recommend people reading it. It talks a lot about execution and delivery, and Essentially, execution delivery is what separates you a successful company from one that's not successful. So I highly recommend reading it.
Okay, fair enough. What about your favorite
My
movie?
favorite movie is the Dark Knight series, Batman: The Dark Knight series. Not this one, the one with Christian Bale. That's my favorite.
Okay. So is it because of the Joker and Heath Ledger, or was it just
I think it was
the whole series?
Heath Ledger for sure.
Okay.
Phenomenal, acting, but in general, I just really liked how emotional it was, and it really gets me emotional whenever I watch it.
Okay. Well, there. Yeah. Maybe you could be the Dark Knight of the database space, right? So you can, you can fight for data justice. That'd be cool. I don't know. We could create a comic book character. Somebody out there create Ovice into a comic book character for us. We would appreciate it. So, out of all the database releases that you have been part of and all the different databases, what has been your favorite database release?
Been my favorite database release? Of course, MySQL 8, I think, was a leap forward. So I think that was a big step forward. MyRocks, bringing in RocksDB to the MySQL space, and but I think that the one that I liked the most was the work that we did at Uber, building Uber's distributed document database, and taking that into production and building out a scalable system. That was one of my best experiences, I would say.
And finally, we'll end with this one. What is the absolute dumbest piece of code you've ever seen moved into production? Like you scratch your head. Maybe you had to fix it. Maybe you're working at Percona and somebody got called in the middle of the night to fix something. Maybe it was somewhere else you worked. What's something that's so even today, you're like, what? How did they do that? That's just awful.
Yes. Well, I am a perfectionist. So there are so many examples that I can think of where, it was just so hard for me to understand how this got into production, and I ended up rewriting it. So yeah, hard to come up with a single example, but yeah, I definitely say that lots of such cases. And in fact, when I look at my code a year later, I see the same thing, that how the hell did this go into production?
Okay, fair enough. All right. Ovice, thank you for coming out. For those who are interested in Tigris data, you can go to, is it tigrisdata.com?
It's tigrisdata.com or tigris.dev if you want a shorter one. And Tigris as in TIGRIS.
Okay, and I would encourage you to follow Ovice and the team on LinkedIn and Twitter and all of the socials. And thank you for hanging out with us today, telling us a little bit about Tigris and talking to us about the open source community.
It's been a pleasure coming here again, and thank you so much for setting up this podcast. I've been following it, and it's a great learning experience. So I'm super happy to be here, and looking forward to being here yet again.
Oh, great. Yes, and Ovice, I think you might have seen. I ended up being #1 in the open source database market podcast in Tunisia. So it's growing in popularity. I have that #1 moniker in Tunisia. I'm aiming for the #1.
You will get
the rest
there
of
for
the world
sure.
now,
Yeah,
so.
this is definitely one that I follow,
I'm
and
gonna
I really
get there.
want anyone who's listening to really follow this podcast.
Awesome. All right, thanks, Ovice. We really appreciate you hanging out.
Cheers.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hi, everybody. Welcome to Percona Community Live. This is our community portion of Percona Live. We're excited to have you here, and we hope that you're enjoying the content that's out here streaming for free. For those who couldn't attend Percona Live in person, this is specifically for you with speakers who couldn't attend either. But we do have all of the sessions from Percona Live recorded, and they are available on our website. So if you go there, you can register for the app, and you can browse and watch sessions on demand from the Austin in-person event. But today we're here to talk about Postgres and the mistakes that we see happening over and over again. Now, typically I have a partner in crime in this, someone who helped me build these slides. That would be Barret Chambers. He could not attend today and make it, so I'm going to be flying solo. So hopefully I can bring all of the fun and excitement that Barret would generally bring in this session. Now, I'm the head of open source strategy, or the HOS for short. Here at Percona, I've been in the ecosystem for a long time. If you follow anything that Percona does, you probably run across me once or twice at least. I also have a podcast, so if you are interested in getting some awesome sessions on various topics in the open source space, the database space, feel free to subscribe and like the HOS Talks FOSS podcast on your favorite podcast app or on YouTube. Now, when we talk about mistakes that people are making or the sins that people make when it comes to Postgres, the first place that I often want to look is I want to look at what we're seeing from our support community. Now, Percona provides 24/7 support for Postgres, and that means that people are calling and asking us for help when they run into situations they can't handle on their own. And we do have some metadata about what sort of issues people are opening. So let's take a look at that. So the most asked support questions tend to fall into three main categories, right? Configuration, setup, and installation. So, or upgrades as well. So how do I do those things? I might not understand how to tweak something. Something's not working quite right in my setup, so I need some help there. Then we also have a big portion of tuning and monitoring. So how do I find issues? How do I fix slowdowns or things aren't behaving quite the same way that we would expect? Okay. And then we also have HA replication issues. So things are not failing over. Maybe replication has stalled. Maybe it's not, keeping up. How do I fix that? Maybe it's just how do I set that up? Now, of course, we do have some things around bug crashes, backups, and security, but you can see that the vast majority, almost, 3/4, actually a little more than 3/4, falls into that HA replication, tuning, monitoring, or configuration setup. And there are a lot of things that could drive questions in those space. So let's talk about some of the more common ones that cause issues. Okay. Now, when we talk about, performance tuning and HA, and we talk about, the configuration and the setup, oftentimes Postgres is installed alongside other extensions or tools. And that means that there is a high likelihood that some of those extensions and tools could be causing issues. So I'm going to count down, and number 10 on our list of things that are causing, issues and cause problems are selecting tools that don't necessarily meet what your requirements are, or you don't understand how to use them. Okay, just like this guy who, hey, he probably knows how to use a saw, but he doesn't know how to use a bench or a table because he's using his friend's back as that. Not a good thing. So a lot of people will deploy some of the great tools in the ecosystem, but not quite understand the nuances or the difference. Let me give you a couple examples of this. So pgBouncer, pgPool, HA Proxy, these are popular tools, but they do things a little differently, right? So pgBouncer is really there for connection pooling, whereas pgPool provides some connection pooling, but also load balancing, but it's not as lightweight. So if you wanted to deploy HA Proxy and pgBouncer, you can get the same impact as pgPool, but you have to have two tools. sometimes people will assume they'll get load balancing and just install pgBouncer. And that's not, necessarily correct. And you won't find that out until an issue happens, right? Server goes down, you're like, oh, wait a minute, I should have some sort of load balancing. I should have some sort of failover. And it's not necessarily working. Or maybe you're using connection pooling across multiple, nodes, and it just doesn't work. So understanding the tool selection here is really critically important. But probably a better example of this is actually on pgRepack. Okay, so probably one of the most widely used tools for cleaning up, that space, that dead space that's in the database. So there are some issues, however, if you use pgRepack, right? Locking issues can occur on busy systems. Some DDL operations can be frozen or killed. So there's actually quite a few nuances to running this tool. And if you kick this tool off and you have a high production workload, you could run into issues you didn't expect. And so often what we'll see is a lot of those performance issues that do occur come from someone who they have a tool, they're running some maintenance, they're doing something that should be lightweight, and what should happen or happens 99% of the time doesn't happen that 1% of the time and causes a cascading impact. So understanding not only the tools, but the nuances of the infrastructure and the technology that you're running is critically important. And there is a blog on this. I would encourage you to check that blog out. Now, number 9. So you might have the right tools for the job, but are you secure? Have you set up security? And so unfortunately, a lot of people treat database security like this gate. It's totally secure, right? Totally secure. So if everybody stays on that path, they're not getting through it. But they leave a lot of holes open. And so we do regular surveys of the community, and what we found was 1 out of 10 in the database community, so actually a little more than 1 out of 10, were impacted by some sort of database security issue. And that was up from the previous year. So this is a real issue that does occur. So you have to make sure that you are setting the database up properly to be resilient and secure. And some quick tips here are to avoid some of these situations, right? You have to use SSL to encrypt traffic. Otherwise, you're sending data that can be sniffed and it can be, redirected and then reused. Also, opening up Unix socket parameters can cause some issues. But probably the most common security issue is over granting permissions, right? So you have a user, it's an app user, you grant it full permissions on the database to do everything. Somebody gets onto the app server, all of a sudden they can, weed their way back into the database server and they have full access to do everything. That is an issue and something that you need to pay very close attention to. Also, you have to understand that there are some best practices that might be different than how you've operated in the past. Things like storing everything in the public schema. Or maybe you've never done any sort of auditing. Well, as you get bigger and you run into compliance type regulations, you will need to look at, ways to kind of come back to the security side and prove that your database security practices have been consistent and have prevented issues to the best of your ability. Now, the good news is, security issues are something that we're all hyper-focused on. So whether we are looking at, different ways to encrypt data or to keep, intruders at bay, as new releases come out, you do get some additional help. So for instance, in Postgres 14, Scram SHA 256 is now the default authentication. So it's harder to crack passwords. Previously, this was MD5 by default. Now, we also have predefined roles. So one of the problems with role-based security in most databases is it's a pain in the rear if you're trying to just give people read access to everything or write access to everything. And you'll have to go through and you'll have to get all the objects, and a lot of people just give up and they're just like, I'm just going to grant it all. I'm just do everything. And so in Postgres now, there is a PG read all data and a PG write all data. So something that's a little easier and it can be a bit more secure than trying to remember, did I grant that? And maybe I didn't, so let me just give full permission to everything. So you want to avoid that. So security is a huge, huge issue. Now, of course, I can't not talk about Postgres without bringing up our number 8 issue, which is cleaning up after yourself. Okay, you know, and you probably all know that I'm going to be talking about vacuuming here. Okay, so those who don't know Postgres, as you update, you delete, you make changes to data, it actually leaves that data in place, and then it's marked for deletion later on, and then a vacuum process will run either in the background or on a schedule that you set up to come back and clean up that empty space. And things can get quite dirty, and if you aren't careful, this can be a significant, source of performance problems. So the proper use of vacuum, whether this is automated or not, is incredibly important. Okay, and so there is a process that's called auto vacuum that will run in the background, and you need to understand how to tune this. Okay, and so you have got the auto vacuum threshold and the auto vacuum scale factor that will tell you how dirty the database or the tables can get before you take action. Okay, and then you can also tell the system how many auto vacuum workers to run in parallel. So you can say things like, oh, once we reach, a certain percentage of, space that's dirty or dead, let's go ahead and clean it up. But probably the biggest issue that you see in this space is with people who delay or push off the vacuum because it's such a intensive process in a lot of cases. And they risk having issues with a transaction ID wraparound because that old data also will have transaction IDs that's associated with it, and until you clean up that data, can't release it for the future usage. So you'll actually run out of transaction IDs and it will force the issue on you, and that causes some pretty significant slowdowns in some big systems because then you are forced into taking action. We do have a couple of blog posts on that, as well as a couple of podcasts if you're interested in learning more details on that specifically. But understanding how fast your data is changing, understanding the workload patterns, when maybe vacuums are more appropriate, and then looking at the tools. I mentioned PG Repack. That's something that is actually a really valuable tool that can help, ensure that you're getting good, performance out of your maintenance operations, and you're keeping ahead of this issue. Now, in PG-14, there are some enhancements that were introduced specifically for vacuum, right? So, the way that tuples are compacted has improved. There's been a pretty significant work on improving the overall performance of vacuum. So that's a really good thing. So faster vacuum, faster maintenance, less impact on the system. Always, always appreciated. Now, you've got vacuum. We've talked about tooling. We've talked a little bit about security. But one of the issues that comes more from the application side, and this is more of a design discussion, is how you are connecting to the database. Now, I mentioned that there are connection pooling tools, as well as load balancing tools that you can use. But one of the critical things in the Postgres space that many people overlook is that the number of connections matters immensely. So having too many connections, especially in Postgres, is really, really challenging. Okay, and the reason for that is Postgres, the connection model, has memory allocations for each connection. And so you could see 20 to 50 gig or megs of memory used per connection. And there isn't, that threading model that MySQL has, for instance. And this means that, as you are scaling those connections up and as they're getting bigger, you're going to be consuming more and more memory, which is going to cause more and more of an issue, right? And then you're going to potentially start to run into swapping issues or other problems. So because of that model, you need to be very careful. We often recommend that you set up connection pooling. So pgBouncer plus HA proxy or pgpool2. But realize that each of those tools may in fact introduce latency to the system because it is an additional hop. So make sure that your connections are taken care of. If your app is opening up a lot of connections, make sure that you do have some connection pooling somewhere in the overall system and setup of this. Now, in Postgres 14, this has gotten a little better. These numbers might not look significantly different, but you can see that the number of concurrent connections has seen some improvement with the most recent release. Now, it'll be interesting to see what Postgres 15 does, if anything, to help improve this as well. But Postgres is generally pretty good about incremental improvements across the board on performance, security, and other topics. So we'll be looking out for that. Now, of course, I mentioned that nearly 30% of all of the issues people open up are around setup and configuration type issues. So it's no surprise that number 6 for us on the list of sins or issues that people continually come back with is people who think that the default configuration is the way to go, right? It was built by smarter people than me, so I'm just going to leave it as default. There are a lot of issues if you just leave the configuration left alone. Namely, you have to realize that the database out of the box is designed for a very general purpose use case, and it is not optimized for what your workload or your servers have available. And so there are some very, very rough estimates here, okay? Effective cache size, shared buffers, where you want to set them. Work memory, some people say that this should be, much higher than this. It's going to vary depending on the system that you're running. And also, don't forget those vacuum settings. So from a performance perspective, there are some things you want to look at. Obviously, any database, the more that you're storing into memory, the more effective or performant the database is going to be. So obviously, these shared memory settings are going to be critical. And then when you look at the vacuum processes, those are going to help, and we talked a lot about those as well. But the other thing that we haven't talked about is actually on the wall side. So when you're talking about like the transaction log, when you're talking about either for replication or for backups and doing hot backups, having those logs tuned can make a significant difference in random slowdowns and issues. So the wall settings by default are going to have checkpointing happen fairly frequently, which may not be a good thing if you have a heavy write system. So typically, and again, I would say that every application, you want to take these recommendations with a grain of salt. You want to have wall log file sizes that are slightly bigger, maybe a gig, sometimes even bigger than that. But again, depends on the application. I don't want to give you, advice that everyone should go out and set this. But you want to look at the checkpoint timeouts, the max wall size, and then the checkpoint completion targets. And then, of course, as the system's processing, you want to make sure you have enough data to understand what's going on. And so having logging debugging set up like, log temp files, log checkpoints, log auto vacuum, right? So those are going to tell you when events are happening so you can go back and debug later on. So my question to you for number 5 is, do you over or do you under? And what do I mean by that? Well, you see, what I mean by that is over or under indexing. Okay, so one of the problems is more is always better, right? that philosophy, and I mentioned with connections that's not necessarily true. In the case of indexes, obviously having too many indexes can cause issues, but having not enough indexes could also cause issues. So it's like the Goldilocks syndrome, right? This one's too much, this one's too, or too hot, this one's too cold, this one's just right. You want to make it so it's just right. Okay, every column doesn't need an index. Most columns that you're filtering on regularly probably should. But you can look at, there are some views out there, pgstat all indexes, pgstat IO all indexes, to see what indexes are being used, see which ones you might be able to get rid of, and understanding the difference between the different index types is critically important. Now, the reason you don't want to have too many indexes is not only will the indexes impact the performance of select statements in a positive way, it will degrade performance of updates, inserts, and deletes, and it will cause potential slowdowns if you have too many as well. So keep that in mind. It's very important. Now, of course, in Postgres 14, there are some enhancements as well that have occurred to reduce some of the bloat and some of the issues with indexes, improving them. So I think a lot of these go hand in hand with some of the auto vacuum features that were implemented as well, but also can help boost performance a bit. Now, Postgres is a outstanding ecosystem. I mentioned that there's a lot of different indexes. In fact, knowing the different types of indexes is critically important, right? So, btree, hash, gin, gist, brin, there's an index for almost every use case if you're looking at, for something. And knowing which one can be deployed when is important. And Postgres has developed a massive list of extensions that you can use, not only from an index perspective, but just extensions to the overall Postgres experience and core, which is great. We love extensible databases, but sometimes, again, more is not better. And a lot of people end up adding extensions just because they think in the future they might need that extension. And that is a classic blunder, right? And so while Postgres is super extensible and they are wonderful and there are many different awesome extensions out there, you have to understand that not all of them are designed to work together and have been tested to work together in all cases. So as you start to integrate them, they can introduce issues. I've had extensions that have caused certain database workloads to completely crash the server. I've had extensions that when you combine the two, like two extensions together, it causes performance issues. In fact, one of the first things that support engineers told me that they recommend if there is a performance issue is have you turned off the extensions you don't need, because a lot of times those extensions cause weird problems, especially if they're not from trusted or reliable sources. So this is an area where you need to be careful, because obviously you're adding an extension because there's some benefit to it, but the question is the benefit worth it? And are you really going to use it? Because every release that comes out, every new extension that comes out, there's a possible conflict, and you can't guarantee that the compatibility of the extensions has been thoroughly vetted to the point that Postgres and the core engine of Postgres has been tested. So be very careful with extensions, even though they can provide some awesome, awesome things. Now, of course, we've talked a little bit about performance. We've talked a little bit about, objects, schema. Talked a little bit about, the configuration. But one of the things that we haven't talked about that does take up a significant portion of our support engineers' time is outages, HA, right? So what sort of issues are causing an outage, and what sort of things are out there? Now, if you have a system that has a required SLA, you have to have HA. HA is not a substitute for backups. Backups are not a substitute for HA or high availability, right? There is a significant difference between those two. Just because you have one doesn't mean the other is sufficient. Just to give listeners a heads up on the difference here, when we're talking HA, we're talking about the ability to fail from one server over to another and be able to recover quickly by redirecting the workload to a standby server. Whereas backups, we're talking about a physical copy of data that we can then restore over a broken system. Now, why are these two different? The classic example is you can have a database that is being backed up, and if you drop a table in that database in your HA setup that has a standby server, the table drop will propagate to your standby. And so you will eventually pull up that, fail over to the other box, and it will still be missing the data. This is something that we've seen happen numerous times. It's not a good situation. That's why you need both backups and HA. And this is a common problem. Okay, whether you're running in the cloud or not. Many of you might be relying on, whether it's Aurora RDS or RDS Postgres or Azure SQL, and it's got built-in backups, it's got some built-in HA. But understand that, cloud outages happen and regular outages happen. And you can't outrun these outages. So you have to understand what your strategy is and how to employ it, right? This is a common problem where, you trust a service provider. You have the button that allows you to do the failover. You've set up something in a different availability zone, and then the cloud provider has an outage and it just doesn't work because the availability zone where everything was stored is out. So what do? And that means that you have to make sure that you've configured it in such a way where you're going to fail cross availability zone or maybe even fail cross cloud provider. So understand outages do happen, and 1 out of 5 who are running in the cloud experience this. 1 out of 3 who, regardless of if they're in the cloud or somewhere else, experience this as well. So odds are you're going to run into it. And, really, the story is Postgres is great as long as it's up and running. And if it's not up and running, then obviously, that's an issue. So make sure that you are prepared to recover from a variety of outages and have tested the scenarios and have those scenarios documented and scripted and ready to go. When was the last time you tested a failover or a backup? I shudder to think of the times that I have had to talk to a customer where they have said, well, I have a backup, but my backup can't be restored. I never tested it. If you are taking backups and they are unrestorable, it's a waste of time and effort. So you have to, if you're doing this as a preventative measure, you have to at least once in a while ensure that backup is a restorable copy. Again, super critical. Now, as we talk about HA and backups, some of the things that you want to remember, right? First of all, those wall settings that I mentioned from the transaction log are going to be incredibly important for both replication and backup and recovery. So make sure that they are set appropriately. Make sure that those configurations are appropriate. But how are you managing your HA? Is it a click button? Do you have to go in and manually do something? That's going to be an issue if you have a high mean time to recovery, right? So, if you need to get up and running very quickly and you are not using automation to do your failover, that's an issue. There are many tools out there that can do high availability and automation around failover when a node fails or has an issue. We use Percona quite extensively with something like HA Proxy, but there are dozens, if not hundreds, of tools that can do high availability automation. And so I would recommend that you look into these if you are not using them, so you have some protection, because every second can count. If you're down, users are going to suffer, and that could potentially cause issues that have a cascading impact on the overall health of not only the application but the business itself. And also, when you talk about backups, what sort of policies and tools do you have? Right? What are you using to do backups? Are you just doing like a base backup? If so, that could be a lot of overhead, and it could be very difficult to restore. We've done some live streams where we've had to do that, where we've gone through and we've used the most basic of backups to try and do restores. And you've got to do some script foo, if you will, in order to get the right LSN number and where do you want to start and stop. So we recommend tools like pgBackRest. We also recommend things like having a minimum retention of 7 days of backups, just in case you didn't catch an object or an issue with a backup, so you have some protection. But also keep in mind there's different types of backups. You don't have to do a full backup every day. You can do incrementals or differentials, depending on your setup and the size of the database. So you might want to mix and match what makes the most sense for you, but realistically you want at least one full every week if possible. And you want to make sure you're not just storing backups locally. That is also a problem. I've run into that. It's not fun when someone calls up and, my system's down, I need to restore from backup. Where's the backup? It's on the local drive. Well, is the server up? Nope, it crashed. Not much I can do, right? So you want to avoid that one. So HA backups, incredibly important. Make sure that you're following that. It seems like easy advice, but if 20 to 30% of people are asking questions or running into problems where they are experiencing an outage or having to deal with issues here, there's not enough people who are paying attention to this area. So it is a big, significant problem. Now, number two, we talk a lot about performance, but performance, especially in databases, is really dependent on the workload that is running on the system. Now, we talked about some basic configurations, avoid just the default configuration. But when we talk about workload and tuning the database to the workload, this is where you're going to have a lot more adjustments than those best practices, right? Sometimes you have workload that evolves and changes over the year. For instance, tax season. Accountants are really busy for a couple months, but then all the rest of the time, they're not really busy. So that workload change is important to understand and plan for. And I mean, that's not just a seasonal thing. It could be a weekly thing. It could be that you're busier on weekdays during business hours than off hours. But it also could be that you're write heavy versus read heavy. It could mean that you are, constantly processing data at night, all kinds of different things. But there is the ability to make some adjustments in tune, because this is where a lot of slowdowns actually occur, is not understanding the workload and how to get the most out of that workload. And right now, sad fact is, more than 50% of users who we talk to still say that they have slowdowns and performance issues, in their database layer. So over the last year, half of the people who are listening to this talk are going to say, yeah, there was some sort of performance issue. Not all of it's going to be related to workload, but this is a real problem. So this gets down to understanding and setting a baseline for what your system can do and can't do, right? So what sort of observability tools are you using? Do you have monitoring tools in place? Have you looked at what the limits of your system are? We use Percona Monitor Management for insight, but there are other tools out there. It doesn't have to be that. But what you want to do is you want to understand that if most of the time your queries, your latency on your queries is 100 milliseconds, and you're generally doing 2,000 queries a second, if all of a sudden you see an adjustment to 4,000 queries a second and a 500 millisecond response time for latency, that's a change in the workload that you need to be made aware of. And not only do you need to be made aware of, you need to dig into and figure out what changed to see if that's the new baseline, or to see if, it was a transient, thing that's going to go away. Because you might have to then adjust and add additional hardware, or rethink how your deployment mechanisms are, or how you even design the system, right? Really, really important. And, you do this in the database side, and there are other things to look at, what sort of use cases and queries are hitting the system. But this is not just a database side of things. You also want to look at the system itself and look at that, that data for what's happening on the system, CPU, memory utilization. But you also want to tune the various kernel parameters in the OS to match what the expectation is for that workload and what the expectation is for the application. And understanding not only the baselines for the database, the application, and the systems, but also being able to see what changes you can make to improve those baselines and give you more opportunity to grow. Now, any guesses on what the number one thing that we see over and over again? Okay, I actually have two, but so there's going to be like a number 0, but it's like a bonus round. But the big thing that often happens, okay, is when people design something that is obviously a mistake, right? If you look at where we as SREs, DBREs, DBAs, people who are dealing with the database side spend our time, where do you think that is? Okay, I'll run down where that is based on our survey. Number one, building automation. That makes sense, right? More automation that you have, the less work you have to do, more efficient you are. Makes total sense. Moving data between environments. Okay, right? So data from A, data to B, okay, yeah, hey, moving stuff around. I get it. Troubleshooting problems, 11%. 11% of folks said that they, spent, time troubleshooting problems. And that kind of goes into query tuning, right? So obviously query tuning is a big area, and that really is a problem, but it's also a performance issue. So a lot of query tuning efforts. But what is the number one thing where people spend their time and consumes most of their energy? That's working with developers on their application and trying to make this right. So it's that poor database design, right? By far the most common issue is really, really inefficient design. And that's because we've lowered the barrier for a lot of people to develop applications to the point where they don't need to think about the database side of things, right? They don't think about the schema in a lot of cases. They don't think about the queries they're writing. So they'll throw things into any sort of like structures that make sense or that they think are okay without any sort of thought process. I hear this all the time that, the impact of choosing the wrong data type can have a significant, detriment to your application. Using an integer or a numeric versus a varchar, for instance, that can add overhead that's in some cases 2 times slower, sometimes even more. Why? Because it's more efficient to process and to store and to handle the integer and the numerics. It's a smaller footprint, takes less memory, takes less disk, easier to find in an index, easier to process in, CPU cycles. So that design aspect is often overlooked because it's kind of, it's boring, right? For a lot of folks. And we've turned from a development standpoint to over-reliance on ORMs. So we try to hide and mask as much of the database as we can. And so that becomes a significant issue. Now, not only is there a database design issue, but people are really smart. And, this is, I'm going to call this a bonus issue, but this is really kind of hand in hand with the design side. You also have, this setup with a poor database design with a Rube Goldberg design, right? So a massively over-engineered, system that has poor database design and is using all of the other 10 deadly sins that we mentioned, right? You've got a whole bunch of extensions that you might not need set up. You've got a whole bunch of tools that are just implemented because they might do one little tiny thing that you really didn't need it to do. And, you build out systems that not only have one database, you have a dozen databases. So from an application perspective. And this has really led to an explosion in the number of database instances that are out there, right? So, look at this growth rate, and again, this gets back to the more is not always better. The number of databases in production over the last 3 years that are of in environments that have more than 100 or more than 1,000 databases has grown exponentially. Look at that. I mean, we go from, in 2019, we had almost 20% of people said that they had over 100 databases in production. Then in 2020, it was about 28%. And then in 2021, it was 42%. So we actually had almost a doubling the last year of environments or companies with more than 100 databases in production. And with those reporting over 1,000, it was over doubling because now we're over 20% there. That's a substantial number of databases out there. And, the thing is, no, it is not the person with the most complex system that wins, right? And by far, when we talk about the design issues, whether it is the overcomplicated architecture, it's the underdefined schema, it's the bad database design, it's the wild and woolly things. This is the number one issue that our engineers see more often than not, and it is the number one problem that you need to avoid in order to ensure that you have a system that can run and a Postgres database that is happy and running well. So that's it for our session today. We hope you enjoyed it. Feel free to ask questions in the chat. So this session is recorded, but we will have people hanging out in the chat to respond to questions. So feel free to put them there. And we hope to see you next time. Thank you very much.
So my favorite, so when I sit down on a PMM, and the customer is already telling me, hey Marcos, we have a problem on this node started at this time. Those are the first two things I need to know, right? Like which node I should be looking at and what time the problems started. So the first dashboard I will take a look is my SQL instance summary. I will make sure I have my the proper node selected. And then I will start going one by one on very much every panel. So what I'm looking for, of course, are anomalies. And I don't know what's going on. Like they only tell me things are slow. That's how it usually goes. They tell me it's slow. And so I have very little clues. Sometimes they will tell me some more clues, but if not, what I do is go search for anomalies on every panel. So sometimes it's good, or most times it's good to enable individual metrics on each panel, because they're gonna show a different picture. Because look at this, connections, it's only in the 20s, 30s. So it's dwarfed by the max connections. So when I turn on everything, I don't see anything. Like the connections are changing. Like you can see 28, 26, 30, 29, whatever. But I cannot see it. On the other hand, when I enable only connections, I can see it. And sometimes you will find a very large spike. Perhaps it was all the time 1, 2, 1, 2, and suddenly you got 40. And 40 connections, they could push enough load to make a problem. But again, you will not see the 40 connections if you have a 2000 line reference here. So turning on and off every metric is many times necessary. The same here, right? Like aborted connects. In this case, I can see all zeros, so I can ignore it. But otherwise, if you see a few and the time when the problem happened, then enabling just aborted connects will allow you to see the spikes. Then peak threads connected and average threads running. These are pretty important. Like this is telling me like the way this changes and the way connections change are telling me about the arrival rate and the residency time. And these are telling me about actual concurrency. This is when someone is asking you how much concurrency your database is having, or is withstanding, or is serving. I'm not sure what word would you like to use, but concurrency in MySQL is threads running. So
how many are active at any one time? And typically, exactly, it's going to be difficult to get more than, like, that's the active ones that are consuming CPU resources, right?
That is correct.
So it's very difficult to get above the number of cores.
Well, it's impossible, right? I mean, you can always have some additional processing with hyper-threading if you don't count your hyper-threaded CPUs as cores. So a 16 cores with 32 hyper-threaded processing threads, it can probably do 32. Perhaps it can only do 20 plus. It heavily depends on how fast your memory is and how much different data those threads are accessing, etc. But yeah, number of threads running greater than number of CPU cores, that is very likely to become problematic. I can see you're pushing more load. Which is
I am. I am not.
Oh, you are.
It's the dungeon masters pushing more load.
Oh, he's gonna start throwing me trolls from all the angles. So, okay, I haven't take a look at the resources yet, which at this point I will need to take a look. So at the very bottom of this panel, I have a node summary, and it's gonna tell me a bit about the system, but it's not giving me CPU cores. Oh, I thought I'd have it here. So I'm gonna have to go to system node summary. So virtual CPUs too. So with the amount of, am I looking? No, I'm looking at the wrong one. Oh my God, 8, that's much better. So 8 CPUs, I like to here, so I can also see the speeds at which they are running. And I can see the amount of cache on each one. Something is a bit off here. Here it says 2, here it says 8. I have to guess this is delayed. All right, I don't care.
You're looking
If
at the
it's
last
8,
12 hours. Go to the last, like, change it to like the last 5 minutes or 15 minutes. Did it change the?
yeah.
Yeah. So there you
Course
go.
4 virtual 8. There you go.
Yeah. So for whatever, it's weird because some of these summary screens, I don't know when it takes the snapshot. It's something we should probably ask, because if you look at like a 12-hour period and the system wasn't running or it was on a different class of box, does it show you the first iteration or the last iteration or the average iteration?
Yeah, that's a good question. Like,
yeah,
usually, you know, in a more stable system, you will see this and you will know it's okay. But yeah, this we just started a couple of minutes ago, so it was prone to change.
By the way, I'm actually getting errors in the application.
You're getting errors? What kind of errors, dear customer?
I can't.
Let me see.
I can't connect.
Oh, you're getting connections aborted, timeouts. Let's see. And thread cache, you're creating threads. This is usually bad. Creating threads can be slow depending on your pthreads library and whatnot.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everybody, it's a pleasure to be here today to talk about database. I'm Charly Batista, I'm the Postgres tech lead at Percona, and today we're going to talk about disaster and how to recover from them using point-in-time recovery. Right? So let's start. Our presentation today is dive into Postgres backup using pgBackRest and how to use it for point-in-time recovery. Right. Our agenda, we're going to talk about backup, what is disaster recovery, how it relates to high availability, and what is point-in-time recovery, and how we can use them, and how we can use pgBackRest to make the process simple and to automate the whole process. Well, and at the end, we're gonna have a few minutes for questions. So, what about backup and disaster recovery? What are them? To start here, we need to have a basic understanding what is a disaster and how we can prevent or how we can recover from the disaster, because sometimes it just happens. Sometimes there's nothing we can do to prevent the disaster, right? For example, hardware failure or even natural disaster. So things happen. Right? So the best thing that we need to do to be able to recover from a disaster is to be prepared. And to be prepared, we need to have backups, right? So the backup is just the process of creating a copy of our database and storing somewhere else, not storing on the same media that we have the database. That's important to understand, because I've seen a lot of people doing backups out there and storing those copies of their database backups on the same media. So if you have a problem on the server, then you lose the server and you lose the backup. It's very important that you keep your backup safe and not on the same place as you keep your database, right? So the backup, they allow you to rebuild the database from the time when you took the backup. That's another important concept. Because sometimes people, they take a backup and they think they're safe of any problem. So, but what happens if you take a backup at midnight and then you have a disaster at 7 p.m.? So you have a lot of time from midnight to 7 p.m., a lot of hours being worked there, and you may have a lot of transactions inside of your database. Then that's something that you're going to talk about later, right? And there are different types of backups. So we can have a full backup or partial backup, or incremental backup or differential backup, right? A full backup, as the name implies, is a backup that you copy the whole database. You have everything and you copy everything there for another media, right? And incremental backups and differential backups, they're both partial backups. You don't take a full copy anymore. So they're useful when you have a huge database and the backup process takes a long time. So you don't want to spend a lot of time doing the backup every time that you want to do the backup. So you can do a full backup one day. Let's say you do a full backup on Sundays. So you do a full backup on Sundays and then you do smaller backups. And what is the difference from incremental and differential backup? The incremental backup, you always compare with the backup that you did on the day before, or the previous backup, if you do more than one backup a day, right? You always compare with the previous backup. Let's say you took a backup on Sunday, a full backup on Sunday, and on Monday when you take an incremental backup, you're gonna see what is the difference on the database from today to what was yesterday when you took the full backup. And this difference, this increment from today to yesterday gonna be your incremental backup. On Tuesday, you're gonna compare what was changed from Tuesday from the incremental backup that you did on Monday, and so on and so forth. So when you get to Saturday, you're gonna have a full backup from Sunday, an incremental that is the difference from Monday to Sunday, another difference on Tuesday that is difference from Tuesday to Monday, and Wednesday and Tuesday, they always have smaller backups because the difference is from the day before, it's from the previous backup, right? And the differential backup, they are similar, but the thing is, instead of compare with the previous backup, you have a milestone. So let's say you take a full backup on Sunday. That full backup gonna be your milestone. You always compare with that full backup from Sunday. So when you take a differential backup on Monday, we'll check what's changed from Monday to Sunday, and that's gonna be your difference for your differential backup. When you do on Tuesday, that you're gonna compare from Tuesday to Sunday. So your backup on Tuesday, they're gonna be larger than the backup on Monday. And when you do on Wednesday, on so on and so forth, when you get to Saturday, you're still gonna compare what's been changed up to Saturday to Sunday. So you have all the changes from Sunday up to Saturday. So your backup on Saturday gonna be the largest one of the differential backups, because you compare with your milestone that's on Sunday, right? So on Postgres, all those processes, they do a physical backup, because the backups, they can be categorized in logical and physical ones. You can do a logical backup on Postgres. For example, you can use pgDump to do a logical copy of the database. But here, for the purpose of this talk, we're always talking about physical backups. All the backups you're going to do here are going to be physical backups, right? Okay, so, and now we know what is backup and what is high availability. So a high availability is the ability to always be working no matter what happens. So if you have a disaster, you have the ability to keep working. Let's say you have a cluster of database with 3 nodes. So if you lose a primary node, you still have the other 2 nodes. Your application is still working, right? So you are high available in this situation. You can lose 1 or 2 or up to X number of nodes. Depending on your cluster, your application is still available. Your database is still available. This is high availability. And what does it do with backups? What are the differences with backups? Do we need backups if we have a cluster, for example, if we're high available? A lot of people, they think they do not need a backup because, well, we have replicas. You have different clusters. I can always replicate my data from a cluster to another cluster, or from the primary to the replica. But then what happens if we have a bug on the application that just drops a table? So that drop table will be replicated, right? So, and we are still available. We are highly available, but the problem is now we are highly available missing 1 table. It's not good. It's not a good scenario to happen, right? So high availability in the sense of having any extra nodes, they do not help on those cases. We still need a backup, right? And the thing is, those are part of what we call a disaster recovery plan. So we need to have a disaster recovery plan to be able to recover from those problems. Not being highly available doesn't solve all the problems. It doesn't mean that we cannot have a certain type of disaster that will be propagated for the other nodes, right? And that's are the things. When you have a disaster recovery plan, you need to account for those situations. We need to be prepared to be highly highly available. If the cluster, we know we lose one of the nodes in the cluster, if we lose the whole cluster. So this needs to be in our disaster recovery plan. We also need to be prepared if a problem happens, if a disaster on the data happens, if an inconsistency on the database happens, or if we lose a table or the whole database in a drop table or drop database situations, right? We need to be prepared. And those, they come into consideration of the disaster recovery plan, right? And this is when the backup that takes place. So even if you have a highly available cluster and with multiple nodes and many different regions and different countries and different data centers, so if something happens that you have an inconsistency of your data and you need to recover that data from that it was there before, this is when you need a backup. That's when the backup comes to place. So because that inconsistency may be propagated to all the nodes that you have in your cluster, right? And this on the disaster recovery plan is what we call the recovery point objective. Right? So if I have this type of problem, if I lose data, what is the max amount of time that I need to spend to recover that data back? And what is the minimal time that I can recover that data back? For example, let's say I can afford to lose 1 hour of the data. So if I have a problem, if I have a drop table, and if that drop table happened in between and 1 hour before, I can recover that data. So this is an RPO of 1 hour, right? So, and to achieve this RPO, I can, for example, take backups every 1 hour. For example, I can take incremental backups every 1 hour. But what happens if I cannot lose that much? What happens if I can lose, like, for example, 1 minute data? I need to take backups every 1 minute. It's not affordable. It's not doable. What happens if I cannot lose any second of data, or if I need to keep the max data that's possible? I cannot afford to take 1 second backup of 1 second, right? That would be quite expensive. And for those situations is when it comes handy what we call point-in-time recovery. So the point-in-time recovery is the ability to go back in time and recover to the database up to that moment when the database was stable, the data was consistent, and you just specify that moment, right? And as I was saying, like, if you have 1 hour RPO, or if we have 1 minute RPO, we cannot afford, sometimes we cannot afford to take backups every 1 hour, every 1 minute. We need to have something that is more efficient. We need to have something that helps us to be more effective when keeping the data. And in Postgres, also in other database, but we're talking about Postgres. In Postgres, we do have a mechanism that keeps saving all the transactions, everything that happens on the database, to a log file. And this log file is what we call the wall log files. This is the write-ahead log. So everything that we do on the database, every transaction that we do on Postgres, every time that we write, when we do insert and edit and delete a drop table or create table, whatever we do inside of the database that writes to the database, it's being sent to the write-ahead log. So what if we can have a backup? Let's say we have the backup, as I said yesterday, at midnight, and they keep all those WAL files. And if something happens today at 7 p.m., let's say I drop a table at 7 p.m., and then I restore the backup and have a way to force the database to process again all those WAL files up to the moment before I have that drop table. So I can recover everything, and I can somehow skip that drop table, right? That's ingenious. And this is exactly what the point-in-time recovery does. So we recover a base backup, a backup from a moment in time that we know that the data we need is still there. We identify when the problem happened, when the inconsistency, when the drop table, whatever problem happened to our database. And then you tell the database, you tell Postgres, look, I want you to recover from the WAL files. I want you to read the WAL files and process all the transactions until this point in time. When you get to this point here, I want you to stop because, well, I want to get my data back. And this is exactly what is a point-in-time recovery. And this is what we're going to do today, right? So the point-in-time recovery allows us to recover the data up to a certain point in time when the data that we need is still there, right? So, and in Postgres, we do use a base backup. We use a physical base backup to recover the database, and then the WAL files to force the database to read all of those files, right? Okay, but like, how does it work? Well, this is the time when things start getting interesting, right? Now we gonna play and try to understand and simulate how those things work. Okay, here I have my database. In this database, I have one table that at this moment has 10,000 rows. Let me show you here. We have 10,000 rows. See, we have this table T1, and this table has 10,000 rows. I'm archiving this to those files, the WAL files. Remember I said I'm archiving here. Here you have the archive command, and the archive command is using this shell script here. Let's see what this shell script does. The shell script is archiving everything inside of this folder, data pgSQL archive 14. So if we check this folder, we'll see that we have two WAL files here. Oh, right? So before do anything, what I'm gonna do here, I'm gonna do a backup. I'm gonna use my pgBase backup, and I'm gonna do a backup here. So this is very simple command. You can find all the parameters on the configuration files. So I'm not going through all of them here, but the most important here is the data dir. So this is where I'm sending my backup, right? So you connect to the database, I'm sending the backup here. It can do a backup with a database that is remote. You can do a remote backup for a database. If you do so, you need to specify the connection string, a user, and thing. And here, because I'm not using any user and I'm doing the local host, I'm not specifying anything. I don't want to compress the backup. I could have the option here to compress the backup. You use a tar file. I don't want, because if we do that, I need to uncompress, and we don't want to waste this time here, because that's not the purpose. And I want the backup to start as fast as possible. So pgBase backup will wait for Postgres to do a checkpoint, and you will not start the backup until it has a checkpoint. And with this option here, it will try to force Postgres to do a checkpoint, right? Be careful with this option. If you have a lot of transactions in your database, you might make your database to do a lot of I/O here, because it will try to force to do a checkpoint. Those for now are the important ones. The -v is verbose. And okay, that's gonna run here. And at this point, we should have a backup in this folder. Yeah, we do have a backup in this folder here, right? And what I'm gonna do here, I'm gonna insert few thousand rows on my database. Here my table has 13 rows, now it has 15. I'm just simulating some sort of application working here and inserting incrementally. And if you see here, we have a timestamp, right? And we'll see that this timestamp is going to be important for the purpose of our exercise here. So 19,000, and here we get to 21,000 rows. So we have 21,000 rows in this table at this timestamp here, right? And I'm playing along my database and do something, and I just run a drop table. My goodness, I just run a drop table here. I just realized it now that was not supposed to run this drop table here. right? And what now? What can I do now? That's pretty bad. It's pretty catastrophic, right? So first thing I need to do, okay, let me check if my table is still there. I want to check if my table is still there. Well, it's not there. It's not here. The table doesn't exist. We see in the error log. By the way, this is the log file of Postgres. The table is not there. So I'm gonna stop my database. So first things first, I'm gonna stop my database, and I'm gonna copy this data here because I'm going to recover a backup and I'm going to do a point-in-time recover. I still want to have a copy of this database, even it's compromised, right? Because if something goes badly, I still have a copy of this database that was working. It was compromised, I'm missing data, but I still have a copy of this database. So I'm gonna move, it's 14 to, I'm gonna call it here PITR 14, right? So that's what I'm gonna call, my database. Also, what I'm gonna do is I'm gonna make a copy of my archives because I can do a mistake and I can compromise my archive, right? That would also be bad. So I'm gonna do a CP, and my archive is on data pgSQL archive 14. So I'm gonna do this here and I'm gonna do the same. I'm gonna call it PITR archive. So this is cp-r. So I'm gonna have now I have a copy of my archive files, right? So if I do something bad, if I mess up with the recovery process here, I still have my point-in-time recovery. And I'm gonna mess up here because, well, I want to show you that we still have the backup files, right? So my backup files is, let me do cp-r here. It is on backup 14. So, and I'm gonna copy it here. So now I have my database. I need to change ch mode 700 this folder, or else it won't start. And here we have one file that the database is gonna complain. We'll see. So yeah, this postmaster file. So it doesn't have here, but we have it on our backup folder, right? So our backup folder is cp-PITR. This file we want to just copy on into 14. Now we can restart our database. I'm gonna stop here this log because this is a load file, and actually I'm going to restart my database. Yeah, restart the database. So the database restarted here. If I go here and do a select, what do I have? What am I have here? I have the original 10,000, right? So at least I know my backup works. But at this point, I might have messed up with my archive files because, well, I didn't change their archive configuration, and here my database is archiving. In C, it's tried to archive files, and some of those files they're there, and some of those files they just been rewritten from the process here. If I didn't do the backup of the archive files before starting here, we would have a problem. We would not be able to do a point-in-time recovery. So let me stop here. I'm gonna stop this process here. Right, gonna shut down. I'm gonna remove the 14. I'm gonna also remove the backup archive, not backup, the archive 14. This is the one we're using. So, and I'm gonna cp the archive 14. Actually, it's PITR 14 to archive 14, right? And this is a-r. So we have our archive back, and I'm gonna also copy our data back, our backup back, right? So cp it should be backup 14 here, and the postmaster, and ch mode. Okay, so we have almost everything. Now we need two things. The first thing, we need to tell the database up to when we want to recover. And to do so, we put on the file name PostgreSQL.auto.conf. I already have this here. Actually it's 14 to 14. I'm gonna copy inside of my database. And I also need to signal to tell the database I want to recover, and to do so, I need to create a file that's named recovery.signal inside of the data, right? So, but this file here, it doesn't reflect all the information that I have. Remember those timestamps that I said they would be important for us? We're going to use them here because I need to tell the database what is our recovery target. So we can tell the recovery target as a timestamp, we can tell us LSN, and we can tell what is the transaction ID up to we want to recover. I have the timestamp, so I'm going to work with the timestamp. And here, I know that at this timestamp, my database was consistent. This table, that's one that I want to recover, was consistent at this timestamp here. And I know that at this timestamp was when the drop happened. So if I recover my database from whatever time between this timestamp and this timestamp, I'll be good, right? So I'll just copy this timestamp here, or just copy this one here, doesn't matter. I will copy this timestamp. I'm gonna tell what is the timestamp here. Oops, I didn't copy properly. So let me copy the timestamp, let me paste the timestamp. And the difference here, I have few seconds. This is timestamp was 55 and 2 seconds, and this is 55, 14 seconds. So what I'm gonna do, so I know that whatever in between, I'll be safe. So then I'm gonna do, just to be safe, 10 seconds here. So I will ask the database recover up to this point. I don't want to include this point, right? Because I know that at this point, it was the data, it was there. I don't have to be this point. So this target, I don't want to be inclusive. It might be, there's some situation that you want to include even the target time. But here, I don't want to. And after the database finishes, I want the database to restart the database. Because I want to copy that data and recover and do whatever I want to do with that data, right? So I want the database. Or else we can use a target action to pause. So if the database pauses, we cannot connect, cannot do anything. Or we will just want to shut down. So we want to recover that data and copy it to somewhere else. So it depends what you want to do. At this point, I want the database to start, and I want to connect the database and make sure my data is there. So I want here to tail my log file, right? So this is my log file. And what I need to do here, I need to restart my database. And let's hope it will work. And here is what we get. See, it's restored from the backup files. And it's saying that it was reading from our WAL files. See, it restored from this WAL file 03, from WAL file 04, and WAL file ending with 05. So it restored. So theoretically now we are good, and the database is online and it's accepting connections. So if I do a select now, I get my 20,000 rows back. So I was able to get my rows back with this process. But see, this is a complicated process, right? This process is not as easy, and there are a lot of things that can go bad. So in this process, and to make things better, so what we can do is we can use an automation tool, a tool like pgBackRest, right? So how does it help us? So first of all, what is pgBackRest? pgBackRest it's a Postgres backup tool. So it's intended to be scalable, reliable, easy to use, and to be extendable. So, and it has a lot of nice features, like it can do backups in parallel, it can do local and remote backups. So it can do full backups, it can do incremental backups, it can do differential backups. And it can also do rotation of backups and rotation of archives. It can do expiration, so it has a lot of nice features. It can help to control a lot of nice things. So it's really nice to have pgBackRest. So we are not here to explain how that works, to explain how we installed pgBackRest. We're here to see how we can use pgBackRest to do a point-in-time recovery. Right, so I do have a pgBackRest here, so it's running, and what I'm gonna do here is I'm gonna go back to our terminal, right? So this is our terminal, and I'm gonna stop my database and I'm gonna rebuild this database, and instead of use that manual process, I'm gonna use pgBackRest. I have a nice script here, beam test init cluster. So this script here, we just drop the database, rebuild the database, and we're gonna have our database with everything is empty, right? So we don't have the backup, we don't have anything anymore here. For example, if I check my backup 14, we see it's empty. So it's an empty folder, and this database, it comes back to our 10,000 rows. So it's just restart to the original point where we started with our other example. So, but what I want to do here is, before we start, remember we have 10,000 rows, we're gonna do the same, but before I start here, I'm gonna do a full backup, but now using pgBackRest. So it's just this simple command here. If everything works fine, it will do the full-time backup, it will check the archives, it will do everything. It will check, and you see it's ended successfully. Now I have a full-time backup. I didn't do anything, I still have my 10,000 rows. So, but now I have my full backup, right? So, and I'm gonna do again all those inserts. So I'm gonna do them faster here, so because or else you're gonna start running out of time, right? So I have 19,000 rows on my database, right? So if I do a select here, let's see how many rows we have. At this point we have 19,000 rows. So, and we know that at this point here we're very good, we're safe. And again, I'm just working, and then I drew a drop table file. My goodness. Again, I'm sorry, let me put the log files here. So as you see, the log files here we didn't do much. And if I try to do a select, we're gonna see that the table doesn't exist. I dropped the table, right? So that's pretty bad. Not nice, not good. And now I don't even have my base backup anymore, right? So what we do, again, we stop the database, right? I'm gonna make a copy of this folder. Actually, I'm gonna move this folder. I'm gonna do a copy of this folder because for pgBackRest, I want to keep this folder. So I'm gonna do a copy of this folder, and I'm gonna call backrest 14, right? So okay, yeah, I want to, okay, I want to copy the folder 14 to backrest 14. Now we have a copy of this folder here. If we mess up with things, we still have this folder, right? So what we want to do now, Now we want to recover the database and we want to use the pgBackRest. So I'm gonna tell the pgBackRest to do check. I have this stanza, that one that we're using, the PITR. So, and I want it to use the delta, and I have a target, right? So, and my target here, let me just copy here. My target here is, remember the time that the database was saved. So if I check here, at this point, my database was saved. I still have my 19,000 rows, right? So this is my target. I want to recover to this point in time, right? So, and the action that I want to do after recover is to promote. Remember the action that we had on the recovery.conf? Yeah, we're just telling the pgBackRest the same thing. And I want it to restore. It's not a backup. It's the type of this action here. It's a restore type, right? So I run it here. I hope everything goes well. See, we have some changes in our log files. We see things are moving. And what interesting enough is we can check on 14 that pgBackRest probably did the change for us. The PostgreSQL.alto.conf, look, the pgBackRest just did it for us. And it created the restore command, and the restore command is using the pgBackRest configuration that we have, is they using the stanza that they have here. And if I go here and start my database, oh, I don't have this postmaster. Okay, that's easy. So if I do my restart here, so our database is ready, and see, it's restored as well. And if we check here, if you do a select, now we have back our 19,000 rows. And if you see here, it was a lot easier doing the process with pgBackRest. It was a lot, we had the probability of error a lot less than if we are using the manually process. And that's the main idea. So it's to use an automation tool like pgBackRest to do things a lot faster and a lot easier, and to make those things less error prone. So we are avoiding problems, and we are still able to get back in time for when the problem happened, when I made a mistake and I dropped those tables. This is the point in time recovery, and this is how we use a tool like pgBackRest to make our operation a lot simpler and smoother, right? So, and yeah, that's what we have for today. I thank you a lot for our presentation. So here at Percona, we really love open source, really love open source, and we are hiring. We have a lot of open positions. We have open positions for Postgres. We have open positions for MySQL, for MongoDB. And if you love open source like we do, if you want to join an amazing team, then just give me a mail, send me a message, or just find us here on percona.com/careers. So you see all the open positions that we have there. And any questions? So if you have any questions, I'll be glad to answer here. And also, you can follow me on my LinkedIn, so you can see my LinkedIn here, and drop me a question on my email. So either way, you can drop me a question on LinkedIn or my email. So it would be glad to answer any questions. And thank you again, and have a great day.
Charly?
Yep. Yeah, definitely. Let's start here. Right, shall we?
Look at that. He just jumped right into it. He just, yeah. So I was going to say this. So we have 3 workloads today that we're going to look at. So Charly created a system that has a decidedly Charly-esque workload, which means that it's a box that's falling over and gonna fall over dead because it's old and decrepit and aged, as Charly says.
That's a bad thing.
And I've got 2 separate workloads that I'm going to throw at Charly as well.
Yeah. All right. So yeah, before I go with your workload that I have no idea, haven't seen, that's a good thing. So because, well, it's usually how we do it per Percona, right? So we have customers, they have a problem in their workload, open a ticket, and then sometimes we need just to jump in to help them without no background. So that's your workload. Well, my workload, even though I have some background here, I'm doing not much on my workload. The only thing I'm doing here is a load test. I'm using pgBench. Really simple stuff. I'm gonna show you the command in a fill, but there's nothing special here. So as we can see from this result, I'm getting around 1,800, sometimes 2,000 transactions per second, right? So nothing impressive. And the customer, the user wants to know why our database is behaving so slowly. This is not a super hardware, I should say, but if we take a look, let's take a look on the specs of my hardware here. We have 8 CPUs, we have 32 gigabytes RAM memory, and we have 512 gigabytes disk. So it's a decent box, let's say, that could do a lot better than 1,500 transactions per second, right? So, and then my customer is asking why it's so slow, it's behaving so slow. So we need to go here and start investigating what problems we might have. So we have many different approaches. The one that we're going to use here is not the only one that we can use. And sometimes you can also find a different approach that works better for you. So this is fine, right? But one thing that we need to keep in mind is whatever approach we use, we need to be methodic, right? We need to use a method and go through that method. So, and this is what we're trying to go here. So then when I do start to investigate, usually there are 3 things, sometimes 4, that I go first. So first things, it's CPU usage. So I usually take a look on my CPU, on the CPU to see how it's being used. Well, the CPU is under 75% utilization here. There are some extra information I'm not going through it now, but like just CPU wise, not that bad. It says 75% utilization here, right? So if I go for my disk utilization, well, let's see memory because we're right here. So memory is not bad. So we hear used memory, like really used memory is like just this small portion in yellow here. We still have a lot of free memory that we can use. If we take a look on the swap, we almost didn't use any swap. We see some swap activity here and there, which is usually not good. We don't want to see those activities, but like, it doesn't seem to be the problem, especially because, well, the server is behaving badly for a long time. It's not only those period of times here. I/O, well, it's not that bad. It's getting some I/O, but it's a database, right? It should read and write, so it's writing like reading more than writing on my database here. So, and the disk load here, it's we have some late load here, but like the write load, it shouldn't be that bad. So what do you would you say, Matt, from what we see here? What do you have a hint for what is the problem? Where we should go just for those basic information here?
Well,
What
so if
would
you're
you
not
say?
using a lot of memory, you're probably have things that are, yeah. And you were seeing some disk I/O there.
Yeah, we do have some disk I/O here.
So we're probably looking at some of the memory settings, you know, and so that's where, you know, you're probably don't have enough being put into memory, reading too much from disk.
Okay, so if we go for memory settings on Postgres, we're talking about which do you have on top of your mind which configuration we go for memory setting? If you don't have, it's fine. Like even I sometimes don't have.
Yeah, like you're talking like shared buffers. You're talking a couple others.
Okay. Yeah, let's take a look on the shared buffers.
By the way,
so I just
the only
changed
one
it.
who asks me questions and tries to quiz me during live streams, just so everyone's aware. like everyone else is just like, you know, let me show you what to do, and I'm off, you know, like getting people on and answering questions behind the scenes, and then Charlie starts throwing me like questions, and I'm like, what? I need to pay attention.
Yeah, please. You know, we need to keep it interactive. You know, otherwise people are gonna sleep out there. We don't want people sleeping, right? So at least someone should be under pressure. This is how we.
So okay. So
Yeah.
now I'm going to go invite other people so they can be under pressure, not me.
Well, you are free to ask for help. Why not? Right?
So who wants to come help me out, live stream wise, while I'm here trying to do this? But anyways, go on, Charlie. Let's continue on.
You said shared buffers, right? So let's take a look on the shared buffers. We have here 8 GB for shared buffer, which is not bad, right? Like recommendations for Postgres is not used too much. I have 32 GB of RAM for the OS. So if we have 8 GB shared buffers, let's say the OS uses 2 GB. So we are left with 15, 14 GB for the kernel cache, right? The OS cache that's supposedly to help us with I/O, right? Yep. So I would say this value is not bad. Like for this box should be fine. What else could you take a look? Well, if you want to look at anything here, so I just changed it from one dashboard. This dashboard is of the OS perspective, and this is the Postgres dashboard. Right? So just to make sure we're on the same page. So this is the Postgres dashboard. Okay.
So one of the other things is you've got a lot of connections, right? So each of the connections is going to consume quite a bit of memory.
Okay. Yeah, that's a good point. We got a lot of connections. We didn't take a look of how many connections you have, right? So, and yeah, as you mentioned here, we are over, I would say, 500 connections. Right, that's quite a lot for this box.
That is.
Right, so and it may say something. So we already identified one problem. We have too many connections for this box, right?
Absolutely. So there should be some connection pooling or something there to limit those.
Indeed. And we're gonna try with the connection pooling later. Before we do any change, we're gonna just switch from direct connections to the connection pool to see if we get any improvement, right? Just like without changing any configuration, I'm just gonna stop my load and point to a connection pool because I have here a connection, I have a PG bouncer there, like just minimize the configuration, listening on the port 6532. So we're gonna jump and see if it changes anything. But before we do that, let's keep the investigation. Okay, yeah, we do have too many connections for this instance. We have like over 500 connections here. And if we take a look here on the activity itself, it doesn't look to have too many things doing because something is really putting my server on its knees, right? And let's go back to the OS.
Yeah,
please.
It looks like you're doing quite a bit of checkpointing as well. So I'm cheating and looking at graphs in the background. You've got some pretty big spikes that are happening on a regular, regular basis. Look at that big checkpoint stats, but
it does.
Yeah,
yeah, it does. And from time to time, also we just flush a lot of buffers, like it's expected because of checkpoints, right? So you can ask whatever information for us to take a look here. It's fine. We are investigating, right? So, and sometimes I myself just miss one point or another. So other couple of eyes, they definitely can account. Okay, we have two things: too many connections, and we have a lot of checkpoints. Checkpoints are bad. Well, they're not bad per se, but like when we're there too often, they're bad because they bring problem with IOs, right?
Mm-hmm.
And okay, one thing that I want to show you here, remember that I said there are some hidden information on the CPU dashboard, CPU graph here. See this red stuff?
Yeah, IO weight.
The huge red one. Yeah, this is the IO weight. And this is pretty bad. So what is the IO weight thing on this graph? What is it is telling me here? Can you explain to us in one short sentence?
That's basically you are waiting for IO to complete before you can use the CPU.
That's perfect. So the IO weight is the
way in which you said that almost was like it wasn't perfect.
That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Greetings and welcome to Percona Community Live 2022. My name is Wayne Lutweiler, and today I'm going to talk to you about installing Percona Server version 8 on a Raspberry Pi 4 or a 3B Plus. A little bit about myself. My name is Wayne Lutweiler. I am from Columbus, Ohio. I live here with my wife and my daughter. I've been a technologist my entire career, going back as far as being a certified Novell network administrator long ago. I've been a hobbyist lover of MySQL since version 3. I've been at my current job about 26 years, and I'm happy to say that the last several years I've been completely 100% focused on MySQL and making MySQL better and doing more with MySQL. In my opinion, it is the best open source database platform available, and I love it. And then shameless plug, but I do love Percona's version, and it is the version that I use primarily for anything I do MySQL related when I'm working with it from a hobby point of view. I use it pretty much anywhere I can. I like it that well. So it worked well with my whole goal here of bringing together, MySQL, Percona Server, and the Raspberry Pi. So my journey started back when I got a Raspberry Pi 3. It was in the winter, I want to say 2016. I got it, and it was incredible. I got hooked immediately on the GPIO and being able to control hardware with the software, and hardware that could initiate software to do things within the Raspberry Pi. My entire life I've been enamored with the weather, and the Raspberry Pi and the GPIO and all the additional sensors you could buy for it really led me to go, can I make something that I can track weather with? And in the beginning, it wasn't so much track the weather, it was just so much, I want a thermometer that's outside that'll tell me what the temperature is. And I want to see that via Python script or via web page. So that's how I started. I went down that route. I built, the circuits to create the temperatures sensors, barometric pressure sensors, wired them, programmed them in Python, set them up, wrote their output so that it could be read by PHP and displayed into HTML. Life was great. And I ran that for a few weeks, and I'm like, I'm a DBA. I really would like to have this data captured so that I could use it historically, so I could track trends, so I could maybe even do a little bit of weather prediction and, watching the humidity and the barometric pressure and other things. So I decided I wanted to put MySQL on the Raspberry Pi. Well, I didn't like the flavors that were available, because I think the flavor that was available was 5.6 and 5.7 was out, and I wanted to use 5.7. So I did some digging, I did some research, and I learned to compile and install 5.7 on a Raspberry Pi running Jessie back in the day. And from 2016 till about about March of this year, That's where I ran my database on a 5.7 running Jesse, and it ran fine for years. Never had an issue with it. Never had any lockups. Never had any crashes. Never any data loss. It just plugged away like a little choo-choo train that could. But the ultimate goal was to get to 8.0, and as most of us know, as we waited for 8.0 to really come out, we were waiting for the right versions. And I was really waiting for version 8.0.26 before I did anything here at home. But that also depended upon the Raspberry Pi Foundation releasing a true 64-bit version of the Raspbian OS. They had been talking about it through most of 2021. There were betas out in 2021. I didn't take advantage of those because sometimes, you just don't want to play with betas, and I didn't want to play with betas. But when they did make the release of Bullseye with a 64-bit version, I immediately took the Raspberry Pi 4 that I had, slapped a new SD card in it, put Bullseye on it 64-bit, and then I started my prep work on what I needed to do. So that's where my challenge came in, is that now I had all the pieces that I really had wanted back in 2016, but now I had them all. And now it was time to put those pieces together. So, I really started with the same process that I used in 2016 when I put Percona Server 5.7 on the Raspberry Pi. I started with the same process. Of course, I hit some roadblocks, and those roadblocks were just packages, finding the correct packages, making sure you installed the correct packages. But once I was able to get past that, I was able to achieve the goal of keeping the data that I wanted now in 8.0 instead of 5.7. And I still kept, my love of the Raspberry Pi and Percona Server. I still kept that. So I was still as happy as I could be. So I trial and error, did a lot of work to get this to work so that I could get it working here at home. And then the next step was to share my work. And I wrote a blog post back in April, and we're going to refer to that blog post for a little bit. I wrote the blog post back in April on how to install, Percona 8 on a Raspberry Pi 4. During the prep for this presentation, I decided to go ahead and see if I could put the 64-bit Bullseye on a Raspberry Pi 3B Plus, and then build and install Percona Server 8 on our 3B Plus. And I was able to. And really, the reason for doing that is the global shortage on chips are making things so expensive that Raspberry Pi 4s are approaching like $289 for a 4 gig model. But the Raspberry Pi 3 Pluses, they're still staying in a reasonable price range. So I wanted to be able to provide two different types of machines that just could be done on. So during the making of this presentation and preparing for this presentation, I did make sure that I could do it on a 3B Plus, and I wanted to make sure that was presented here as well. So as we go look at this blog post of mine, we're gonna pay close attention right now to needed packages, a creation of a larger swap file, making sure that we install Boost 1.73, build tips so that your build will be successful. And then once your build is done, the installation of the binaries. So we're going to just jump into the blog post real quick. You know, I've done the hardware recommendations here, so I think we're pretty clear on that. As for your SD card, don't go less than 128 gigabytes. Go higher if you can, but don't go less than 128, especially if you intend on using this as a database that you could put, you know, a lot of data into. I say a lot of data, but you know, I've collected my weather data over the last 6 years, and it's really not a lot of data, but you see where I'm going. Give yourself space to grow. I won't cover installing Raspbian Bullseye. There are many, many good places to do that. This link here on my blog post is a very good place to walk you through it step by step if you need that assistance. So one of the keys to making your build successful is the creation of a swap file. I found that the 4 gig swap file was the sweet spot. It worked very well. I did a little testing with smaller ones, with bigger ones, and 4 worked out really well. So that's why I went with 4. So, you know, you really, the steps are simple. Create it, make it, turn it on, adjust the privileges. And when you do that, you know, if you go look at your box where you have put that on, I think I have one right here that I can show us. If I type free here, and this is a 3B plus, you'll see that it has that 4 gig swap file. And then if we do an ls on root, you'll see that there the actual file is. So, you know, this has what it needs. So this is the 3B plus. MySQL is running on here. So let's go back to our web page. So once you have that, now you just need to do a couple quick housekeeping items. Run apt-get update, run apt-get upgrade. When those are complete, install your packages. Once your packages are installed, you're actually ready to start downloading the sources that we need to do the Percona install and the Percona Extra Backup install. So grab them. I personally grabbed all these and just put them in home/Pi. If you're not real familiar with the Raspberry Pi, you can just do a quick pwd, and home Pi is where you go when you log in. So I just, you know, I just downloaded everything into here and uncompressed it into here. So, you know, here's the source, here's the uncompressed, here's the source, here's the uncompressed, and here's boost and the uncompressed, vice versa. But you see my means. So I put everything here. And that's what kind of what we've done here. Pull it down, open it up, pull it down, open it up, and so forth. Now we're going to build it. And during this build, we're just going to cd into the directory structure that we created once we unzipped it. We're going to create a build directory. In my particular case, I called the build directory an ARM build. We're going to jump into the ARM build directory, and we're going to issue this CMake. And this CMake, we're going to build it as a build type as a release, telling it what version of boost to use, and then we're telling it where we want it to install. So I wanted it user local MySQL. So this is what we're doing here. A note about this build directory. In prior versions of make, you could do a make clean. So you could just pull some, you could pull some source code down, you could run a make, and if it didn't do what you wanted or you messed it up, you could run a make clean. In newer versions of make, you can't do that. So you're encouraged to create a build directory and then go into that build directory and do your work. And then that way, if you mess anything up or you want to change anything, you can work within that build directory. You can clean it out. You could create another one and run the command in another directory, but you can do, pretty much what you want at that point. So make clean doesn't exist anymore. So make sure you use a build directory. So I'm going to go ahead and take this command, and I'm going to show you what it looks like when we kick it off. So we're going to cd into here. And then I'm going to cd into arm. I don't know if this is clean. It is not. Let me clean it. All right, that's clean now. Just prove to you it's clean. So now I'm going to run this. So I'm going to have it prepare for the build. So I'm going to hit enter, and it's going to go out and it's going to go start looking for dependencies. It's going to go start looking for libraries. It's going to start looking for what it needs to build based on what we passed it. So that's what it's doing now. While it does that, we will just let it go, and we're going to come back here, and now we're going to talk about the make command. So the make command here, we're saying use 2 CPUs. So make -J2 says use 2 CPUs. I did a lot of trial and error finding out the best make command, and what I found is that combination of that 4 gig swap file that we created and using make -J2, you can get your build to run completely in about 3 hours on a Pi 4 and in about 8 hours on a Pi 3B plus. I don't recommend J3. It's inconsistent, and J4 will crash your Raspberry Pi every time you try to run it that way. So if you want a successful build without any headache, again, make sure you create that 4 gig swap file and run it with a J2. So now this is done. So the CMake is done. So now if we were going to, I could just run the make -J2 here, and it would start building all the necessary binaries and libraries. I'm not going to do that for this demo, but that would be the next step we would do here. And then when that was done, and like I said, it takes about 3 hours for that to finish, then we would use the make install, and the make install would do exactly that. It would install the binaries, the libraries, and other files into the location that we had defined. So if we go back to the terminal and we cd into user local MySQL, you can see that we have what we wanted. We've installed MySQL Percona Server version 8 on the server. No issues. We have everything we need. So now that we've installed it and we've copied the binaries where they need to be, let's go back to our PowerPoint presentation and let's look at next steps. So next steps is the setup. We have to do manual setup here because we didn't use a yum package and we didn't use an app package. We're doing this by hand. So we're going to want to make sure that, we create our MySQL user. I hate when I do that. We're going to need to create our MySQL user, define its home drive. And this is a service account. So keep that in mind. So you're going to create your MySQL user, define its home directory. You're going to create a directory for MySQL to do its logging. You're going to make sure that MySQL owns that directory. going to do a directory under user MySQL called temp. This is just something I do. You don't have to do this, but it's something I do. I create a temp directory to hold the temp files and temp table data. And then I create a data directory for where the databases actually are going to live. So this is just something I do. You don't have to do it that way. But throughout this entire presentation, it's going to rely on those places as you look at things. So, and here we're going ahead and we're just making sure that MySQL owns everything under user local MySQL. Once that is done, then we can move on to setting up our config file. So I've spelled out the config file here, and you can actually edit the etc myCNF with an editor of your choice. Make sure you sudo it when you edit it, and you're going to drop this information into it. Let's just go look at this on my server. So we'll just do a quick vi/etc my.cnf. And in here, you can see, where we have defined, some things you don't really have to put in. Port I could have left out, but this is just a template that I use. It does have some fine tuning in it. I wanted to point out to you that since this is running on a Raspberry Pi 3B Plus, the buffer pool size is 256 megabytes. It's smaller because this box only has 1 gig of RAM. I could set it to half the size of the RAM, which is what I typically do. But for this demonstration, I just left it at 256 megs. I wasn't too concerned about it. And then I created a 64 megs worth of log files to support it. So this is the the CNF file that we're going to use for this particular server. So let's get out of here. Once you've created your CNF file, the next thing we need to do is we need to create the service file. And the service file is what's going to stop and start MySQL when the OS goes up and down. So this is the file you need to edit, and this is what you need to put in it. But let's go and actually see it on the file system. So jump in here. So in here, here's our file. It's in its appropriate location, user lib system D system. And we have in here defined, our description, when it should start, after which other things being done, wanted by multi-user target. And that gives us the ability that if we change this to a server that boots to a command prompt, it'll still start. And then we define the service itself, the user, the group. This is important. If you change your install location, or you change where your etc myCNF file are, you would need to modify this to reflect your changes. And again, if you changed where you put MySQL, you would need to change this to reflect those changes. So we don't need to make any changes in this file, so we can go ahead and jump out, go back to our slideshow. And now we've got this done. And we need to go ahead and do the initialization of our database. And you're going to use this command here. You're going to say, hey, sudo mysqld initialize the database and initialize it as the MySQL user. Now, this is all you need to define here. You don't need to define the defaults file because the defaults file is in a default location that will be looked for. So we don't have to touch that. So you kick that off, you let it run. When it's done, you move on to the next step, which is setting up MySQL to stop and start with your OS. And that's what this command does. This command says, whoops, sorry, I did that again. I have to stop doing that. That's what this command is saying. Hey, enable it to stop and start with the OS. And then here, since we've initialized the database up here, we can go ahead and start MySQL now. So we can say sudo system control start MySQL service. When we do that, if we want, before we try to connect, before we look at the log files, if we want to verify that our service started correctly, we can just do a real simple system control. I have a misspell here. Status MySQL service unit. Oh, I'm so sorry. I didn't put the D in here. There we go. So MySQL is running. We have a loaded service. It's running. It's started where we told it to start from. It's using the default Etsy file that we told it. It's plugging away. It's ready for connections. So if we go back to our spreadsheet, our slideshow, you're going to have to get the password. There is a temporary password created for the root user when the initialization is done. So if you just cat the MySQL, the var log MySQL log file and grep on the word password, you're going to get a little bit of a, you'll get an output similar to this, and it's going to say temporary password is generated for root at localhost, and this is the password. Once you have that, I suggest you go ahead and use this connection string to connect to the database. Once you're connected to the database, you're not going to be able to do anything in that database until you alter the password. So you've got to alter that default password that was created. So alter that default password. As soon as that alter is done, I recommend that you immediately create a new privileged user. Create the user, give it the permissions it needs so that it can replace the root user. Log out, log back in with your new permissions user. Verify that you have everything the way you want, and then drop the root user. The root user, if you keep it around, it is a security hole you don't want. So it's a very easy security hole to plug. Just drop the user once you have your replacement user ready to go. So now, your MySQL is running. You have it running. You're running just fine on your server. Life is good. What we can do now, and it's much more fun to look at some of these things than it is to read a PowerPoint presentation. So let's just jump into var SQL. You can see that we've got, a really nice, clean MySQL log file. We just recently did I upgrade this guy? Yes, I did. You can see I just recently upgraded this one from 27 to 28. No issues with that upgrade either. I just, did the same procedures that I did for 20. Well, this had 27 on it already. I just ran the same procedures again, but I used the source code for 28, installed them, and then stopped and started MySQL, and it picked up the new version and did all the necessary changes so that it can be on 8.0.28. But as you saw here, no issues. Shut down, came right back up. Life is good. So we'll get out of here. We don't need to really be in that log file any longer. If we connect to MySQL, You can do -S here. You can see, you know, things that I like to point out is that it does tell us that it's running on the ARM architecture, 64-bit. It does tell you that this was a source distribution. This is database connection 12. I don't have any SSL in use at this time. If that was something you needed, you could add it later on. I just don't have it running right now. So, and as you can see, this has only been up about 6 hours since I did the upgrade. So that was about 6 hours ago that I upgraded it from 27 to 28. So we'll get out of here. And, you know, we've got another tool that we really need to look at. So we're going to go back to our blog post, and we're going to talk about extra backup. So I always include extra backup when I do a blog post like this. I like to keep Percona server and extra backup together on my server. So again, we all know that with version 8, with 8, you need to make sure that your backup version and your Percona version match. So we have 8.0.28 for our backup version. The build process, no different. You're just going to a different directory structure. So you're going to go into the backup directory, then you're going to go into the build directory after you've made it, and then you're going to issue the same command again. Really, the only difference is user local extra backup. It's really the only difference. That's just because we want to put the backup tools there. And I can let's go look and see that real quick so we can see and then we have our extra backup tools right in here. Jump into bin, and then there they are. So everything we need is right here. So once you've done this, then again, you're just going to do your make -J2. Don't change anything. And then sudo make install will just end you right here where we just looked. I want to show you guys that the backups run. So I'm going to jump into a directory that I have on this server. And this is the backup that I use nightly. It's just a quick little script. So I'm doing a quick streaming backup. And I'm actually backing this up to a USB drive that is connected to this server. We're not going to watch it run. But something I wanted to show that's really not in my presentation, but since this is the way that I'm going to use them going forward, I thought it was kind of nice to show. So I'm going to do a quick DF, and you'll notice that on this one, there's a data directory. So this is a 250 gigabyte SSD drive, just hanging off the USB port. And inside here, I didn't put the 0 on it. Inside here is where my data resides. So if I jump into this MySQL directory, do an ls here, jump into the data directory, here's where all my databases reside. I like using external SSD storage on my servers. This is just a preference that I had. I wanted to show you this so that you knew it was kind of an option. Hey, do I really want to put my database on the SD card, or do I want to put it someplace else? You can put it someplace else. You just make sure that you configure your myCNF file appropriately. So if we look at the myCNF file on this server, you'll actually see where I have the data directory defined and the temp directory defined. And the same goes for here and here. So again, this is something that I do after the fact. In my blog post, I wanted to keep it pretty cut and dry. and not go down too many extra roads, but take the time to show you here that you can go down those extra roads and you can spin some of this off and put it in different places. So we'll get out of here. Let's go see if this backup is done yet. So the backup is completed. So if we do quick ls of my backups disk, you'll see that we've got the backup from yesterday and the backup from today. There were older backups on here, but I cleaned this up so it was a little nicer to show everyone. Now we'll go back to the slideshow. And we did this. Now performance. So I ran Sysbench performance tests on the 3B plus and the 4. 4 tables, I'm sorry, 4 threads, 10 tables, a table size of 250,000 rows for 5 minutes. Let's just look at the queries per second. So we basically saw 583 queries per second on the Raspberry Pi 4. If we jump to the next slide, we have 402 queries per second on the Raspberry Pi 3B. There is not a significant difference between the 4 and the 3B. So, you know, in terms of where we are today with the chip shortage and you want to do this project, there's no reason you can't use a 3B. You're not going to see that big of a performance hit. It's just, and again, we're not looking for warp speed with this. We're just looking for data that we can collect and that we can report on at a later time. So we're not out for speed demons, we're out for data and a fun place to run it. And I think this is a fun place to run it. You know, let's look at a couple more things at the terminal level that I think is much more fun. So I talked to the weather station that I have, and I talked about some of the tools and things that I used when I started this. And Python was an integral part of this whole project from beginning to end. And if I just take and I cat, this is the barometric pressure file, I mean Python script. And you'll notice inside here that, I was right, 2016 is when I started this. So I wrote, you know, this simple code, defining the libraries that we need, pulling in libraries for the sensors. And then, you know, I defined the sensor, I defined the readings to get the barometric pressure, and then I defined the connections to the database. I can print this information to the screen, or I can create a cursor into the database, insert it, make sure it inserts. If it fails, roll it back, close it up, and then close the database connection and be done. So this gave me a start into Python. So again, another benefit of this was a start into Python. And then there's one more thing that I want to show you. So currently there's no PMM for the ARM architecture. PMM is coming. It's on the plate. I think it's ready to go. And I think we should see it shortly based on some of the talks that I had at Percona Live. Once we get PMM for the ARM architecture, then, you know, life kind of changes a whole lot for me, because then I can set up PMM and start watching my Raspberry Pi, my SQL servers with PMM. For now, I have a really simple little script that I wrote a long time ago. And, you know, again, really simple little Python script. communicates with the database. And, I can pull information out that I want, like the process list, and there's nothing going on this server because we didn't catch it at a time that data was being inserted. We can look at connection information, nice looking connection information, only for boarded clients. I know where those come from. I have a Arduino that connects to the MySQL database that's having issues, so I got to fix that. Let's hit the buffer pool. Buffer pool is always one worth looking at. So, my buffer pool, I'm taking 99% of my reads from my buffer pool, but of that buffer pool size, I'm only utilizing 2.56% of it. I won't make any changes to it just because it's the standard size setup, but you can see some of the buffer pool usage by schema, some of the buffer pool usage by tables as well. And then memory utilization is always worth showing. So this, I went to queries. So we'll just look at queries real quick. So query utilization on here is relatively, relatively low. It doesn't do a whole lot. It takes more writes than it does reads typically. You see more selects going on right now because I've been doing sysbench testing. Typically the selects are pretty low and the writes are much higher, but that's just the workload on this box, and it hasn't been up 2 days yet because I've been taking it down to prepare for the presentation. And then we can look at the memory usage, which is option 5. We see here that we're going to use about 2.41 gigabytes of total memory on this box. I've kind of shown some of the threads by maximum memory used, NODB information on how much memory the NODB is currently using, high watermark. So as you can see, it's not using much of that 2 gigs at all. And then down here, we can look at, that if a connection were to take all the memory it needed, it would probably take 17 megs per connection. Average is going to be about 8.5 megs per connection. So that's some of the stats on that particular database. Again, the performance between the 4 and the 3B plus is not insanely different. So if a 3B plus is something you can get your hands on today and you want to do this project, you won't have any issues. Especially, I did it for 6 years and had no issues, so you won't have any issues either, even running 8.0. So one of the things that I'd love to hear from those of you listening is, what other use cases do you see there where a Raspberry Pi running Percona server would be useful? I know I came up with 3 as I was putting this together. Collecting gardening data, collecting aquarium data, and then the one that really piqued my interest was this would make a great STEM mentoring project. You could really introduce someone into Linux, into compiling and building software, into package management, into database management. If you went as far as collecting data and writing it, you could get into the Python and show them how to connect and enter data into the Python, using Python to put the data into the MySQL database, table management, table creation. A lot of different avenues could be pursued if you use this as a STEM mentoring project. So those are just some of the ideas I have. If there's ideas that you have, please, I would love it if you threw them into the chat. Or if you would like to email me those, I can be reached at this email address. My GitHub is here. You can contact me via GitHub. That Python script that I use to play with the database is in this GitHub repo if you would like to look at that and play with that. And then you can also contact me on LinkedIn. I want to take a few moments to thank each and every one of you who came to watch the presentation. I hope you enjoyed it. I hope you got something out of it. I know I enjoyed creating it. I learned a few new things as I was creating it, and that's always great to learn something new. So again, thank you so much for your time. Thank you so much for coming. Enjoy the rest of your week and enjoy the rest of Percona Community Live. Thank you.
So those who are listening, I want to point out something, that there's an interesting debate here on percentage versus hard-coded numbers.
Can I give you my opinion?
Of course.
Use absolute numbers. Because if someone decided that max connections would be 50,000, 30% of 50,000, it's a lot of connections. It's 15,000 connections. That's going to be a lot. So, and it's still 30%. So ratios and percents are usually aligned. They usually lead to bad things. They usually result less than ideal stuff, in my opinion.
I'm going to wave my finger at you, because I think that there's a use for both, and let's debate this for a second, because this is
that's interesting.
So let me give you a couple scenarios where I see this. So there's pros and cons to either way. And when you look at a percentage threshold, let's use the user connections here. You're making an assumption here that you will know or be able to set a threshold that is universal across your nodes. What if you've got 100 machines and all of them have max connections that vary because some are busier than others, some are analytics, they have different workloads? A percentage in that case could be something that is beneficial, especially if you're really focused not on getting alerted that your system's busy, but you're going to hit a critical threshold that's going to, kill you, right? So, once you hit max threshold or max connections, things break. So you want to avoid that. So there is some benefit to saying like, I hit 90%, whether that 90% is 9 out of 10 or, 900 out of 100. Like there is a benefit, but there's almost like you need a secondary, because, when you hit 9 out of 10, one more connection kills you. When you hit 900 out of 100, you get 100 more. So really you probably wanted to set the threshold to 95 for that. But I would rather get alerted than not in cases where I've got a lot of massive systems and then adjust each one individually. So I see that there is a benefit for percentages, but they are when you're handling lots of nodes and you can't get control of all of them, and you are looking to that max that's going to kill you and push you over. I think that can be something useful.
Can I give you my opinion?
Of course you could give me your opinion.
How I will try to structure my alerting. Performance problems are related to hardware resources. And while sure, hardware resources nowadays could change. You could have hot plug memory and hot plug storage. But normally, you will have a fixed machine, especially for a database, right? So what I will do is I will label my nodes with the disk capacity, with the memory capacity, the number of CPUs. And then I will create alerts that are based on the hardware, because what you're going to saturate is the hardware. And then I will create filters to apply those alerts with the proper dimensioning to the proper hardware. My take. So might not work at too big of scales, but I believe that for vast majority of the people, I'm talking about people 500 nodes, 1,000 nodes, you can perfectly do this. You're not going to have 1,000 different nodes. Come on. So I think it's better because it's easy for some thresholds to be changed by humans. So if I tell you max connections 30%, and then I go sneak back in your back and said state global max connections equal 90,000, I just blew out your server. So that is the thing, is hardware resources are fixed and can be easily labeled when you are installing, could even be automated. So much so that could be automated that when you're deploying your PMM agents, you can add those labels to qualify what piece of hardware you have there. Automatically, you don't need to have a human do it. So you will get those labels for free, basically, and then you can use it in the filter. So I could say, okay, I want 30 connections for the 8 CPU cores machines, and I want 1,000 connections for the 144 cores machines. Does that make sense to you? Or what do you think about that?
Yeah, you could do that. I mean, I guess you could if you tag them. So what you're saying is tag the different size instances and then set the alert threshold for those different size instances. Because as the environments do grow, we're losing control over individual nodes, right? So if you've got a environment where developers are, let's say you're an RDS, right? So you're on Amazon and you're looking to monitor and you want to set up alerting thresholds, you might have 10 different development groups and they might have 50 different instance types. It's entirely possible. So, yeah, you can put, filters in there then that say like, hey, this sort of tag or this sort of, system. But I think you could also potentially do that in the template. Like, so if you go down and look at the Victoria, metrics there, you can make this expression, for instance, like say,
a piece of the CPU or a piece of the
yeah, or even hard code the value in here, so if you're going to use a percentage, like in this case, right? So a percentage, let's say you wanted 90%, you could say 90%, it's over 90% and has less than 100 connections left, or has less than or has more than a certain number of things, right? So you could say like in here, put an and statement and then say, take the max minus the max variable. So the maximum number of active connections minus the configuration variable, and say if that's over 100 and over 100 or under 100 and over 80%, then alert. So you can make it a little more intelligent by kind of mixing things in here as well.
Yeah, it's kind of a heuristic built into the template.
Because I mean,
never looking into it. To be honest, never looking into it.
Yeah.
But yeah, it sounds interesting. What is wrong is that, right? Like, it's like the rule of thumb of 75% memory for the buffer pool, and then I see people with 784 gigabytes of RAM using 75%, and they have like 180 gigabytes free, right? It's like, sir, you have a lot of memory free. You don't want to have all that memory wasted. It's a lot of money. And it was, I was following that percent rule.
Yeah. And I mean, like in that, like if you were going to do a memory, you would be saying like, what's the maximum that I want to allocate for the OS? And you'd say, maybe it's like 32 gigs. Once you hit 32 gigs, everything above 32 gigs could be to the database. And you could put that directly in your template expression as well. That says that, if the the memory is above a certain threshold, then just send this alert that you've got this free memory that's not being allocated, regardless if it's at the percentage or not.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Well, hi there, folks. I'm Robert Reeves, and welcome to my presentation. So happy to be invited to Percona Live Virtual. We're going to be talking about liquid-based data today, version control and collaboration for your database. Got to tell you, never thought I'd be saying those words, right? Version control and collaboration for a database. What's that all about? Well, before we get started, hi, I'm Robert. I'm CTO and co-founder of Liquibase. Liquibase is open source software that helps you migrate database changes throughout that app lifecycle, from dev to test to staging to production. We can help update that database alongside the application. I'm a big fan of comic books. So we're going to be having Q&A afterwards. And so happy to answer questions about liquid-based data. But if you would like my thoughts on anything dealing with comic books, you got any questions, let me know. You can find me on Twitter at Robert Reeves, GitHub, R2 Liquibase, and certainly via email, r2@liquibase.com. So let's go ahead and get started and talk about how we got into this need for versioning and collaboration with databases. And it all goes back to the dewy days of 1979. A lot of stuff was happening that year. Look, I got to tell you, this guy never put out a bad album, but for my money, this is the best. Really, really good. We also had, this new cinema, Kramer versus Kramer, a movie about divorce. Oh my goodness. Scandalous. Some of you might have had a Walkman. Some of you might remember this from Guardians of the Galaxy. That came out in '79. But also the first version of Oracle was released. And wow, look at those colors. That's something else. And so, prior to this, prior to a database, if you wanted to answer a simple question like, oh gosh, what are the top 10 customers that my company has in the greater tri-state area by revenue, you would have to get an enormous room, a bunch of files, maybe some chalkboards, and you would be wrong. It would take days and days and days to figure out that information. With the database, we can figure out in seconds, less than seconds. But not a lot has changed since then. I mean, really, let's think about this. I mean, Oracle ran on a VAX machine. It had tables, it had columns, rows, indices. You change that structure with a .sql file. You queried from a command line. I got to tell you, I don't see a lot of improvement. I mean, oh gosh, it's running in the cloud now. Well, great. It's running on somebody else's server somewhere else. The amount of advancements that we've seen on the application side of the house compared to what we've seen on the database side of the house, it's a big difference. And I think, as an industry, I think we should feel a little shame about that. I mean, let's think about this. We've got a whole host of people over in application development, continuous delivery, cloud native, Kubernetes. They're doing all sorts of great things. And progressive delivery with feature flags. That's amazing. It's increasing the rate of change for our application. It's increasing the number of changes, and it's increasing satisfaction to our customers. Where's that for the database? I mean, seriously, we've got a whole bunch of people on one side of the house that are really enjoying life, and then our database professionals, frankly, not so much. And I think it's time to change that. And so the folks at Liquibase, we looked at this and we said, hey, we could do better. We've got to figure out a better way. And along the way, we found out a way to improve that experience of versioning and collaborating with databases. And that's what liquid-based data is. At the end of the day, we're going to take a database and version not just the schema, which is what liquid-based does, but also the data itself. Wow, that's pretty cool. And also allow you to collaborate, to be able to share those changes with your team members. What we did was we modeled Git, the same workflow that developers are using today with Git, Git commit, Git push, Git pull, Git clone, these sorts of things. You can do the same thing with liquid-based data. And, you know, the reason why at the end of the day we decided to do that is because we saw that dev process for databases as arduous, tedious, overwhelming. We also believe that developers should be able to share changes with their database as easily as they share changes with their application code. So that sounds neat. How about we see it? So we're going to go ahead and have a demo here. And I am going to go to the handy dandy command line here, make sure that's up and running. But I wanted to show you this. We are obviously based on liquid-based here. And so I wanted to show you my liquid-based.properties file. Now for liquid-based users, for veterans, this is going to be familiar. You might notice that there is a new key value pair here. Repository. We are versioning, so we do have a repository in liquid-based data. But this lays out that we're using Postgres, username and password, and I prefer to use XML for my changelog with liquid-based. You can use YAML, JSON, formatted SQL, doesn't really matter, and personal preference. But, you know, let's go ahead and start this up. And liquid-based data requires Docker Desktop, and that's what it's going to be using to run the database. We leverage container technology to do this. And so if I go ahead and start my kind of baseline first version database here, you're going to notice this looks a lot like Docker. Liquid-based data run. This is the first and last time I'm going to be calling out the repository because I put it in my changelog. I'm sorry, my liquid-based.properties file. We have this environment variable that Postgres requires, or rather is really handy. And then we just say Postgres. Now I'm using Postgres today, but you can do this with any database that will run in Docker that has a volume mount for the data. That's it. Later, I'm going to show you some links to see Mongo, Oracle, SQL Server. I would very much like to be challenged to see if you could find a database that this does not work with. We would like to hear that. So let's go ahead and run this. And what this is going to do is two things. One, it's going to start the Postgres Docker container. But it's also going to create a repository. It's going to say, hey, okay, my repo is where we are going to store versions of this data. And so if we do liquid-based data ls, we can go ahead and see that we have one repository there, my repo. Okay, that's pretty cool. So let's go ahead and take a peek at this in a database ID. We're going to use dbeaver, but I want to show you that it is empty. It has, you know, it's going to have that new database smell. And here we go, schemas. Come on, there we go, tables. Nothing in tables. Okay. This would be a good time to do your first commit. So we'll go back to the command prompt, and I am going to, and if you're wondering why I keep looking to the left, that's where I have all my commands, make it a little bit easier. And so liquid-based data commit, first commit, yay, we did it. And now we can go ahead and just like with, you know, git log, we can do liquid-based data log. And we're going to see one commit there. Great, as expected. Now let's start making some changes to this database. Now, a lot of different ways of doing this, but I think the best way is with Liquibase. And so I'm going to use Liquibase. You know what? I'm just going to go ahead and copy the whole command here. And we'll move that up to the screen so you can see it. And we're going to do, we're going to generate a changelog. Instead of me having to write all of the XML, I'm going to have Liquibase do it for me. And so now I've got this changelog.xml file created. I'm going to open it up in Notepad. You can open it up in whatever you would like. And so we'll see that we just have database changelog there. It is an empty schema. And so what we're going to do now is add a change. Database changelog, nope. Much better. And luckily I have a changelog over here that I can copy and paste. Just simple, no big deal. We're just going to add a single table. Now, of course, if I had created this table in, using dbeaver or something like that, or created it manually, writing SQL myself, generate changelog would have picked it up. And so as you can see, just customer table, a few columns here, no big deal. 4. Now that that is saved, we can go over here and do Liquibase. Now, what Liquibase is going to do here is look at the changelog, look at the database, say, okay, there's one change set in this changelog. Well, it doesn't appear that it's over on the database. I'm going to run it. If you had 5 change sets and Liquibase looked at the database and said, oh, I only see 2 there, it will run 3. If it sees 5 and 5, it doesn't do anything. That's how Liquibase works. And so update was executed successfully. So let's look at dbeaver here. And I would expect to see some changes in tables. Yes, there is my customer table. And here are the 2 meta tables that Liquibase creates for us. This is how it keeps track of it. This is database changelog, keeps the history, and database changelog log makes sure that 2 people aren't using Liquibase at the same time. Great. Now that I've made my change, this is probably a good time to do another commit. And same thing as before. We have Liquibase data commit, we have a message, and there we go. And if I do Liquibase data log, it's going to show me 2 commits now, as expected. Now, what is the point of versioning if you can't go back to safety? So imagine I really messed up my database. Maybe I made a bunch of changes to it, but I didn't commit. Or if I did commit, that's fine. But I want to roll back. I want to get back to that last state. And so that's pretty easy. We would use, in Git, you would do git checkout and give it some information. Here, we're going to do Liquibase data checkout, and we're going to give it the first commit that we did. Remember, this was the empty schema. So if we go back to dbeaver, we're going to see that there are no tables there, right? I would hope so. We'll go over here. We'll hit refresh, and now they're gone. Wow. Okay. On second thought, maybe I did like that table. So if I want to go back, all I have to do, and I'll do, get this to the top of the screen so you can see a little bit better. We'll do Liquibase data log. And there is that commit that I want to get. And we'll delete the old one. We'll do the new one. So I'm rolling forward this time. And I would expect to see that I have my tables there. And there we go. Outstanding. So, you know, there's a lot of work that we put into this, and there is still more features and functionality available. So to get access to liquid-based data, go to our GitHub repository and you can download it there. There is a tutorial that will walk you through it. And certainly if you'd like to talk with us, if you have any problems, you could join us on Discord here at this link. And I'll be distributing this presentation as a PDF, so you can click on those links. And then we also have some demo videos here, certainly Postgres, one that I just did, but Oracle, SQL Server, MongoDB. And we also have, you know, showing off how we work with multiple developers. I mean, what would be the point of versioning if you could not share this with other folks? And so we show in this video how to do, using remotes with liquid-based data, how to share those data sets back and forth. Thank you very much. And let's go ahead and open it for questions.
Hello everyone, my name is Javier and I am here to talk to you about this past year development at PostgreSQL team. So, first introductory note, who am I? So, my name is Javier Jaramago Fernandez. I am a system engineer working at PostgreSQL. For more information, you can refer to my GitHub or GitLab pages. These days, for sure, you are going to find more information in GitLab. So, which one is the goal of this presentation? So my goal was to give you a brief overview of all the features that I considered were more exciting, either by their impact or because they offer interesting insight about PostgreSQL itself. Also, I wanted to be able to give you the most interesting, sparkling internal details that I can afford within the context of this talk and the time that we have. So without any further delay, let's just digging into the features. First one, the Prometheus exporter. This is a big feature that was introduced in PostgreSQL version 2.1.0. Since this version, PostgreSQL includes a built-in Prometheus exporter that currently exposes more than 180 metrics. These metrics are exposed through an HTTP endpoint to be collected by Prometheus, and then can be accessed by any other services for the presentation, as for example, Grafana. So, why Prometheus? This leads to some questions, and the first one being, why Prometheus? So Prometheus was chosen for several reasons. First of all, the simplicity of its format, the widespread adoption, and also the availability of third-party exporter libraries that we could shape to our needs. Also, it provided the kind of observability that we were looking for the metrics. This leads to the second question, the API design. Well, since we wanted this to be the primary source of metrics going on for PostgreSQL, we wanted to have a very solid API design for them. So there were two key aspects that we cared the most when we designed this API. There were simplicity and performance. For the first of them, for simplicity, we wanted the metric to be just able to be defined as simple in a couple of lines, and also being accessed in a uniform and reliable way through across the whole code base. Because of this, we took an approach of per module defined maps for the metrics. So what is that? This means that for each module, for each PostgreSQL module, it should contain the metrics definitions that are exposed from that module. These metrics definitions contained in these maps are then later used during the initialization of the module itself to create arrays that holds the metrics objects themselves, the Prometheus metrics objects. And then these metrics objects are the ones that are used to expose the metrics through the exporter. So this approach offers error-prone definition and access of the metrics, because defining it is just adding it to the map, and accessing them is just through the arrays defining the modules that has been already initialized. And also it's a very fast way of accessing the metrics objects themselves, because they are located inside the arrays that are located within the modules. But since in PostgreSQL we care about performance a lot, and we didn't want to spend any extra cost of PostgreSQL working threads time for the simple purpose of updating a metric, this approach comes with some downsides, which is that metrics objects for Prometheus exporters are usually atomic, and we didn't want to spend this extra cost for some metrics. So what we did is that we have internal per thread counters for certain metrics that we collect and then update the metrics objects themselves on demand when the endpoint is queried. So this design lets us scale in the number of metrics without worrying about performance at all, and also have the advantage of the simple definition and access that we were talking before. So this leads to a point that we want to address, which is the comparison between the exporter and the admin interface. So traditionally, all the metrics from PostgreSQL and also configuration, etc., are exposed through the admin interface, but it's important to take into account that the exporter is specifically designed for not introducing any locking or any extra work in the current proxy in the PostgreSQL working threads. While the arming interface is not designed with those design considerations in mind. Yes, we try to keep the arming interface as performant as possible and as reasonable, but that isn't the main goal of the arming interface. The main goal of the arming interface is to have a generic configuration tool for getting and accessing the PostgreSQL config. But if you need to access metrics about PostgreSQL in a tight loop or in short intervals, we really encourage you to use the Prometheus exported, because unlike the admin interface, it is specifically designed with this purpose and should meet all your requirements regarding PostgreSQL metrics gathering. So together with this feature, we packaged some template Grafana panels that you can check out in this repository. This should serve as an example of how to configure and how to use exported. But please don't take it as a source of truth. It's simply a useful resource to take into account when you are first approaching the exporter. Here are some of the Grafana panels that are supplied. One of them exposing several metrics about PostgreSQL and the other exposing metrics about the connection pool. And as a final note on exported, I wanted to add these very recent metrics additions, just to show that we have a commitment, a long-term commitment of keep adding more metrics to the exporter as we go on. So, for example, you can see the even recent cluster tables that has been introduced in our latest PostgreSQL release 2.4.0 are added as a Prometheus metrics. We will talk about those tables later. So this is we move from that, and now we have prepared statement results buffering. This is also a very interesting feature that was also added in PostgreSQL 2.1.0. And in a sense, it is that PostgreSQL is able to start sending to the client parts of the result set without the result set has been fully received from the backend. So this matches the previous behavior that we have for text protocols and makes the behavior of PostgreSQL homogeneous between the two protocols, and can be controlled via this configuration variable that determines the maximum result size the PostgreSQL will buffer before starting to send the result set to the backend. So this feature allows for PostgreSQL for a much more steady use of memory in PostgreSQL side, even for large queries, and no matter the size of the final result set. So as a conclusion, it's a really useful feature when you don't want to care at all about either the protocol version or the size of the result set that you are going to receive. PostgreSQL should just have a steady usage of memory. So now we're moving on to a couple of security-related features. First of them is SPIF authentication. Since PostgreSQL 2.1.1, SPIF authentication was added. Since the initial additions, we have improved support in all the subsequent releases of PostgreSQL to the latest 2.4.0. So briefly, you have there briefly defined what SPIF is. I am sure that many of you are already familiar with it. Is a secure production unity framework for everyone, set of open source standard for securely identifying software system in a dynamic and heterogeneous environment. Well, on PostgreSQL side, we are going to care about some minimal SPIF concepts. We are going to care about the SPIF ID, and we are going to care about the SVID. So, the SPIF ID is simply the URI for the workload that we are specifying. The SPIF SVID is the SPIF verifiable identity document, which is the document which a workload with a workload proves its identity to a resource or a caller. So it's a document used for a workload to prove its identity. It encodes the SPIF ID in a cryptographically verifiable document that by standard has two formats, which is the X509 certificate and a GWT token. In PostgreSQL, we just support the former. We support the X509 certificate. So, on PostgreSQL side, what do we need to care? On PostgreSQL side, the first thing we need to do is to configure the SPIF. For using this feature, we need to configure the SPIF ID user attribute. So for example, one like the one that we are seeing here. As a small note, since PostgreSQL version 2.4.0, we have added reject support for these SPIF IDs. So you can use an SPIF ID like the one that you are seeing there, which is an SPIF ID which starts with an exclamation point and then is later followed by the rejects, that could authenticate against several services as the one with the URIs listed there. So this was the first part. So as I recall, we have said that first we have configured our SPIF ID, as an user attribute is PostgreSQL, and now secondly, the client connection needs to supply the SVID, needs to supply X509 v3 certificate, which can be verified against PostgreSQL CA certificate, and which this supplied SVID needs to contain a SAM URI with the same ID as specified in the user attribute SPIF ID. So, I want to add a remark here. Note that even if this points to PostgreSQL performing a validation of the supply certificate against PostgreSQL cert, this doesn't mean that PostgreSQL supports MTLS. This check is just performed if the client connection supplies a certificate which holds a SAM URI, identifier which starts with SPIF. So in case that condition holds, PostgreSQL will perform that verification. Otherwise, it won't. So next security feature also include in version 2.0.0 was multiple TLS improvements. First of them being the client certificate reload. So this feature, in combination with the previous feature that PostgreSQL already has, which is the allow of backend certificate renewal, allows for a full certificate renewal without the necessity of restarting PostgreSQL. So, before, it was already possible to perform a backend certificate renewal using changing the variables that we see in the screen and then using the command load MySQL variables to runtime. And now, since the new feature is introduced, client certificates can also be reloaded by swapping the files that you can see listed there and using the command that you see listed there, which is PostgreSQL reload TLS. Please remember after doing this to check error log in case error log, PostgreSQL error log for verifying that the operation was successful and took place. Also, as a note, the certificates will be used for the new incoming connections. Okay, further TLS improvements. So, since version 2.0.0, other keys than RCA can also be used, which, for example, easy keys. Also, certificate revocation list and multiple certificates authorities can also be configured. And since the newest major release 2.4.0, TLS versions can now be explicitly specified, including the deprecated versions TLS version 1 and TLS version 1.1. In case you want to use this deprecated TLS version, PostgreSQL will issue a warning since we don't recommend their use. So, another security feature, the client error limit. Also seen in PostgreSQL version 2.0.0, a new feature client error limit was introduced. This feature controls the number of connection errors that can be initiated by a particular address before denying any further connections from another address, providing a protocol-aware DDoS protection mechanism. So this feature is controlled by the variables that you can see there. The first one determines the number of errors that any address is allowed to perform before getting banned for any future connections. And the second one is the size of the cache that determines the size of the cache being used for keeping tracks of the client addresses that have had any connection errors. Cache can be cleared by performing the command that you can see there, PostgreSQL flush MySQL client host. And then the feature also offers observability through these two stats table, which allows you to see the current status of the cache and also allows you to reset the table, as many other tables. Some technical insights about this. So cache is checked as soon as the connection is established. Why that? In order to keep the invalid connection time as light as we can, when this feature is enabled, the first check being performed when the connection is established is the cache status. If the client address is found in the cache, connection is denied and the socket is immediately closed without any need for processing authentication or session creation inside PostgreSQL. Now we move from these security features that introduced to multiple DGS improvements that PostgreSQL have been receiving since 2.1.0. The first one being better replacement for query digest. So now with the aim to produce more homogeneous GDS, you can see a number of different replacements that PostgreSQL now performs over digest that before it didn't. So you see decimal, floats, spaces, but also we introduced new grouping options like the one that you can see there. MySQL Query DS grouping limits allows you to compress any groups of values into the maximum number of values that you think you care about that query, thus allowing to compress heavily the size of the query digest that you are generating. Since for the latest PostgreSQL release 2.4.0, multiple corner cases were addressed, multiple bugs were solved, performance improvements were, as a consequence of the big refactor that we performed, multiple performance improvements were added, were introduced, and also we added a new grouping option. So we start with the new grouping option. If we talked before that we added a new grouping option for compacting groups, for collapsing groups of values, now we add a new grouping option that allows you to compress groups of values. So for example, if you have inserts like the one that you can see there, you can now compress the whole collection of values into a maximum groups of grouping, which allows for even bigger compression as the previous option. Also, in the latest release was a new option was introduced, which is query digest keeps comment, which allows you to entirely preserve a comment that was added to a comment from the query digest, which is very handy in scenarios in which, for example, you have an issue identifier that you are sending in the query and you want to separate the digest because of the digest is using the service identifiers that you are placing there in the command. Before you will see the identifier lost, and now you can preserve it. The performance improvements. Here are some insights about the refactor that we perform. So the previous parser, the tokenizer that we had, was a refactor from a single pass parser into multi-stage parsing. So the goal here that we have was to reduce the branching, because it was a very complex logic, to simplify the logic, to improve user control of parsing, adding more configuration options as the one you're seeing. Also because stages can be disabled themselves just by disabling the previous configuration options that we have seen, and also maximize the DGS buffer usage with the compression mechanism. Because as I thought of this compression that we now perform per stages allow us to fit even bigger digest in a small query buffer, as long as the digest the end digest holds in the supplied query buffer, the digest will fit in, unlike in the previous implementation. So all of these changes comes up with a 30% performance increase in several intense benchmarks that we performed. And now we move on from query digest to cluster changes. So we have added multiple improvements recently to cluster, including further table variable synchronization that it was added in PostgreSQL version 2.1.0, which are MySQL Valera host group, Pro Replication host group, MySQL Abdullah Aurora host group. Before you couldn't rely on clusters to synchronize all that for you, and now you can. The number of things that clusters now then syncs is very, very limited. Basically, all PostgreSQL relevant configurations should be synchronized by cluster. Version verification, this has to do with the previous feature. Via version verification, now cluster only can work with PostgreSQL with another PostgreSQL instances which are of the same version. This greatly simplifies the synchronization of all the values of all the possible configurations of PostgreSQL. SSL support for intercluster communication, and also, since the latest major release, improved intercluster synchronization resiliency. This was done by several means. First of them, for example, it was the avoiding invalid fetch through cluster nodes through epoch preservation, also verification of the pooled configuration from different servers matches the expected configuration, and also reporting of invalid sync states. Now we move to some features that came in 2.4.0, specifically about cluster, which these two features that you can see right now are closely related. And now cluster node has a configurable UUID. So this can be configured either by a configuration file, by supplying the command line, or letting it to be automatically generated. These UUIDs are used by the nodes to announce themselves when they connect to another cluster node. So when a cluster node performs a connection to another cluster node, it announces itself using the previously mentioned UUID. So this relates to the second feature that we see here listed, that core nodes are now aware of satellite nodes. So because the concept of cluster nodes and satellite nodes is a concept on how PostgreSQL is usually deployed, we are going to check this a little bit in a little deeper way. So Here we can see the typical topology in which a PostgreSQL cluster is deployed. You can see two layers of configuration, the one in the center being the core nodes and the outer layer being the satellite nodes. So the difference between the two layers is that PostgreSQL core nodes are considered the source of truth for the outer layer. This means that satellite nodes push configuration from PostgreSQL core nodes, but are not aware of other satellite nodes and don't pull configuration from them. While in contrast, the core nodes are all aware of all the other core nodes, meaning that they monitor each other for configuration changes. So, as you can see in this diagram, all the configuration is pulling from the inside layer to the outside layer. And the core nodes are the only one actually being monitored by other nodes, by themselves and by the outer layer. But, since we have talked before, cluster nodes are now aware of satellite nodes. How we and they identify them with the new introduced UID. But not only with the new introduced UID, because they also identify them by knowing the host name, the port, the admin interface, and the last time they saw this satellite node. So why all of this and how this all relates? So the motivation for having cluster node aware of satellite nodes is essentially having better extensibility of the cluster state. So with only a connection to a core node, now we can inspect or introspect the whole cluster state and provide an easy debug experience, because the cluster node is aware, the core node is aware of the other core nodes, as also is aware of all the other nodes that are pulling configuration for him. This is also very useful for monitoring tool creation, because of the previously stated facts. And also, this, as a proof of it, this will be used by our next web UI interface. As always, all the information is available through this table. There are also more tables that has been added through informing about cluster information, but I am not going to mention those. So there is another upcoming feature for cluster, very minor. I wanted to just to mention it because I find it really handy. It's the kind of thing that you think where you are developing, which is that we will have coming support for release and debug build compatibility in cluster. Right now we don't support it, but we will, and because we think that it will be a very handy feature for debugging. So I want to conclude talking about cluster, encouraging you to watch René's presentation about the topic from past FOSDEM, because he covered cluster in a much deeper way and presents you with nicer examples, with practices that we have observed about it, taking more time into the details that I have just done. So please, if you are interested, just watch out for that presentation. So we move from cluster and we move to client deprecate UF support. This is a big one. This is a big one because it's a protocol change. And it's a protocol change that was introduced in MySQL 5.7.5. Essentially, it's the deprecation of the EOF packets in favor of OK packets. So what is the motivation for a protocol change like this? So the motivation is that OK packets are extensible. Via that extensibility, you can use it for supporting things like client session track. As a real-world example of this, in Shopify, they were doing a very interesting use case of it by sending back performance metrics from inside the databases using this capability. So, what are the PostgreSQL side changes of this? Well, as PostgreSQL itself being a client and being a server, for MySQL, this offers a challenge on both sides of the proxy. First, and a very big a very big challenge was that the protocol wasn't supported by the connector that we use for the backend connections, which is libMariaDB client. As you can imagine, this as itself is a big deal, and supposedly the first step of the challenge. And as second and later stages of the challenge, multiple modules were affected by the change. As an example of them, especially supported commands, so the commands that we intercept and we need to reply, but some of them are required to be aware of the protocol change for performing for sending the correct result set. Also, query cache is affected, capability trackers, etc. The propagation of these changes represented also testing challenge, especially because at protocol level, different connectors do behave differently. It was a hard one, but we can say that PostgreSQL supports now clean deprecation UF. So very happy about that. So now we move on to some final compatibility improvement features. I wanted to add this because let me talk about some PostgreSQL insights. So the first one will be the added support for HA proxy MySQL health checks. This is an interesting one. So in short, there are some facts about that are important to remember to understand the issue. So first about PostgreSQL data flow check. So PostgreSQL never expects data on both sides from a SQL data stream, which is the communication channel, let's say, with the client. HA proxy health checks are composed by an auth request and a conquit packet, and they are sent together. And also, HA proxy doesn't wait for the greeting message. So in the SQL protocol, there is a greeting message, and then you reply to the greeting message with whatever response it proceeds. But HA proxy basically ignores it, which is it results in a communication like this. So HA proxy doesn't perform any wait to the greeting message received by PostgreSQL and performs an out request and a conquit, and then start wait. So this can have this side effect of this taking place, or this scenario taking place. That PostgreSQL sees that as at both ends of this data stream. So due to the no waiting of HA proxy under certain timing conditions, PostgreSQL could find both the greeting message and the auth request plus conquit packet in the MySQL data stream, breaking so the data flow checks that PostgreSQL has. This situation has been handled, and now HA proxy health checks are supported. So, but there are a couple of side notes that are worth mentioning. Depending on the protocol version, depending on HA proxy version, out packet can be protocol handshake response 320. This is a very old and unsupported by PostgreSQL. In recent versions, HA proxy has defaulted to handshake response 41, and no action whatsoever is required by the user. But if you find yourself using an older version of HA proxy, then you will be required to use the post 41 configuration option for MySQL health checks. And then, for the latest, the final compatibility feature, we have JDBC query batching. So what is JDBC query batching? The JDBC connector offers a feature that allows to batch multiple queries, DMLs, and send them in parallel to the MySQL server. This is performed by sending the queries without waiting for the typical server response, which in this case of these queries are OK packets. This response, this behavior is incompatible with PostgreSQL since it breaks the expected packet flow. This is PostgreSQL receives the next request from the client while processing the previous request. And that's not allowed. It's not allowed to receive a request from the client while PostgreSQL is still processing the current one. So this leads us to the first question, like, is this a configurable behavior in JDBC? The answer is historically yes. So historically, that was configurable via use batch multisend, but this was deprecated in versions in 3.0.0. So only for all the versions that 3.0.0, this can be disabled via that configuration option. So that answers with the question, what we do now? So now that the option is no longer present, JDBC decides whether or not to perform this query batching based on other protocol checks, flags checks that he performs. Because of this, our solution is that we plan to add support for this behavior to ensure JDBC compatibility. But as a acceleration, what we plan to do is to add support for receiving parallel requests for clients, which leads me to my final note, which is that queries will still be processed in sequence, yet we will allow the parallel reception of them. Now we move to a very interesting feature that is coming probably to the next major PostgreSQL release, and this is the QPS limit rules. Essentially, this feature will allow to throttle the amount of QPS that you can impose, that will allow you to impose QPS limit based on several criteria, which are username, schema name, and flagging. That correlates with the flag out applied specified in the MySQL query rules table. So, how will you control this feature? So the feature will be controlled by a new table, which will be called MySQL QPS limit rules, that will have two configuration values for controlling the matching query. Will be QPS limit, which is the desired QPS limit to impose for the matching query, and the bucket size, which is the vastness or variation that allows for that QPS limit that you have imposed. Alternatively, this can be called as depth of the token bucket. For more information about how these two parameters relate and how can you get the most out of them, you can refer to the token bucket algorithm, because it's the one that is going to be used under the hood for this implementation. So I am jumping now to conclusions. This is the list of features we have the time to go through. You have seen there has been a lot packed in the most recent major release of PostgreSQL 2.4.0, and I really encourage you to give it a try and to check it out. Also, I have an asterisk there in the minor version number because I wanted to have a side note to clarify how we do minor releases. So we have seen that multiple times our users use the major release and never get to upgrade from the major release to a minor release from that major. And I just wanted to say that we try to be very conservative in any minor release. We only pack bug fixes in them. There are iterations in which we want just to pack the things for that iterates towards the best experience of the features that we have packed in that major. So I really encourage you to upgrade to the minor release that we keep releasing, because they are just minor improvements over the features that we have released in the major. We never pack anything big there. There are very exciting features to come for the new 2.5.0, as the previous one that I have mentioned, and some others that I don't have the time to go through. We are also very excited about the coming year and what is to come. Finally, I would like to thank you a lot for your attention. It has been my pleasure to be part of this conference. I will also have a final thanks to the PostgreSQL community for this amazing year. I hope that we can have another one submit like this, the next one. And that's it. Thank you. Thank you, everyone.
Hi, everybody. Here to talk about the lost art of database design and database design considerations for when you're building applications. Right now, we are in a spot where people think that the databases are just part of the commoditized infrastructure. But unfortunately, that leads us to a lot of problems, and I'm going to talk to you about it. But first, let me introduce myself. I am Matt Yonkovit, head of open source strategy here at Percona, and you can find me on all of the socials everywhere. Follow me on YouTube, LinkedIn, Twitter, anywhere that Percona is. Check out our podcast. Love to hear if we could get some better guests. You're interested in participating. Would love you to like and subscribe to the podcast. You can drop me an email at thehoss@percona.com if you are interested. So we're talking about database design here. Let's get going. The first thing I want to do is say that a lot of this is going to be captain obvious if you have been in the database space for a long time. That's okay, because there are a lot of people out there who have never heard why they should focus on designing their databases and their database infrastructure a little better. So, multiple people can benefit from this talk. Great. So, let's start with this thought. Okay, if you are designing for success, what you decide before you write any code is going to have a huge, if not the biggest, impact on the scalability and stability of your application, right? Of the project that you're working on. So right now, as you're starting to work and think things through, the decisions you make are going to cascade throughout your application's life cycle. Now, think of it like this, okay? Some failures are easier to fix than others. If a drive fails, you replace the drive. If you need to get a bigger instance because you're hitting CPU limits, you upgrade to the next, instance size. But if you've designed a piece of crap, it's really hard to uncrapify it. Is that a word? I think it should be. So you need to go back and rebuild a lot of what you already did, and it has a massive impact. And a lot of what we do is super connected, okay? There are pieces that are connected throughout our infrastructure. Apps nowadays are no longer a single stack. They are no longer a single component. They're made up of many, a multiverse of different diverse services. And when you start to design, you need to ask yourself and decide on some simple things. One of them is, which stack are you going to be building, right? And that really starts to, what are you building? How is it going to be used? Where are you going to store data? Do you even have choices in many cases, right? So when you start to explore, what you're trying to do, you're going to decide on programming languages. You're going to decide on databases. You're going to decide on, different components, right? If you can. Sometimes if you work at a company, they might be like, you must use Java and you must use Oracle and you must use this, and right? And so they're going to dictate a lot of the choices from the infrastructure standpoint. And you need to understand where your limits are and what you're trying to accomplish before you can make some critical decisions. Now, if you are an old school developer, you probably have seen apps that look something like this, right? You have an app, person connects to a phone, browser, whatever, comes to a web server, hits database, okay? And when you look at deciding on what you're going to build and starting to think through the implications of the different technology, a lot of people look at this and they will make some concrete and generally reasonable assumptions on what this looks like and what sort of components they're going to use. I'm going to use Node.js. I'm going to use MongoDB. I'm going to, use React in the front end. Done. Boom. And that is the extent of what they've thought through. Now, the issue is, realistically, most apps now look something like this. Okay, let's assume this is a phone game or something, mobile game. Okay, so you've got an app that's on the phone. It has its core, app web server type activity. It's got a database, but then there's a third-party authentication service. There's a third-party leaderboard, or maybe a separate service that you built for multiple games. There's a chat system for the ecosystem. There's ads that you're displaying. All of these different components actually make up what you're trying to accomplish. And so when you're looking rather myopically at this graph or this architecture, it seems fairly straightforward and you can make some decisions. But if you actually look at the holistic view, you might start to figure out that, maybe there are some better choices for me to make, because this might be something that your authentication is built on, technology that's, supported in one environment and not another. Or it might be that your libraries of choice might not have the hook-ins to, certain, systems here. So understanding that, this is a bigger, broader picture and there are multiple components to consider is a critical, first step. And a lot of times what decisions are made in these subcomponents and the overall architecture, it's not up to you. And this gets into what I call stack politics. Oftentimes you don't get a choice, right? Oftentimes you will be dictated certain changes and you will have to live with them. So understanding as you start to build and design out what your infrastructure and your application is going to do, especially on the database side, and what you can and cannot do, what the limitations are incredibly important. Now, keep in mind that as you do that, you have to also understand that the small things matter greatly. So it might seem insignificant to make certain decisions, but those certain decisions can have massive cascading impacts. A good example of this is I did some testing and I was testing different Python drivers and different MySQL drivers for Python. You can see that there's actually a pretty significant performance difference between certain Python drivers and certain versions of Python. So the combination of different components can often have a pretty significant impact on the performance and the scalability of your systems. So when we go back to the big graph of this, you have to understand that each one of these connected lines, right, and each box that we see will have another set of boxes underneath it, and each one of those has to be verified and vetted that they actually work well together and that they're designed in a way that you're taking advantage of each of those systems appropriately. Because if one of those boxes tends to use Python 3.10 in the MySQL connector, where another one uses MySQL 3.10 with the MySQL client, a performance difference of almost 70% difference could create some artificial bottlenecks. So understanding those components, how they all work together, is incredibly important. Now, we're going to talk about the actual physical database design in a second, but I wanted to point out how incredibly important the entire ecosystem is in understanding the infrastructure and how the components play together. But I also want to point out that, especially with this particular slide, that sometimes just assuming things work right doesn't necessarily mean they will. And this is a philosophy that you'll often see when you're building out your schemas, you're building out your applications, you're building out your code, that people will assume just because something works means that it works well enough and it won't break or it isn't problematic. I recently had a problem with some plumbing, and the plumbing was working fine for 2 years, but underneath the floorboards, it was leaking water. And it wasn't until 2 years that enough had leaked to cause a problem. Doesn't mean that my plumbing was set up correctly. It just means that it worked for 2 years without manifesting the real problem that it had. And that often happens in the application design space right now. And so understanding all the different components and getting a clear picture is fundamental to understanding how you should build the data infrastructure as well. Now, you don't want to just put blind trust in technology, okay? You just can't assume that everything is going to work out of the box. But I do want to say most of the success and failure of projects and of applications is not due to the technology choices. It sometimes is, but it's very rare, because when you choose a database or a cloud provider or a JavaScript library, okay, all of these components within the stack, they can be made to work in a variety of conditions, right? It really is not about whether they can do the work in many cases. It's about how you've designed and implemented it. Because an application or, a game or whatever, its success is tied to the end user experience, not necessarily what libraries you picked. And part of the job as architects, as designers, as infrastructure folks is to make sure that we have set up the systems and designed the systems that lead to the greatest path to, customer happiness, delight, whatever you want to call it. And that means that we're looking at things like availability, security, performance, right? These are the things that are going to impact the end user experience, and that's what matters more than anything else. And looking specifically at the database, there is a database out there for all kinds of different workloads. Okay, I'm not going to get into which database is best for which workloads. That's beyond the scope of this. But I do want to point out that you can make any database work for almost any workload. Doesn't mean you should, because, it's like, putting a tiny engine in a sports car, right? Yeah, it can go down the street. It can go 50 miles an hour, but the car was supposed to go 300 miles an hour. You're not going to meet the expectations. And so when it comes to, choosing a database or a cloud provider, you have to understand that the choice of one over the other isn't going to dictate your success. It doesn't matter how awesome they say that they are performant and scalable and have all of this other stuff. That's wonderful. That's great. But if you design it poorly, you're not going to be able to achieve the level of success that they are telling you you can. And that's critical. So it's really about trusting but verifying. So when someone says that the scalability of my database is 1,000 times greater than any other database on the planet, you can trust them on that, but you need to verify it, especially that it does in your environment. Same thing with cloud providers, same thing with SaaS providers. Anybody who's in that architecture design components that we had out there, any component there, trust but verify that you're getting what you expect out of them. Because oftentimes you might not be. And when we have these technologies that we're implementing and adding into our ecosystem and our infrastructure, you have to understand that even though many may claim to be fully managed or self-managed or zero management, you still have to have someone who is responsible for it, especially in the database space, okay, but in other spaces as well. So who manages it and understanding who is ultimately responsible for those activities when it comes to, ensuring and trusting but verifying you're getting the results and the things that you want. Who is it? And what about the cloud? Well, we'll get to that in a second, but, you still need these functions in the cloud. It just changes maybe what some of their day-to-day responsibilities are. So as we start to think about who's managing, your databases, who's managing the technology, we should probably start to think about like what sort of database we want to choose or use for this particular application. And those are going to come down to specific questions, right? You're going to start looking at what components you need to rely, that are going to connect to the database. How are they going to use it? What sort of, skills do you have in-house? What happens if the database goes down? What happens if you lose a few seconds worth of data, right? So all of these questions are things that you need to think about before you choose the database technology that's part of your stack, and that's going to drive each one of those components. It might be multiple databases. Each one of those components I showed you might get their own database, might be a different technology. You should ask these questions for all of them. But not only do you want to understand the database, side of things from a, how is it going to be used, but you also have to understand the capacity planning side of this. Okay? How much data will you store? What will it look like in 1 to 2 years? Is data transient? Is it going to come and go? Do you need streaming? Like, thinking about that architecture picture that I showed you, right? How data is flowing through them and how the data is stored in each one of them, that's going to help you design a better application. It's going to help you pick the right database. It's going to help you design a better database structure for your data. All critically important. All critically important. You also need to think about that ecosystem again, right? So we go back to that picture of, all of the different applications, right? So we go back to this guy right here. You look at this. How are third parties going to access your data, right? How are third parties going to, pull data out, use it, retrieve it, do whatever? One too far. So third-party plugin software, how you need to integrate. Think about it, plan for it, understand that that's critical. Now, when we talk about databases in the clouds, you have to follow that same trust but verify, and you have to understand you still need to manage. Because if you aren't managing, then you are potentially scaling your system by your credit card, right? Because there is a shared responsibility model. So again, trust but verify. So just because you've chosen a cloud provider to manage your databases does not mean that you are free from designing, architecting, or ensuring that it is working properly. Okay? All critically important things for you as you design something. Daniel Nichters gave a presentation and has a book out on efficient MySQL performance where he published this graph. I grabbed it from his presentation. Excellent kind of visual just to kind of outline what sort of things you're responsible for versus the cloud. And so that's something that all people who are building a new app should consider. Now, you might also be considering whether you want to run your cloud or your database infrastructure on, Kubernetes or in a cloud native type way, right? And so you can, and a lot of people are starting to be very successful at doing this. But you need to consider, a couple things, right? So each of the databases will have different levels of support for Kubernetes and will operate slightly differently. And the scalability will also be very dependent on the technology, right? So how you're looking to grow the application. And remember, I got to some of those questions about, hey, we're designing, the system. What does this look like in 2 years? If you are looking for sharding and scaling features, maybe MySQL and Postgres out of the box don't have that. Maybe you need to add extensions. Maybe you need to look at, some alternatives. So the workload patterns and what they'll look like in a couple of years will help you choose the right technology. Now, when we talk about clustering, sharding, there's this concept of new SQL. And so I wanted to provide a word or two for those who might not be aware of what it is. But it's something that is important. So first on this is to understand kind of the concept between sharding and clustering. Okay. And so a key concept when we're talking about databases and data growth is the more data you store and use, the slower your database generally gets. I'm just going to throw that out there because databases are heavily dependent on what can be stored in memory, and the more data that's in memory, the faster it is to access. There's definitely, memory faster than disk. It's a universal constant that's been around forever. So you want more stuff to fit in memory, and the larger your data set, the less can fit into memory. But also, the more data you have on disk, the more your backups take, the longer it takes to do operations, the more costly it is. So there's all kinds of implications. So basically, the more data you store, the slower the database becomes. Most databases all do this. Now, there is this concept that's called sharding. And what sharding does is it takes your data and it breaks it up into smaller data and spreads it across multiple machines. Okay, Mongo, for instance, has built-in sharding into its database. Postgres and MySQL do not. However, there are new databases or new technologies that bring sharding or clustering like solutions. Now, the difference between clustering and sharding is taking servers and combining them to all appear as one. So you have multiple servers that all appear as one, whereas sharding is splitting your data amongst multiple nodes. Now, when we talk about some of the new school databases that are out there, there are new databases that are coming along that are implementing a sharding plus clustering type setup. So TiDB, Cockroach, Yugabyte, great promise, excellent performance on some workloads, but sharding requires your application to be written and designed a certain way to take advantage of it fully. And it assumes that certain functions or features or things aren't necessarily done within that particular database, right? So when you think about sharding, let me go back to my sharding slide really quick here. If you're going to select an aggregate across multiple shards, and let's say you have 10 shards, you will have to go down to each server, pull individual pieces of data, then aggregate them back up, and then continue to munge them up until you get the final result. That's not necessarily great for sub-second transactional processing. It could be fine to incur that impact for reporting or analytics workloads where it doesn't matter as much. But there are some fundamental things that you just need to be made aware of. Certain things aren't going to work right, especially if you're not selecting off of the shard key. That's probably a better example here. If shard key, for instance, is last name, and this is how your sharded system or one of the new SQLs set up is to use that last name or whatever, and you select first name, then you're going to have to hit all the shards and then aggregate that data back. So this is just a small example. Not all of them have the same limitations, but that type of thing. Now, sharding, there are systems like Vitess, which is an extension for Postgres, Vitess, which is MySQL framework, and then Citus, which is a Postgres plugin. Sorry, reverse those, where data is split amongst the nodes, and it requires more structure around the database. It's not a database in and of itself. Now, TiDB, Cockroach, and Yugabyte are compatible with open source technology. So TiDB, MySQL compatible, Cockroach and Yugabyte Postgres compatible. So they have compatibility, but they are not 100% MySQL Postgres, whereas Vitess and Citus are Postgres and MySQL, just with additional technology around it. And then I mentioned there's also other technologies like Mongo, which has its own built-in sharding as well. So mileage will differ on these, but these require you to also think schema structures, workload, data access, all of those things are universal, whether you are using one of these technologies or not. And that's where it really comes down to that design of the systems, and the database matters. Okay. I asked our engineers, our support engineers, our managed service engineers, what's the number one issue that they see over and over again? And you know what? Their number one issue is always poor database design. Okay. That's the most common issue that causes the most problems amongst the most, or the largest subset of users. And that has a variety of, causes, right? Bad data type selection, poor schema design, over-reliance on ORM frameworks, under or oversized hardware, storing more data than is needed. I've also heard that the Rube Goldberg, infrastructure design also comes into play. That means something overly complex, you should never use it. And that gets back to a lot of what we were talking about, those understanding the different components and how they interact with one another to choose the appropriate database. So why do data types matter? You might hear this harped on quite a bit. A lot of people might be like, I'm so sick of data types. Just shut up about data types. I'm just going to use whatever. But remember, I said earlier, memory is faster than solid state disk, which is faster than rotational storage. All databases are memory hungry, okay? Because the performance is when your data is in memory. That's where you're going to get your greatest performance. So the more data that you are storing on disk, the less can fit into memory. And the wider or the fatter the rows are, the less rows you can store into memory. Okay? And this comes at a time when we're not only talking about data types, but we're also seeing an explosion in the amount of data that people are just physically trying to keep around. We're data hoarders. We are keeping data forever, and we never want to clean it up. And so we've got more data, and we know that we need to store things into memory. So when we talk data types, it matters quite a bit. So a good example of this, using MySQL. If you're storing 1, 2, 3, 4, 5, 6, you could store that as a varchar, or you could store that as an int or a big int. Obviously, you would say, well, why wouldn't you store it as a big int? You'd be surprised. It happens. But in this case, you're talking about the difference between 4 bytes and 21 bytes. Well, you might be like, that's not that many. But over 100 million or a trillion data points, that adds up to a significant amount of overhead. Now, thankfully, the databases themselves have several different types of specialized data types for all kinds of different things. Like there's a data type for storing IP addresses. There's a data type for storing, common sets of data. Each of the data types are designed to improve the footprint or decrease the footprint of the data that they're storing and make it more efficient to process and handle that data. So make sure that no matter what database you're using, you're thinking about that. But let me give you an example of why this really, really matters. Okay. We worked with a social media company, really big social media company, still around. You probably use them every day. Won't say who they are. But they were storing everything that they had in as your email address. So everything was primary keyed or keyed off of your email address. When you sign up with your email address. It takes that email address, it creates your user based on, the email address as the primary key. It creates other information using all of the linkage with the primary key. Now in MySQL, which this happened to be, MySQL is even a little more conscious of using, the right data types, especially for primary keys, because the primary key is stored as a pointer back in every subsequent index you create. So imagine you have this 100-byte, field that is your primary key, and then every subsequent index, even if that index is what is your age, you're just doing, I want to get everybody who's under 18. It will also then store everyone's email address. So you can see how that blows up. Now, for that particular company, they were experiencing some significant problems with not only performance, but also runaway storage costs because of this. And so in the end, what we ended up doing was using the primary key as a unique key, taking the email address, making it a unique key, and then using a CRC32 hash, so that becomes an integer, as well as an auto increment ID as the primary key, which reduced their space. I think it was like 3 or 4 times what they had. So it was a 3-4x reduction in the space alone, and also a 2-3x improvement in all of their query performance. And this gets back to, and we've written about this quite a bit. I would encourage you to go check out our blog for using UUIDs as primary keys, why it's bad. But a lot of applications, especially ORMs, might use a UUID as the primary key for tables. And in the case of MySQL, that is a really inefficient use. It also has a cost in Postgres as well. It's not as significant as MySQL, but it is substantial. So I would encourage you to watch out for using the appropriate data type and making sure that you're using that. But half of you out there, or maybe a quarter of you, are saying, I don't care about schemas because I'm schemaless. And here I'm going to tell you that is marketing material. It is fluff. I don't believe it. You should not believe it either, even if you are using MongoDB. It is not schemaless. That's a quote. You can quote me on it. When we talk about schemaless, we're talking about unstructured data. We're talking about that flexible design. And the issue here is you are trading your flexibility for performance and scalability. And as your data volume increases, these quote-unquote flexible systems really, really, really slow down and often will get to the point of being non-functional. Because you are still having to validate that the data is in some sort of structure at some point or another. And so if you are not enforcing the validation, the databases themselves have some logic behind the scenes, the schemaless databases, to try and do some minimal validation. And so the more crazy the structures get, the more work it has to do, which slows things down. But also, a lot of times, even beyond just that happening, you have to push the logic to do the validation up to the application. And so you might be doing double validation in some cases. And that's why most vendors who have a quote-unquote flexible schema or schemaless type of implementation recommend some sort of schema validation and, say that that is absolutely a best practice. So keep that in mind, that even if you are saying, oh, I'm schemaless and flexible, you're just forcing something else to do that, that validation, and you lose a lot of control over your structures, and you're going to have to write code to potentially fix some weirdness. So there is that. Now, as your schema and query design goes, you will start to grow, and you'll eventually outgrow a single server. So how are you going to scale? And understanding that is very important when you're designing your application early, because you can start to think about, like, can I do read-write splitting? Can I take and move data to shards if I want to go sharded later on? Okay. If as I grow, maybe how I'm selecting the data out of my system needs to be changed. I say avoid select stars. I've been at companies where they select everything and then throw away everything but one column, and they oversaturate their network pipeline. Well, as data grows, especially in the quote-unquote schemaless side, where your schema might start very narrow and selecting all the data might be okay, as you get bigger, or as you add columns even to a relational table, a select star might become unruly, right? Because let's say right now you just have first name, last name, email address, but then all of a sudden you add a binary column to store someone's picture, and you're using select star. All that binary column is going to get selected and brought to the application, even though the application might not ever use it or need it. And so that could be a significant overhead. Now, Of course, we want to talk about indexing because we can't not talk about indexing, because indexing is probably going to be the number one thing that everyone looks to when they're looking at query performance problems. Assuming that you've chosen the right data setup, you've chosen the right databases, you've set up the workload, you've analyzed the different components, you know how they work together, you're probably at the point now where you've got some queries that are a little slow. So indexes are good. Too many indexes are not good. Okay. There is an overhead to adding indexes. It's really on the insert, update, delete side that you're going to see that overhead really, start to creep up if you have too many indexes or have over-indexed. But you don't need an index in every column. You should be looking at what is being selected on most frequently and how it's being used, and that's what you should be looking to index. And you should check, the statistics, whether you're in Postgres or other databases. They all have slightly different ways to do this. Which ones are being used, which ones aren't? If they're not being used, why are they out there, right? You can drop those. And know that each database has their own index types, and there could be indexes specifically for workloads. So Postgres has several that are really interesting for different types of workload. And so understanding how your data is going to be accessed again and how it's going to be used across the whole application, you can choose better indexes for that. Now, let me finalize or wrap up with this, okay? Recapping, if you have the right design, that means that, which database is going to be appropriate for what you're trying to do. You're going to understand the pros and cons of the environment. You're going to understand the workload, the growth, the access patterns, right? You're going to understand how data is being accessed through the system and where it's going to go. And then if you have that, then you can start to think about the data types and the schema itself, and understand that space matters. That's going to have a direct correlation with performance, and you're not going to overthink your structures. And eventually, you're going to then add the right indexes. And so if you're following that process, you're going to have a structure that is not only going to work for you, but it's going to be very scalable and efficient going forward. Thank you for hanging out with me today. Hopefully that was interesting for you all. And don't forget to like and subscribe here at Percona's channel. And check out our podcast. I'd love to hear your feedback. Thanks a bunch.